marathon festival style event that we are producing. And when I say first, that's an indication that we have more planned. As of right now, we have 2 more concepts and lists of participants that we're gonna, once we rip this one, we will do a couple more. Probably not very quickly, because we want to let people have the Coliseum Hackathon and current shipping cycle done, but we will continue to do this. And we'll talk about why in a couple minutes once we get formally rolling. And by the way, folks, please disable your note takers. Those of you that know me know that I have like a major note taker allergy. I break out in being very annoyed. And of course, we don't want to share this Gmeet link around just because we want to make sure we have a good, calm in-call model. Okay, we are live. It is 9 a.m. Welcome, everybody. Welcome to Toolapalooza 2025. We're excited to be here. I'm here with my co-host, Brianna. Brianna, go ahead and say hi and introduce yourself.
Hey everyone, nice to have you all here to learn about tooling on Solana. I'm Bree. I work for Solana Foundation for Developer Relations. So great to meet everyone. Yeah.
Awesome. Yeah, so let's spend a few minutes here kind of setting the stage and giving everybody just a little bit of a warm up before we get onto our first guest, which is Magic Block. A little history. You know, a lot of us on this current call remember the days of the bad DevEx and the not so great dev tooling on Solana. And of course, if you talk to some of our friends from other ecosystems, they'll say it's still the same. They're the same people that post on X about outages, which is distant history in the past. But I remember when we first started over 3 years ago, it wasn't that great. And an early conversation that I had with somebody at Foundation was, you guys need to build truffle ganache for Solana. Okay, so, you know, we went and researched that and we made it a project. It was called Lava. And Lava evolved because it wasn't what we needed. We didn't need to imitate what some other ecosystem did. We needed other tools. We needed other things to make the Solana DevEx better. So even Lava changed over time. And as you're going to see today, the narrative of the DevEx on Solana being less than anybody else is old. That is an antiquated, old myth. Because today, you're going to be able to judge for yourself how good the tooling and the developer experience on Solana has become. And we've been able to see it. I mean, Brianna, when you first got here, I mean, to now, what's your thoughts?
Yeah, a lot has changed. So I'm actually kind of new-ish to Solana. I joined about 1.5 years ago. And just within that 1.5 years, so much has changed and it feels like I've been here for ages. So it's great to see that things are just always actively being developed and iterated on. And when we see like any type of issue in DevEx, we want to try to find a solution as fast as possible. So it's great to see things just evolving a bunch. So yeah.
Yeah, and I mean, of course, I remember when you joined because you were with us at that time. You know, the interesting thing about this is and shameless shill for you guys, there's no developer relations team in the whole industry that can match what the Solana Foundation does in leading the way and inspiring people and supporting the development of tooling and improving of the developer experience. I mean, invariably, not a week goes by, or probably a couple of days without you or Jonas or Jacob or somebody saying on Twitter, tell me what your biggest problem is, because we want to fix it. That's a huge part in why we are all here today, which is, the support and the emphasis and the focus and the inspiration to, really get better at this part of it. Because, what we're seeing is the influx of new talent from Web 2 and other ecosystems is massive right now. We saw it with our builders program admission process just in the last couple of weeks, where, the next 100 people that would have usually gotten into the builders program with us, they usually get in. They got moved out because the quality is just getting better, which is why we actually started the pre-builder. So this focus is important. And before we get rolling with like the formal, Brianna, I know you did an anchor testing process this past week. You want to talk a little bit about that and how that could actually help the builders on the call right now?
Yeah, definitely. So like how we talked about, we're always just trying to find different ways to make things better. We're looking for a testing framework to push forward, just to guide people. As you're going to see throughout the rest of this call, there's a lot of different ways to write tests on Solana, and we're trying to just make things better. So one way for testing is LiteSVM. LiteSVM is essentially a testing framework that doesn't have an RPC layer, so it's a lot faster. And it just simulates the SVM on your machine, and you can test Solana programs that way. But when you do write LiteSVM tests, there's a lot of knowledge that you need to set up the program that you don't necessarily need to understand with Solana programming when you're just writing Anchor programs. So just for some context there, if you're new to Solana, Anchor is a framework for writing Solana programs that abstracts a lot of the complexity away for developing. So things like having to deserialize and serialize accounts into data that's going to be stored on chain, you don't have to do with Anchor. It's all hidden under macros that Anchor provides for you. Another thing is when you pass accounts through instructions, typically they have to be ordered in a specific order for it to correctly execute on chain. Anchor figures that order out for you. So a lot of those concepts in Solana programming, you don't need to understand when you are writing Anchor programs. When you write LiteSVM tests, you do. So to be able to get rid of that learning curve, where if you're just writing Anchor programs and you know how to write Solana programs with the Anchor framework, you can now write LiteSVM tests with the same knowledge and not having to now understand how to deserialize accounts or order accounts or just little other additional concepts just for testing. So there's now an Anchor LiteSVM crates that I've been working on. I announced it earlier this week, but check it out. It's on crates.io. It's Anchor-LiteSVM. And I have a few examples. I'll post them on my Twitter. I don't know how else to post it. So my Twitter's BreeMigs, just a little show there, but I'll have some GitHub repos that are linked that just show the difference between LiteSVM test or LiteSVM test using the Anchor LiteSVM crate. And it shrinks your code for testing about like 50%. So yeah. Just some additional help for writing tests and making things faster and easier and shrinking that learning curve that you need. So
that's great. And I mean, folks, as always, if you see something, say something. Make those open source contributions. If you can improve something that you see out there, go ahead and act. Everybody is a contributor as long as you act on what you see. And, one of the things that we say a lot is, and this goes back to like funny, the AA rooms, the new person is the most important person in the room. So if you are newer to Solana development, you probably have one of the most useful lenses on how to improve new developer experience and new developer tooling, because you're in it. So if you see something, say something, leave imposter syndrome at the door. These are things we talk about all the time, you know, because nobody can go back and say, I'm going to pretend I'm new and I'm going to pretend I know nothing and try to create tools and experiences for the new builder. So again, keep track of what's working for you and what's not, and let's try to make the not stuff go away for the next person that comes around. So with that, let's actually go back to the beginning a little bit, which is only 8 days ago when this concept was born. We usually, during hackathon season, Turbine has done some special workshops, and you know, just to try to help people that are building. And some crazy old man in the middle of the night was like, Toolapalooza. So if you know what the reference is there, back in the early 90s, yes, I was already of legal age in the US to drink, and did. There was something called Lollapalooza, which was a huge music festival with top talent. The best bands decide they were going to do this, you know, festival and travel around, do this, you know, this festival thing over the course of years. So here we have, you know, really excellent tooling, total rock star engineers and builders in Solana building them. And instead of trying to spread this out over the course of a week or two, we, in our infinite insanity, decided to do it all on one day. And in pure Solana style, we saw a need, we had an idea, we let it rip. We didn't ask anybody for permission. We didn't negotiate contracts. We didn't ask for any funding. We just did it. We got a bunch of mission aligned people to say, yeah, this is a good idea and we want to participate. And actually, after we got this rolling, I think Varma, who works with us at Turbine and is a grad, you know, Varma and I got rolling on this fast. I think by the third day after the idea, we had people that we hadn't thought of inviting, reaching out, going, how can I do this? How can I do this? How can I do this? So again, that allowed us to say, well, we could do more of these. What you'll see when we start in about 4 minutes is, as we try to galvanize these 8 different tooling options, concepts, tools, you know, our goal is for you to understand as best we can, and of course these are recorded, how to use them together. You know, we know that there's a lot of fragmentation, and the next step, once you have great tools, is how do we show people how you can use some of these things in tandem with one another and understand where to use them and how to use them and so on. And so we asked everybody presenting to follow what we call a 5W how process. You know, when you're talking about your tool, you know, what is it? You know, who uses it? When would they use it in their development process? Where would they plug it into their package? Why would they use it to improve their application? And then the big bulk of these sessions will be how to integrate. So we do have a handful of folks on the call here, and we also have a handful of Turbine folks in the actual YouTube chat. So as our first one, we expect this to be perfectly imperfect. We'll do the best we can to get the questions, but you'll also be able to see who these people are presenting, what their Twitter handles are, and be able to ask questions there. We would obviously love to see hashtag Toolapalooza25 go viral on X. That would be very, very cool, a lot of fun, and you could say you were here when. And every day we see what people need, and today we're going to give you what you need. And if we fall short, give us the feedback, and we'll do the best we can to support you. There's a lot of organizations and groups of people and individuals across Solana that want to help. One of the best things that we've seen really in the last 6 months is people that are new to this ecosystem are saying Solana embraces you and brings you in and helps you. And it's one of the things that really resonated with us when we started here a few years back. We felt that support, and the only way to continue to grow is to pay that forward. So that's what we do. So okay, so here we go. We're gonna start with Magic Block. Okay, and he's getting himself set up and getting his tech all ready to go there. And so a little bit about Magic Block and Turbine. I met Andrea, who's the co-founder with Gabrielle, on the super team yacht in Amsterdam at Breakpoint a couple of years ago, coming up on 3 breakpoints ago. And they were pretty new, a little further along than where we were, but we had a great chat. We basically just left it with the proverbial, let's just keep in touch. And when the time is right, we'll do something together. And we did. We ran a Magic Block cohort, and we try to use the ephemera roll-up and the tooling in it, everything we can. It's in a lot of our programs. And of course, Magic Block is doing incredibly well right now. And so we're going to start off with Magic Block. We have Andy, who's DevRel at Magic Block, that I want to introduce and turn the show over to. Andy, are you ready?
Hey guys, yeah, just give me 1 second here. I'm going to attempt to present. Does that look okay to you guys? Figma's having some trouble on my phone actually, or trouble on my computer for some reason. So I'm trying to present here on my phone. How does the resolution look to you guys?
It looks good on the Meet, and I'll check it on the YouTube, but go ahead and rip as if it's perfect, as if it's just in time, real time, transactions on a roll up.
Awesome. All right. So yeah, thank you guys for inviting me here. My name's Andy, and I'm DevRel at Magic Block. And so actually, despite having lived in Chicago for 2 different times in my life, I never got a chance to go to Lollapalooza. So this is kind of like fulfilling my dream for me here. Super excited to be here and get to speak with all of you. Thanks Turbine for, again, inviting us to speak. I think that love what you guys are doing. Amazing work getting all these ecosystem devs from both Web 2 and other Web 3 ecosystems to come and join and learn all about Solana. More importantly, thanks everyone watching for being here. The schedule looks absolutely cracked with great speakers and teams coming up. So I'm excited to stick around myself after and learn some more about Solana tooling. Okay. So, actually, sorry, 1 second, guys. I'm going to try presenting from the better version of this. Let me know if you guys are able to make that switch. There it is. Perfect. Yes. All right. So who are we? We're a team of nerds, and we believe that fundamentally everything should be on-chain. So we're building the infra and the tools that you need to make that possible. So why should we use Magic Block? Solana, I'm sure you guys all know, is already incredible. It's got high throughput, low fees, and it's decentralized and secure. There are a ton of apps on Solana that have already found product market fit, from launch pads to dexes to prediction markets. Where we focus is on all the other use cases that are currently unfeasible on-chain. And this is for multiple reasons. One main one is real-time execution. There's a category of apps where if you have latency more than 50 or 100 milliseconds, it kind of ruins the experience. This involves gaming, high-frequency trading, and DeepIn, among many others. Many of these experiences do exist on Solana, but they need to make some trade-offs in terms of design and UX to accommodate for the block times. And the second main problem are transaction fees. Solana has low fees, but imagine a use case like a social network where every single like or every interaction is a transaction. If you do the math there, it soon becomes extremely expensive to either sponsor or scale the gas fees as your app gets usage. And these are the core problems that we're solving with what we call an ephemeral rollup, among many others. Another big problem right now is privacy. There's no great solution on mainnet that can scale well today. I'll briefly also present on how we tackle that problem with ephemeral rollups. So I mentioned just now how we offer a bunch of other tools to supplement building apps. So for us, we offer things like pricing oracles to give price feeds partnered with PithLaser. So this means that you can get prices for any number of instruments like the price of Bitcoin, ETH, anything, as low as 50 milliseconds per block. And we can also set up custom ingest if you want to have any kind of data you want, either on-chain or off-chain, being put on to the blockchain such that your smart contracts can interact with them. Something else we offer is a crank. So we have a built-in crank that you can schedule to make transactions. So right now, say you wanted to make a transaction every hour in your game. Maybe it's like you pay out some fees. If you wanted to do that, you need to set up some off-chain infrastructure to once per hour send that transaction, and that's going to be liable to all different kinds of things happening. Whereas for we have a native crank built in so that you can directly schedule it on-chain using a network of keepers to execute your transaction. And this plays well with our next plugin, which is a high-precision clock. So for a long time, many people have talked about Solana's clock being a little low precision, given that there's 400 millisecond block times. But I think there's actually SIMD to change it to milliseconds coming up soon. I saw one getting proposed. So excited for that. For us, yeah, we have right now a very high precision millisecond-based clock so that you can confidently schedule your transactions and know when your transactions are actually being called. We offer oracles for VRFs and AI. So what that means is that getting verifiable randomness on chain is actually a pretty hard problem, and as well as getting AI responses. So what that means is that you can send a query on chain and it gets fulfilled by an LLM of your choice, and the response is returned to your program on chain. So you can, for example, in a game, have an NPC that's hooked up with some AI, hooked up with some prompts, and have players be able to talk to the NPC, again, completely on chain. Finally, we have some customizable fees. So for example, it's gasless, but if you wanted to take fees, you can actually take it in your app's native token. So say back to the social network example, maybe it's like as users interact and get positive interactions, they can get rewarded in your native token. And they also need to use those tokens to pay gas for being part of this. And that creates this self-sustaining feedback loop, this positive reinforcement. And the result of all of this is a contract where you can access real-time speed in a gasless environment. So here's an example of one of the teams building on us. And what's really cool here is that every state transition, every player movement, every player's position state, it's all executed on chain in real time on an ER. So if you look at this video, you can see that on the right side, you can see the transaction streaming by. So each of those is an on-chain transaction. And I don't know how good the resolution is, but you can see that each of them takes about 60 to 100 milliseconds to execute end to end. So I've told you a lot just now about what you could do with Magic Block, but what exactly is Magic Block? So at Magic Block, our flagship product is what we call an ephemeral rollup. So how ephemeral rollups work is that you still write your smart contracts as you would on Solana, whether that's in Anchor, Pinocchio, or Native Rust, and you deploy on the main chain, just like a normal program you deploy on Solana. Then, optionally, within your instructions, you can tap into some of these features that I talked about earlier You can think of it as a main thread. Your main thread is your Solana program executed on Solana, and this can optionally spin up extension threads that have these injected features where they can do computation, and then you can close the rollups, take the results, and orchestrate everything from your main program. And as I mentioned earlier, this includes price feeds, cranks, a way to scale latency and transactions, and pretty much all the features you need to build any sort of app. How we like to think about it internally is kind of like a road. And so the road is Solana, and it's overall a very nice road. However, there is a speed limit of 400 milliseconds, constrained by the fact that they need to do consensus across the world, which again is amazing. And this is great, but some people want to go even faster. So we see Magic Block as a highway for these accelerated transactions. So while on Solana, every 400 milliseconds a block is produced, blocks on an ephemeral rollup are around 40 times faster. So you're driving on the Magic Block highway in parallel to the main road, just faster, and eventually you'll get back off onto the main road. So here's how it looks in action. On a given block on mainnet Solana, you delegate to the ephemeral rollup, where you get to do your transactions faster. And when you're done, you bring the results back on the main chain. So an example here, to conceptualize it, would be, say you wanted to start a chess game on mainnet. You delegate at the start, go through the game with the ephemeral rollup with fast response times and no gas fees. You're playing like bullet chess up there. And then you undelegate back once the game is finished. You can note down the moves that were taken on chain and the result of the game. But all that goes back to Solana is actually this transcript of like what happened. So how does this work? You might notice that I just said the word delegate. Delegation is the backbone of how Magic Block's ephemeral rollups work. In order for transactions to be executed in real time, accounts need to enter and exit this highway I just told you about. So how does that work? Magic Block utilizes something called delegation, and this is actually a native Solana function. So before transactions can be accelerated, the accounts need to be delegated. This means that the ownership of the account needs to be transferred from the original program to the delegation program of Magic Block. Afterwards, transactions that are usually submitted on Solana can be submitted without change to the ephemeral rollup and executed in real time. So on demand, these account states can be committed back to Solana or undelegated by transferring ownership back to the original program. So this is a detailed view of the life cycle that I just showed you. On the bottom, you can see there's the Solana main chain, and on the top is Magic Block syncing to the main chain as fast as every single block. So you can sync as often as you want, but you don't need to sync if your program does not require it. So validators can commit optimistically the state from the ephemeral rollup to Solana, and anyone can challenge these state commits with a proof to reject the state. I'll go into more detail later, but just to show you now, like all you need to upgrade your existing smart contracts is to add two simple functions to your code, a delegate and a undelegate function. So here's an example of doing it in both Rust and Anchor. After adding these delegate and undelegate commands, the main complexity becomes managing the connections. Your app needs to keep track of whether your account is currently delegated or not in order to know where to send your transactions. Thankfully, we created a solution for that. We recently released something we call the Magic Router. Normally, when you're using Magic Block, like I said, you need to keep track of the state, whether your program's currently delegated or not, so that you can know whether to send your transaction to either your Solana RPC or the Magic Block RPC. What we created was a router where you can send all of your transactions, and then based on the metadata of your transaction, we will automatically route it to the correct RPC. So under the hood, what we do is, you send us a transaction, we check the metadata of the transaction to get the writable accounts. After getting the writable accounts, we check if all the accounts are delegated, and if so, we route it to the ephemeral rollup, and if not, we route it to the base chain. So to close the loop on this sort of mental model of delegation here, right now where we're at is that you simply send all of your transactions to this one RPC, the magic router, without having to worry about anything under the hood. And based on where your program actually is, we route it to the right place. And while using this is optional, we found that using it makes Magic Block much simpler. You should note that here, like in the diagram, you can see that there's like the 400 millisecond and 10 millisecond latencies for Magic Block. So this doesn't include the end-to-end latency because, you know, in the real world, when we send stuff, there are networking delays. So it's like from my computer, you're going to probably add, depending on where you are, to the current like Solana leader, or for us, the co-location, it's going to be adding maybe like 50 to 100 milliseconds. And that's just due to, you know, the nature of the internet. And so when you connect with our router, you get this co-location. And what that means is that when a user delegates, it will delegate to their nearest Magic Block validators. And we have validators all around the world. And they get the benefits of this co-location with the validator, minimizing their end-to-end latency. The delegation record is then preserved on-chain. And while they're delegated, the router will actually use that record to automatically route transactions to that ephemeral rollup. Again, just making sure that users get the smoothest possible experience. Earlier, I talked a little bit about verifiable randomness. While we don't expect it, we didn't expect that this would actually become such a huge thing. It's now one of our most used products. We have it both in the ephemeral rollup and on mainnet Solana. So much that we got it formally audited a couple weeks ago. So why exactly is randomness hard? So in modern computer systems, when you call a random function in like JavaScript or C, you're just asking the machine to give you something that feels random enough. Most systems use what's called a pseudo-random number generator, PRNG. And what these do is that they take an initial value, call it a seed, and they run it through an algorithm to spit out numbers that look random. But they're not truly random. If you know the seed, you can predict every single number it will ever generate. And that's fine in most scenarios. Whether it's like games, simulations, flipping a coin, PRNGs are generally good enough. But this becomes a massive problem on blockchains. Because blockchains are public, deterministic, and adversarial, meaning that people will do whatever it takes to make money on the blockchain. And you see this come in all ways, in like MEV, in scams, like, oh, you know, when you get these like anonymous people who can do whatever with no repercussions, you generally get people that are antagonistic. So you might think that something sufficiently random, like the block hash or timestamp, could work. But if there's enough money on the line, say you're flipping a coin to win 1,000 SOL, validators can and will rig it. All they need to do is wait for their turn to produce a block, their leader slot, and they can simulate a bunch of outcomes and then only publish the block if the coin flip goes their way and win 1,000 SOL. So how does Magic Block's VRF work? First, your program does a request for randomness to the VRF program. And what this does is add a randomness request to this queue, this on-chain queue. Next, there's a network of validators working to fulfill that request. So when a validator fulfills a randomness request, it also signs and submits a proof, proving that it generated it with the correct inputs and that no cheating occurred. The proof is then validated on-chain, and if valid, the VRF program calls back to a function you set in your program, letting you use the randomness however you want. So let's look at it from the perspective now of like, how might someone cheat? Can the program cheat? No, because the player can't mess with the randomness because it's generated outside of the program. The randomness comes from a callback CPI, and our system calls them, not the other way around. So they can't influence the result, reject it, or re-roll if they don't like the result. All right, how about the Oracle provider? Can they cheat? Still no. We use a VRF, a verifiable random function, which means every random output comes with a cryptographic proof. So the user submits a commitment, which is like a hash of something they know. So for us, it's like slot number, slot hash, Unix times, a bunch of stuff. And any result must verify against that commitment. So if the proof doesn't verify on-chain, the callback fails. The randomness is discarded before it ever reaches the user. Okay, so then what if both of them collude? What if the player works together with the Oracle provider to try to cheat the system? Still no, because the player locks in the request before the randomness is generated. The commitment hash ensures that the result is baked in before anyone sees it, even the provider. And so think of it like you're sealing an envelope with the results before the dice are rolled, and then checking afterwards if those matches up. So first, let me see if I can show you guys just a quick little demo here. Let's see, present something else. Yeah, that's the one I want. All right, so this is something that we've built to demonstrate our verifiable random function. So the idea here is that you can roll for these character stats. And so you can see that there's like an attack stat, defense stat, dexterity stat, and that say that you were making a game and you wanted people to be able to roll random characters. So here you're not only rolling the stats, you're also rolling what character class they are. So we can take a look here at the on-chain, what is happening on DevNet. So what's happening here is that let me try to make this a little bigger just to make sure people can see. So you're going here and you're calling this roll dice function, and that's requesting randomness from our VRF program. And so let's see if we can take a look here at our VRF program and see if we can find an actual callback. Is it this one? Perfect. So we can see here that the program's logging the callback roll dice, which means that it shows that we rolled a 22. It showed the different stats that we rolled. And basically what happened was that my front end requested this randomness, and then the randomness got returned from the program to me in a later transaction. And so this is just something that we built together to show what you could do with RNG, what you can do with VRFs. So let me bring it back here. Perfect. And talk a little bit about what's going on behind. So I won't go too deep into it, but you can request randomness by a simple CPI into our randomness program. And you give it the callback function that you want the randomness to go to. So in this case, I had like a dice callback function. So this callback function can do whatever you want with the randomness, whether it's flipping a coin, rolling a dice, generating stats. And there are a lot of neat tricks that you can do to minimize the number of calls you have to make. So for example, here I generated the attack, defense, and dex stat for my character. But instead of calling the randomness generator each time, I can instead split my randomness into different roles. So I generated a single U32. Then I split it into 3 different 10-bit chunks to create my state roles. And doing stuff like this saves a lot of time from having to roll each stat and makes for a far better UX. Moving on to privacy. So earlier, I talked to you guys a little bit about privacy. And so let's dive into what we can offer there. At MagicBlock, we recently released these private ephemeral rollups using TEE, or Trusted Execution Environment technology. So a trusted execution environment acts as a vault inside of a CPU. We use the latest Intel TDX to power our TEE. Generally, when you run a program on the operating system, you can see and influence everything: the code, the state, and the memory. A TEE creates a hardware secured space that physically prevents interference, even by the machine it's running on. We use the TEE to protect the entire state of an ephemeral rollup. Normally, when you execute a smart contract on-chain, every step of the process is visible to anyone. Any observer, from validators to the general public, can see what program your transaction's calling, what accounts you're calling it with, and what the subsequent state changes are. And that's what we just saw earlier with the Explorer, right? You can see like it called the VRF program, it called it with these accounts, and here's what happened afterwards. By using the TEE, we can selectively shield the state of an ephemeral rollup. But first, there are a ton of approaches to privacy in crypto right now. There's stuff like fully homomorphic encryption, zero-knowledge proofs, and multi-party computation. All of these are very powerful tools, and each of them comes with their trade-offs. At MagicBlock, we chose TEE as our solution because we believe that it offers the most practical benefits in terms of confidentiality, real-time performance, and developer friendliness that Solana builders can utilize today. So why should you use the TEE? It's confidential. The state is protected from anyone that's not authorized. It's scalable, so it's running inside an ER that can execute blocks at increased bandwidth and reduced latency. We did some benchmarking. So generally, our normal ephemeral rollup blocks are anywhere from like 10, 20, 30 milliseconds per block. With a TEE, running inside a TEE, you're looking at a little bit of performance trade-off. You're looking at like 60, 70 millisecond blocks, which is still very, very good for this private infrastructure. It's composable. You're still able to interoperate with other Solana programs, and it's compliant. It's easy to enforce compliance because we have this fine-grained access control layer. So trusted execution environments unlock entirely new applications. You can do stuff like confidential transfers. So without exposing your balances or counterparties, you can send money from one person to another. It has sealed bid auctions. You can do fair price discovery by keeping bids hidden until settlement. You can do stuff like private games where maybe it's like you want to play poker, or strategic games where revealing the state undermines the gameplay. And stuff like enterprise and compliance flows. So you can run payroll for your company. You can do supply chain operations. You can do regulated processes with blockchain guarantees while keeping sensitive data private. Something to note here is that, again, many of these are already possible on Solana, and that's great, but they require these different workarounds, either in terms of like commit reveal schemes, and using a TEE makes it as simple as simply writing the program. So how do the permissions for these TEEs work? What happens is that there is a permission program living on mainnet where you can define for your program different user groups and different permissions to assign those groups. This could be things like read or write access. Once defined, when a user tries to look at the private state of the program, I don't know if you can see my mouse, but like the transactions or the current state, we'll first check against the permission program and allow or deny based on that. So how does the program know that the front end requesting the data is really who you say you are? Like, couldn't you just claim to be a user that has permission? There's a couple of ways to ensure everything's up to standard. This is going to be very technical, but I'll give you guys a demo afterwards. So first, we have attestation of the RPC. And what that means is that the front end sends a randomized 32-bit challenge to the RPC, who has to internally sign it within the TEE to receive what's called a TDX certificate. Then the front end can verify their certificate to ensure that the hardware is indeed a genuine Intel TDX TEE, and that neither, say, MagicBlock or a malicious actor switched out the hardware behind the scenes. So this proves that we are using, say, genuine hardware, and anyone can check it. Next, we have what's called a client challenge, where the RPC sends our front end a challenge that we need to sign with our private key. So this proves to the TEE that our front end is indeed being controlled by the wallet that we signed with, and thus have the read and write permissions that that pub key has. And when we give it that, the RPC then returns our client a auth token. So finally, using this auth token, when we create a connection to the RPC, we pass it this auth token that was generated for this session, allowing us to see the state that we're allowed to. So again, that was very technical, and I think that it's much easier to understand if you see this in person. So let me pull up this and hope that our live demo work goes well. Fingers crossed. All right. Okay, so this is a private payment. So this is live today. Right now, we skipped actually the first step because I actually already logged in. So if I actually, all right, you're just gonna have to trust me here that normally there'll be a thing that asks us to sign, and we have to sign it with our wallet, and that proves that, again, our wallet is who we say we are. So we can see here this verified. This shows that this is doing the TDX check and checking that it is indeed connected with this legitimate software. So let's take a look here. So we see that here, we can just create a new token actually. So let's create a new token. You can't see right now, but I'm signing with my Phantom wallet. And so what it's doing is that it's creating the token, minting the SPO tokens, adding this 1,000 initial supply to my wallet. And then what we're doing is that we have to create like the permissions. We have to create all of these different programs behind the scenes. But maybe something is weird here. Or maybe it's this one. No, it's this one. Okay, we'll do it with this one. So if you look, we can see that we have 100 of these SPO tokens right now. And what I want to do is send these SPO tokens to my other wallet. So again, you can't see right now, but I'm pulling up Phantom in my other wallet. And I'm going to put in my thing. And then I want to pass it 50 of these SPO tokens. So you can see here that I can see this other wallet's mainnet balance, but it has a private balance that I have no idea what's there. This is, again, the curse of live demos. Thankfully, I thought of this and I have prepared something I recorded a little earlier. I will have to figure out what just happened there, but this actually is great because it can show you this authentication. So, like I was saying earlier, we have this authentication where right now you can't see, but I'm signing with my Phantom wallet here. So it goes in, and you can see right now that I have 1,000 SPO tokens on mainnet. So I'm grabbing the address for my other wallet that I'm going to send it to. And I want to send it 100 tokens. So here I'm just signing the request. And every request that I'm signing here is added with my auth token that I generated. So I have to append it to the request. And so we see here that we cannot see the private balance of the person that just received the tokens. Like, I don't know how much they already have. I just know that I sent them 100 of them. So I'm going to switch right now to the other account. And once again, I have to authenticate my identity to show that, prove to the TEE that I am who I say I am. And look, you can see the 100 encrypted tokens that we now have, but no one else can, unless that you've specifically given them permission to. So then what we can do now is that we can withdraw the 100 tokens to our mainnet balance. And you can see that right there, we withdrew 100 tokens. So that's how you can implement private payments today. So then let's bring it back. So right now, I'm going to go a little faster, running a little, just make sure that we're good on time here. How this works is that we have a backend implementation, and you have to do a CPI into the permission program. And you create, like I said earlier, a permission group. And each group can have different members and permissions. And you add permissions to the created group. So currently, a permission implies read access. And there's going to be distinctions with many more permissions that you can do. Real-time price streams. So this is one of my favorite things about the ephemeral rollup. So let's first talk about what oracles actually are. So oracles move facts from the outside world onto the blockchain in a way that smart contracts can verify. So this could be anything from, the BTC price to the price of eggs to the winner of the US presidential election. On Solana, most oracles are programs that keep Solana accounts updated. So when a smart contract needs to know the price of Bitcoin, it doesn't call an API. It simply reads the data of the known oracle account. So we utilize PithLaser, one of the most popular oracle networks, to provide our real-time price feeds. So these price feeds can then be used in a variety of ways, like pricing perp exchanges or providing inputs for games. And the best way to show things is to show them. So what we can do with this super granular PithLaser is we can, let me pull it up here. One second. Seems it doesn't want to cooperate. Okay, one second. Here it is. So this is one of the coolest apps that I've seen. Essentially, what you're seeing here is fully on-chain, and it's the price of Solana. And so what we can do here is that we can, let's see if we can play right now. We can try to guess where the price is going to be in, this is, I think, 5-second increments from now. So for example, trading sessions, let me sign this message. So if it hits your block, you get paid out whatever reward it shows. And this is super cool because, again, this is fully on-chain. Every single one of these updates is a price feed update. And looks like it's not cooperating for this, but every single update here is a price feed update. And it just shows that this is a new way that you can play games. This is something that it's called tap trading. And this is actually one of our, not portfolio projects, but one of the projects building on us called Rush Trade. And you guys should definitely check them out. So then, yeah, so that's using our real-time pricing oracle. And again, super cool. We use Pith. It could be anything you want. You could ingest, say, I don't know, pump fund token prices. You can ingest the prices of gold is recently very popular. I think that Pith actually has gold natively. All right, finally, let's take a little walkthrough on what implementing this could look like within code. So let me see if I can share with you a code editor. Okay. So let me make this a little bigger for everyone. So this is going to be a simple counter program. It's a program that is deployed on DevNet where literally you just give it +1. It increments this counter account, and every time that you press a button, it increments it +1. So to integrate Magic Block, first thing all you need to do is download our ephemeral rollup SDK. And at the top of your program, you just add a little ephemeral macro. And what this does is it adds a bunch of injected accounts to your different functions. So let's look here. This is the interesting one, delegate. So what we do when we delegate is that, like I said earlier, we're going onto this fast lane. And we're going to be delegating just the counter accounts. And so you can see here what the increment does, right? So increment just increases the count of the counter +1. And if it's more than 1,000, we're just going to reset it and go back to 0. And here we have the undelegate function. And so what this does is that when you want to leave the highway, you simply call undelegate, and then it goes back all the state onto mainnets. So we can take a quick look at this code in action. Let me share with you the ephemeral counter. All right, so this is what we just implemented right there. So this is, you press it and the counter goes up. So right now this is on a local validator. So you press it, number goes up. And so what we can do is now press the delegate button, which we'll call the delegate instruction, and delegate it over here to now the ephemeral rollup. So right now this is living in the ER. So now when you press it, it goes up, and you can press it almost as fast as you want. So this is, it updates in real time. You're pressing, and all of these again are on-chain transactions. And so right now we can then undelegate this state back to the devnet or mainnet. Yeah, so this is essentially how easy it is. All you have to do is be able to add this delegate function, add this undelegate function, and then from your front end, route it to wherever you need to, wherever you want. And so if you actually guys want to check it out yourself, all our code here is open source. I'll give you guys a second to take a look. But we have a ton more examples for you to try, start getting built with. We actually recently released a bunch of starter kits for a bunch of different use cases. And we're really excited about this, like use cases from finance to DPIN to games. We have everything. Last thing I want to note is we currently have our incubator program open for applications, and we're always looking for interesting teams that want to utilize Magic Block to build these ambitious app ideas. So we'll provide you with technical mentorship to help get you from 0 to 1, marketing support, strategic guidance to raising a round, as well as working together to give you guys feedback. Like, we love you guys. You guys did cohort with us, and we would love to see what kind of ideas, what kind of companies you guys want to build. Related to this is actually, if you don't know if you want to, for example, just get inspired, we have something called a request for product, which are just things that haven't yet been built on us that we think would be super, super cool to build. So you can find this on our incubator website, but you can also find this, I can share some with you right now. So these are just ideas like, for example, under collateralized credit marketplace. So the font might be a little hard for you guys to read. And if you click it, it shows you the technical design. It gives it a short description of like how we think that this could be built. And we would love to see if you guys, have any ideas regarding any of these things, how this could be built on ephemeral rollup. You can, short meme coins. You can build some on-chain roguelike games. You can build a news trading app where you trade real-world news. Anything is possible. So, yeah, Magic Block incubator program. You guys, highly encourage you guys to apply. And if it sounds like you, we'll love to talk with you. And you can check it out with the QR code on the right there. Yeah, thank you guys for hosting. My name was Andy, and I'm a developer at Magic Block. And if you want to take a look at our Twitter or our Discord, feel free to reach out anytime. Yeah. And if you guys have any questions, would love to hear them. Or I can just ramble on. I can do that as well.
Andy, this is great, man. Thank you so much. And of course, thanks to the whole team. We do have some folks in the call here that have been watching the YouTube chat and looking at some questions there, and also probably have some of their own. So let's go. First one, go ahead, ask.
Thank you, Jeff. Thank you for the delivery, Andy. I just have a few questions regarding the Magic Blocks use. You said Magic Blocks use a Vixen validator, right? The ephemeral rollup. And does that validator need to be the same as what we are using on our Solana chain. Or they can
Sorry.
be different.
I think my internet might be breaking off a little. Would you be able to like type that or yeah?
Yeah, let's do this. Go ahead and write that in the chat, and I'll read the questions from the chat. That might be a little bit easier because we have a better connection. I see that Onana has here, can we delve deeper in the zero fee transaction and how that is supported?
Yeah, for sure. So this was again one of the features that we were the most excited about. So how we're able to offer not just zero fee transactions, but custom fee transactions, in which case we think is much better, is much more interesting, is that what we essentially are a customized SVM runtime. So we have SVM running, but you can fully customize whatever parts of it you want. And that includes the fee model. So by default, we changed the public fee for our public nodes to be 0, completely free. And then you can change it to whatever you want for your own application. And like I said earlier, this could be your own coin. This could be some other coin that you create just for it. Yeah, anything is possible.
Great. Okay. And we have the question from before, but before I read this out loud, one thing that I want to mention is, we did a cohort for Magic Block, and, I think we shipped like 9 projects, most of which were done in a couple of weeks. And while the magic here, pun intended, is very complex, the integration process and creating with it is not. Magic Block's website has excellent videos, lots of content, lots of really clear information on how to integrate and use. And like Andy said, there's so many different use cases, it's really limited only by your individual imagination. So the question that we just were thinking about, can the validator used by the ephemeral rollup vary from one of our Solana nodes that is running?
No, so we keep it up to date with the current stable version of the validator nodes. So you can be sure that it's always compatible with whichever node the leader is using.
Cool. Okay, thank you. So the next one was, would it be able to commit and undelegate in the same block?
That's a great question. I love that because it's like, it shows a deep appreciation for like a UX perspective, right? Like as a user, you don't want to be signing a bunch of transactions to get something done. So yes, you can commit and undelegate within the same block and the same like side transaction. But more than that, you can do a ton of this in all transaction. Say that you were a trading app and you wanted to delegate onto the ER to trade. So what you can actually do is in one transaction, have the user deposit SOL to your program, take that SOL and delegate it onto the ER all within one signature and one instruction, such that the user gets a seamless experience and they don't have to worry about, clicking a bunch of buttons.
Yeah, that's very cool. Oh, very interesting question here. Has anyone that you know of, Andy, tried to use Sora using Magic Block? Is it possible to create videos using Magic Block's AI functionality, or is that something that someone needs to build?
Wait, that is super interesting. So currently the article is supported for text-based, and we actually have a team launching tomorrow called Will, and they're using us to do these text-based inquiries for LLMs. But I think the main limiter for, say, these videos were generated would be the storage on-chain, right? So storage on-chain on Solana is very expensive, and we released a one second. Yeah, we released a compression solution recently in partnership with LiteSVM, where you can compress a bunch of data on chain. And so I'm wondering how this is actually possible. That would be super cool. Like, yeah, if this is something that people, you think that you want to give it a crack, like I would love to talk to you about it. Like being able to give a prompt, and because what you can do here now is that you can attest that this was actually generated by this person at this time. And that creates a ton of possibilities around, say, like IP or like where it came from. Like, super cool idea.
Nice. And Andy, your voice is a little muffled, but we are working on it. I see another one that's very interesting that I know a lot of people are wondering. Is everything on chain when using an ER, or does it offload anything off chain? I actually know the answer to this, but I'll let you have your time in the sun.
Yeah, thank you. So yeah, let me know again if my voice is muffled.
Your voice is perfect now.
Perfect. Okay. So everything is fully on-chain, running on an SVM runtime. Like, you get all the same blockchain guarantees that you get running on Solana mainnet. You can be sure that there's going to be like no double spend. You can be sure that there's going to be no shenanigans happening around this blockchain stuff. There's no off-chain computation.
Awesome. Very, very cool. So we'll go with one more question. How do we, this is a juicy one, Aditya. How do we build a Polymarket style CPMM and Oracle on Solana using Magic Block? That's a big
That is a big one. That's actually very similar to one of these requests for products, which is trade the news. So we actually essentially diagrammed it out and tech charted it out. So at a high level, what you need to do is have an Oracle ingesting the latest news headlines, right? And so you can take these headlines and have people trade on these headlines. And what they're essentially betting on is whether this is noteworthy or newsworthy. So you think that if, say, China announced a new embargo on US goods, and you know that this is going to be huge, so you can start trading on it and being able to speculate on whether or not news is big. And so you can put this back into the idea of Polymarket, where you simply had like a single article, and it tells you, you can actually honestly hook it up directly to Polymarket, and in tandem create Polymarkets that they create. You have it completely defined. You can have virtual liquidity and use this protocol to settle all these markets. It's probably possible today. And again, this is something that really excites us, the possibility of like all of these things that you can do on Magic Block. So I'm going to urge you to reach out and, love to chat about it.
awesome. Thank you. Yeah, Alex, Magic Market. So Andy, we're going to wrap it here for you. You can see how to get in touch with Magic Block, everybody here in the call and in YouTube world. We are very fortunate that we were able to get the Magic Block guys here and have a really nice long-standing relationship with them, as we all have the same mission. We're all mission aligned, and that is to really push the boundaries of what's possible and to create tools that people can use to, design and develop great applications to grow the user base in this industry on Solana. Andy, we certainly lucked out that the sound stuck around and cooperated until the end, and appreciate your resilience on that side. So folks, if you are interested in Magic Block, you know how to get in touch. And Andy, I'm gonna, welcome you to stick around. I know you said you want to, and we're gonna take a little bit of a pause here, and Brianna and I will jam a little before we bring the next guest to the stage. So everybody, give it up for Andy from Magic Block.
Awesome, thank you. Yes, so it was great to be here. Thank you for inviting us.
Awesome.
Yeah, thanks.
Thanks, Andy. So, Andy mentioned we did a Magic Block cohort a couple months ago. We built a couple games, we built some consumer applications, and we built some DeFi applications. The CLMM, We did an arbitrage roll up, a couple games. I think Rust Undead, which is gaining a lot of popularity right now. Daniel built that, and he is daily talking to the Magic Block team. So when Andy says we're here to support you, I see it firsthand every single day, the effort that team puts into supporting people in their building process. Brianna, what do you think?
I think it was awesome. It was a really great demo, just going through everything to fully understand what Magic Block is. I think you hear the term like ephemeral rollups and you're like, I don't know what's going on, and it's very intimidating. So having it broken down by all of the concepts and use cases was great. So
yeah, thank you. And I mean, look, the other thing is, I'm going to say this probably every time, if you see something, say something. If you're using this technology and integrating it into your project, and what works today doesn't work perfectly tomorrow, just remember they are constantly improving and working on their stack. So just let them know, go and make a contribution. But never think that you are not ready to make a contribution. Everybody should be thinking as a responsible steward of this technology. If you use it, you got to help contribute to building it out.
the one thing that I love about building on Solana is everyone's always very receptive of feedback, and also anytime you do make an issue or a PR, all of the maintainers or builders of whatever project you're looking at are going to immediately respond, and even just reaching out as a Twitter DM and saying hey, I'm having this problem, this could be improved, because we're kind of in the weeds after being here for so long. It's easy to overlook where those DevEx challenges could be. So when you're newer, you're going to bring a new insight in. So definitely reach out when you see something, because we love to hear it.
Amen. Yeah, I mean, the new person is the most important person. They can see things that we can't see anymore, and we tremendously value that. So we're going to take a little switch, pun intended, as we shift into Switchboard. So Brianna, what's your what do you know about Switchboard before we hand it over to Manny?
Honestly, I'm not too sure. This is going to be a learning session for me. So,
I mean, our experience with Switchboard, again, it goes back a couple of years. When Switchboard was a little newer, and the idea and the concept and the tech is brilliant. Mitch and Nathan and the team over there are absolute legends. But the DevEx needed work, and that's a hard thing, because if you're a PhD like Mitch, and this stuff is so intuitive to you, it's hard to kind of look at it from the lens of someone like me, who was an English teacher for however many years. And, I know about as much about math as Khan Academy can teach me in 20 minutes. But, they have come a tremendously long way. The DevEx is brilliant and getting better. The docs, the support. Manny is here to demonstrate, what the human developer support looks like. But if you are looking to build some sort of customized Oracle solution, and I'm thinking about all the projects in our current cohort that are doing some sort of piping of off-chain data to trigger some sort of on-chain response, that requires something like Switchboard. That requires the customization and the integration of that conduit between the off-chain and the on-chain. So, the use cases are limitless now that the DevEx has reached this, escape velocity quality. Let's shift into Switchboard. Manny is developer relations and works with Mitch and Nathan at Switchboard. So, Manny, thanks for being here, man. The show is yours.
Awesome. Can you guys hear me fine?
Perfect.
Awesome. Cool. Yeah, great presentation before me from Magic Block. Awkward as he just rambled on about Pith Laser. I kid. They're all great. We all in the Oracle space. Very small space, I guess, between us, Chainlink, Pith, Redstone, et cetera, et cetera. We all strive to do the very best when it comes to not just bringing price feeds on chain, but as now more markets, prediction markets, different types of consumer apps, etc., want to come on chain, all that data needs to come on chain for your contracts programs to work effectively. So real quick, I'll kind of just like outline before I start sharing my screen what we will, or what I will talk about here. I know you guys wanted Mitch between travel schedules and a couple things. I'm the one you get today, so hopefully that's okay. I'll preface by saying I know a lot of people in this cohort are also participating in different hackathons and creating apps, etc. I did just win the Radar Hackathon Coliseum. I know that's a few back, but we did win first place in the consumer track, so hopefully I can give you some pointers there as well too. All this is while using Switchboard to power the platform as well too. So I'll go over what differentiates Switchboard from other Oracle networks today. Although we do most of the same thing, you do have a lot more freedom and customization than other Oracle networks. How to different examples on how you can use these. And then I'll give you some live examples in the world today that use oracles in different ways, from sports to price feeds, and then talk about our new offering, Switchboard Surge, which again rivals Pith Laser a little bit. So all that and more. I'll start sharing my screen if you allow me. Give me a sec. And I think I'd rather just share I'll just share probably this entire screen. Let me know if that's viewable here.
Looks great.
Cool. Awesome. So I'll talk a little bit more about Switchboard first. Switchboard is an Oracle network for the most part. I'd say 90% of our business is bringing price feeds on chain to your programs and using that to create, I don't know, a lending program of some sort, perps, trading, prediction markets, et cetera, et cetera. The issue, and I'll talk about the underlying problem first. The underlying problem, if you go back to 2021 when Switchboard started, by the way, Switchboard did start, I think, right before Pith. So technically we are first movers, but neither here nor there. We bring price feeds on chain for a few reasons. The first way we did it in 2021 was what we used to call the push model, right? Where every X amount of seconds, or I don't know, 30 seconds or a minute, whatever, we are pushing updated price feeds. Just like you see on the screen right here, these little white things are how often it's being pushed at the moment to a specific program of some sort. The issue there is kind of obvious, but if you have some sort of trading platform and you're getting prices every 10 seconds, if I'm making a trade at the 8th second and that price has been stale for 8 seconds with the volatility of Bitcoin, ETH, whatever, you're working with kind of old data. So when that new data comes in, now your trade is all of a sudden down, 0.5% as soon as you made the trade. And working with stale data was the number one reason people did not like, working with oracles in the beginning. Let's just do this off chain. Defeats the purpose of Web3, but there was a big flaw there in how it worked. Fast forward a little bit, and you get the new pool model where now every single time you make a trade or a user makes a trade, now right before that trade, the program asks Switchboard or whatever Oracle network, what is the latest update? That latest price is what is then used in that transaction. And that obviously is beneficial for a few reasons. One, you're working with way less stale data than you did before. So all your prices are up to date, as best as you can. And number two, it's cheaper for the end consumer or the platform, right? Where you don't have to pay for price updates every 10 seconds, whether you use them or not. You can just only when you need it, that's all you're going to pay for. And that's that was great. Now, the fast forward till today, where you're seeing these new offerings, the ultra low latency offerings that many companies are now offering is how can we get price data to come in pretty much in real time. And I think this movement from 2020, 2021, since we incubated all the way till now, is how can we get price to move as real time as possible as it does in the Web2 world here on chain. And that has been a challenge, right? I think you've seen many companies try to do this, but I think now we're in a pretty good state where it's not off chain, say, I don't know, Hyperliquid if you want. It is fully on chain, where you can today make a Hyperliquid on chain, fully on chain on Solana that works just as fast. You get real-time pricing, you get real-time transactions. It settles immediately. and you have as close to real moving platform as possible. And obviously this lends out to a bunch of markets. As soon as games end in sports, you can have things settle immediately. As soon as someone places a trade, you are placing a trade with the latest price that Binance is giving you that same second. Or you can just stream this data and stream real-time data, even if no one is using it on your site, so people constantly have the latest price and know that they're working with up-to-date information, whatever that information is. A couple things. The reason why we say we're the largest customizable Oracle network is because you, and permissionless, I guess, is because you can create these feeds yourself. You don't need us to create them. I'll walk you through an example now. And you can say, hey, I want the price of BTC, but I want Jupyter as a source. I want, I don't know, Meteora or CoinGecko or wherever. I want 3 different sources, and I want to average them all out, say, for redundancy purposes, and have the average of all those sources into one feed, and then get that one feed into my program. And like this, you can do that for any asset, including long tail assets. So I think the beautiful part about permissionless and customizable systems or processes is that the day Trump coin launches, you don't have to wait till someone creates you a Trump feed that is, public for people to use. You can come over here, immediately have it created, and use it within 30 seconds of a Trump launch, per se. If there are new games starting for your prediction market and you immediately want to support those, you can immediately create those feeds and have that settle your markets once the games are over, or give you live updates, et cetera, et cetera. So we haven't taken the traditional approach, as in, hey, this is your traditional Oracle network. These are your feeds. Here's the feed ID. Go take it and use it. Although we do have that now. You also have the ability to create your own feeds, and I guess I'll walk you through. I know this might seem overwhelming, at least in the beginning, but and the way we've structured it is we kind of have these tasks that we're calling them on the side, where we've kind of delineated, hey, like this will be how you get Jupyter price, this will be how you get Meteora price, this will be how you get, and the list goes on. Little by little, we are adding different task types. If you saw a couple of days ago, we are now supporting all Kalshi markets. So if you wanted to bring Kalshi updated prices of every single one of their markets, you can bring that on chain as well. You want to have some R bot you want to build with, or whatever the case is, you can have all that information updated on your on-chain program as well too. So I won't go through every single one. We do have a lot, and I'm not going to go through all of them, but I'll go through a basic one just so you can see and understand how it works. And then I'll also then just kind of skim through the other ones and show you, this is also possible. So let me delete these. These are your standard. I'll kind of use the Jupyter one. Why not? So I'm creating my own feed here, and for the sake of this example, we'll create a Sol USD feed. We try to make it as easy as possible to where you just kind of just read and just fill in the blanks, if you will. So I'll take the Sol address, and I just have it pasted somewhere else so I can just copy and paste. We're going to do Sol to USD. It's asking you enter the token address. And the output token address would be the USDC one. So I'm just copying it here. Sorry. In this line, base amount of 1, and we pre-populate a base amount. Base amount would be like how much of the first token do you want to be? I'll just do 1 for now. And then slippage, if you have some slippage tolerance of some sort that you don't want to pass. At the bottom, we'll just save the job. We'll simulate. We'll run the simulation. And you should see the price of 1 Sol is about 184.79 at the time. And this is using Jupyter as a task, right? So a few things. I'm kind of on a new computer, so I'm playing with water, but you'd create the feed account, and then you'd get the feed ID, et cetera, that you can feed into your program. And like this, you can do many different task types. So I'll just kind of go through each one a little bit. If you do have, an API, say like a CoinGecko API, this is where you place the URL. We do have get and post methods for APIs. And once you get your, because sometimes when you get an API, it'll come back as a JSON. Then you parse the JSON with a JSON parse task, and you get the actual price of the API or asset you're getting from there. And as you go down, you'll see we have Meteora. All in Meteora, you have to do. They're very famous for their DLMM pools. You'd get the address of the DLMM pool. You'll put it in, and you'll have pricing from Meteora if that's what you wanted. I'll kind of quickly show you what that looks like. It's going to ask you for a Meteora pool address. If you see, I remember off the top of my head, on Meteora, anytime you go to a pool, on the address bar at the top, it'll show the address of the pool. You input that here. Again, the same input token address, output token address, and you'd get your feed from Meteora. And like this, you can go down and do anything you'd like. I think the beauty about this is how I explained to you, once big drops happen or big tokens get launched, etc., there is no waiting around. And if you're like me, my pet peeve is I think the Switchboard team hates me for this reason, is waiting on other people. And sometimes I find myself waiting on other people quite often. This lends itself right to that. Don't wait, go create your feed and go use it. I will say our new offering, and I'll show you that. I guess I'll show you a live example of what that is with what I created on the side using Switchboard. Our newest offering, Switchboard Surge, is and I'll go back to the homepage because I think it does a great job of showing these Switchboard Surge price feeds. These price feeds are currently updating, and these are all Switchboard Surge price feeds that you're seeing on your screen. All Switchboard Surge means is it's the code name for our ultra low latency offering. And if you see here, we've done a pretty decent job of showing the latencies between, it's a BTC USD feed, but latency from the feed to the program and how fast they update. And here we take pride in this. I think this took a really long time to build and master and get the latencies down, get compute costs down, get everything down to a point where, hey, not only is this fast enough, but this is usable and it doesn't cost an arm and a leg. And again, I'm going to show you a live demo of this now, but 2 ways of using this. One is via WebSocket, via streaming, where you can always, at all times, have live updating feeds just like you see on the screen. So I think if you're thinking of a regular Oracle or feed, you think, hey, it updates, I don't know, every second or every 2 seconds, which is great, which is fantastic. But for me, even that cadence with people running our bots and trading bots, etc., that are, as sophisticated as they come, like even a 1 second or 2 second stale price, you'd be surprised how that can go against you pretty quick if you're a platform. And you can talk about, insurance oracles or whatever, but the point is people do try to take advantage as much as they can. It's crypto, it's Web3, like people are going to do what they want. So having real-time prices moving as fast as you see on the screen is an edge. And I think if I were to go a step further and say, if you're building anything in the trading space, whether it's a perp dex or whatever, or even a consumer app that deals with trading, or even, it doesn't have to be lending per se, because lending you don't need to speed as much, but even if you're doing some prediction market style platform, I think speed will be your best friend, where you can always have updated prices to the nanosecond, if you will. And you can see here, we're down to 1 ms is overkill because we are co-located right in Tokyo. But if you're not co-located, this looks more like 40 ms, 50 ms. At worst, is probably like 100 ms, but we guarantee pretty much under 100 ms, which is, I don't know, I haven't seen faster. I'm a little bit biased, but it's as quick as they come, right? So I'll show you what this looks like in practice. This, for all my hackathon enjoyers, this is the platform we won the hackathon with. It's currently live, very little, but the point is to show you that these price feeds are all real time. And I'll walk you through kind of what this looks like. So this is a WebSocket stream that we are streaming prices of Bitcoin from Binance. It's specifically the FDUSD feed that we get directly from Binance. We get this streaming in real time. Just this is spot price, number one. And then here, using the spot price, according to where spot price is and a couple other calculations in a formula, you are getting a strike price. So where Bitcoin has to be above in 5 minutes for you to win your trade. So two things happen. With Surge, we're getting live pricing real time. And then when a user clicks a trade, so I'll just click it for you for the sakes of this. What's happening now is Surge also has the ability to bundle everything in one transaction. So again, you are getting the freshest data possible when creating a trade. So walking through that step right there, what happened is usually what happens in traditional sense is the transaction and the Oracle update happen in two separate transactions where you get the live update of the price and then quickly right after you make the transaction for the trade, or could be on a perp text, could be on whatever. Again, we're talking about milliseconds at this point, but even then, that is still somewhat stale data when you talk about like how bots are trading today. So Switchboard and the way Surge works and its bundling, you can create that updated price from the Oracle feed and the transaction all in one. And then when it's passed, it happens immediately right after the other with as little as possible for MEV or front running or whatever you want to call it. So it's the 2025 version, almost 2026 version of what oracles are today. And you can do this for any asset, any feed, etc. I'll show you some other examples of where this might be applicable. Again, if you're using perpstexes, Drift, good example. And I know they use a few oracles, so redundancy here is key. But imagine trading here and not having up-to-date pricing. That'd be an issue. I think what we're seeing across the world or crypto world now is 15-minute markets, hourly markets, 4-hour markets for Bitcoin, Ethereum, etc. All these need an oracle of some sort. The faster, the better, although these settle in 15-minute markets. Sports, or if you go to Kalshi and you see all the sports, you can bring sports data on chain. You can bring, the other day I brought Fed rates on chain because I know some markets are doing Fed rates. So when we get that information, the feed brings it on chain, program does whatever it needs to do, etc. So all this is to say that now more than ever, speed is everything. And at Switchboard, we've gone from the slow pool model in the very beginning all the way to as close to real time as humanly possible. I hope that did it a little bit justice. I'm willing to take some questions. I'm willing to show more examples. And of course, we have great documentation that can go through all of this and walk you through exactly, also explain why it's so fast, et cetera, et cetera. I don't know if you wanted me to go into this. I don't know how technical we want to get, et cetera, but.
So I would say this, Manny,
Sure.
Let's get technical now. I am integrating Switchboard,
Sure.
my application, to get off-chain data as a triggering condition for an escrow. Let's say that I'm going to lock one soul.
Sure.
And if the Philadelphia Eagles win tomorrow, I get it. And if they don't, I don't.
So what you're saying is Eagles game tomorrow, one soul on the line. Could be against a house, could be peer-to-peer. You lock up the soul. If Eagles win, we pass in an Eagles victory and you get, I guess, 2 soul, whatever. Yes.
Perfect. Let's play with that. Let's demonstrate. I'm putting you a little bit on the spot, but I think it's an opportunity.
I'd love to do this. Because of travel, like we're all on different computers. I don't have anything installed here to do anything, so I can talk through some of this stuff. But
let's talk through it.
Yeah.
Let's point to the spot, the switchboard.
As a matter of fact, we actually do this now live on this 0DT site that I gave you. It's not sports per se. But you are locked with a house on the other side, where just to kind of explain how this works. So the initial transaction. Oh, sorry. So I could actually show you this. The initial transaction when you make a yes bet here, and I can do one soul, do the exact same thing. what's happening here when you press trade or place a bet with eagles, etc., is you are putting this in an escrow where the logic in the program is saying, hey, for 5 minutes, and the timer started. You can see there's like a timer going. If at 5 minutes, what's going to happen? We're going to again prompt Switchboard to give us back a price of, BTC at this exact 5-minute mark, and we're going to say, and I think there is probably a history page that I can probably show it better, where right final price at the time of the 5 minutes is this. Prediction, what I needed Bitcoin to be above this number, and it was not. The final price was just $1 short. So my payout is I lost the 0.01 SOL that I initially put in. If that were to win, like this one, like the very next one, where my prediction was above 107, 8, whatever, and 183, and I had 107, 263, I won this bet. My bet amount here is 0.01. My payout is 0.02. So my net result would be so all this is saying is I am locking up this SOL into an escrow account. The program already knows that at the time of finishing, or the 5 minutes are up, or whatever time frame you chose, it's prompting Switchboard, and in one transaction, again, it is giving you back the SOL. Now, the escrow or the house account or treasury or whatever you guys want to call it does have house liquidity or an LP pool, or if you want to call market makers, they'll deposit in here. Like, there's a bunch of terms for a lot of this, but there is pretend there's a bag of money here that you're playing against. You are putting it in you're putting it in a PDA in the middle that's just saying like, hey, this is the escrow. If this happens, cool, we'll pay you double your money. Or, because there's also another component, you can pay triple your money or quadruple your money. And this is all programmed into the logic in the middle. So again, I installed this computer 2 days ago. Everyone's traveling. We're all traveling. I'm trying my best, but
you're good, man. You're good. So let me ask you another question. No, we're fine, man. We do it all the time. So, I am a relatively new anchor builder, and I've got this escrow. What from the Switchboard code base am I going to grab, and where am I going to drop it in my repo?
Yeah, so I could actually, because I have this on my other screen.
Perfect.
Oops. How can I stop sharing this screen and share the other one? One sec. Oh man! All right, let's see. This is live. They tell you not to do anything live, but we're out here. Yeah, I mean, I'm trying my best.
Well, so it's funny. So as a teacher, you're doing 900 shows a year.
Yeah.
And there was this time that I would be teaching grammar, and the kids would ask for an example, and you show an example that fixes one thing.
Yeah.
And you just mess up a few other things, but you learn from it and you figure it out together. So that's what we do. Show us what you got. Let's see what we can figure out. We got a room of 21 people that have all done Turbine here. So we'll work together on figuring this out. I think there's a lot of value to doing this raw. So let's rip it. That's the fun.
No. And listen, I think what you guys have built is fantastic. I've known a few guys that have been through the program, and they're brilliant builders, all with great jobs in the space. So,
yeah, man.
Yeah, pretty sick.
It's also a mindset, though. I mean, so I just want you to know the comfort of you have a room full of people that are used to that. Let's figure some stuff out right here.
Yeah, for sure.
Cool.
All right, cool. So I'm actually bringing this up because, again, new comp. I'm trying to. So let me share my screen.
Cool. Everybody in the call, get ready to help. It's what we do. I'm willing to bet something new that you guys need to, integrate will come out of the next 20 minutes. It's my bet. Can I lock one SOL on that? And
sounds good. Cool. So how you can get started, and I guess this is, by the way, can I post a link in chat? Is there a...
You could do whatever you want that helps anybody else do this work. No
Yeah,
need.
cool.
This is a permissionless opportunity.
Yeah. Oh wow, I didn't notice there were also questions here. So it's everything here is, so everything happens on demand. Yeah. So we've actually nicknamed this on demand as well. You can call it pull. You can call it, I don't know. There's names for all of this, but essentially you need the on demand. So someone already went through this, I guess. You need the, yeah, correct. You need the on demand package. That's right. And here's a simple way to install. Yeah, that's correct. Sorry, I'm just catching up on the people. So aggregating multiple sources does not increase. I'm just going to quickly go through the question. Aggregating does not increase. No, I think we have some of the lowest compute units possible. Also, the way fees work, I'll explain that real quick because I see a question there. It is passed on to the user at the time of transaction. It's micro, so you won't see anything. Most of the deals we make as a company are all with the L1 or the L2, or it's not at the consumer level or the platform level. So there wouldn't be anything to pay for. There is so for Surge, I think pricing is a little bit different, where we are giving you 5 free Surge feeds free, but because those are a little bit costly for us, yeah, you do have to pay. I believe the starter package is about $5K per platform. But yeah, that'll include anything for Surge. Any good example for pools, Radium, Orca? Yeah, actually, sorry, I know you wanted me to go through this, but there is some pretty good questions that I'd love to probably tackle in the chat. I actually think I made a...
Yeah, we don't apologize around here, man.
I actually think I made a video on one of these pages. One sec. That explains exactly what he's saying. I think it's deploying the feed. No. Integrating, maybe. Damn, there's a video that I made for this page specifically. Whatever. It's in here somewhere. And I do Radium. I don't do Orca, but I do Radium for you. So you could, yeah, you could do that. I think for the majority of your listeners, viewers, whatever, I think making tools and some sort of perp stacks is what we're arriving at. And I think, yeah, I'd love to get them started myself too. I could offer, help. And I could teach you how to, I could actually go back in this page. Let me open the Explorer app and teach you how to aggregate sources, because that's 2 questions from it. Let's say you want Jupyter, and I won't go through the token again, but you could just, so in this space below, you could add as I think we have a limit of 5 different tasks at once. It might be 7, I'm not sure, but you can continue adding tasks. So say you want Meteora swap task under it. You want, I don't know, pump under it. And all of a sudden now you have 3 different tasks where you can feed it where you can get 3 different prices from. Because the other thing is, the price from Jupyter is not the same as Meteora, is not the same as, CoinGecko, all at the same time. They vary by, I don't know, depending on the asset, they vary by $1, or some update much faster than the others, et cetera, et cetera. So sometimes, and what I recommend to others is, hey, add 3 different tasks, maybe 4 if you want, and then, that'll be much easier. Another thing too, if one goes down, you still have the other 2 running. Again, talking about redundancy. So, cost increase, yeah. And then to do your ESPN task, you can get an HTTP task. You can get ESPN API, or I don't know where you get a Sport Radar. I don't know what the best API is for sports. Again,
we are still on the dock screen, just so you know.
Oh, wait, you missed everything.
Yeah.
Damn.
No, you're fine. You're fine. Let's just
that is my bad.
No, you're good. Repetition is the mother of learning. They heard it once, now they're going to hear it and see it. We're good.
Oh, damn, that's unfortunate. Okay, so Jupiter swap 1, this space in the bottom is lent for you to continue adding tasks. So if you want a Jupiter, Meteora, and Pump, you could add all of these, and it'll be like you have 3 separate tasks in the job feed. So here you can say, what is the price of BTC from Jupiter? What is the price from BTC from, a Meteora DLMM pool? And then, I don't know, I just threw in Pump, but you can throw in any other task that you want. And all 3 of these do a few things. You can get the average of all 3, or like I told you, if one goes down, you still have the other 2 that, for redundancy purposes, are still giving you the price of whatever asset you're trying to fill here. And then the last one that I wanted to show you is, for your example specifically, I can do the HTTP task, which from here, you can get anything that's not supported on the left-hand side. So say ESPN API, Sport Radar API. And then the only thing on the bottom that you would need is a JSON parse task. So you add the second task as a JSON parse task. So all that's happening is from the API on the top, we're going to get a big JSON file. And then that JSON file, you just have to go find exactly what you need from it. In this case, the Eagles game, just winner of the Eagles game, and then you'd simulate. And at the time of the game ending, by the way, sports are a little tricky because you're going to need to crank a few times throughout the game, only because you don't know when the game ends. Might go to overtime, might end quick, might end late, you don't know. So you're just going to keep cranking until you get a definitive winner from the API at the very end. So yeah, I hope that explained a little bit more. But yeah, you just feed that winner into your program, and it'll allow the soul or the winnings to be transferred to your wallet.
Okay, so I've got 2 questions. This is
Sure.
great. Just because I'm trying to think like the newer people in the room.
Sure.
If I know that the game should end between 4 and 4:30.
Yep.
Can I preset like 3 cranks, like one at 4, one at 4:15, one at 4:30?
Yep.
Can I preset those cranks, let them run? And if so, can you tell us what that might look like?
Some of these feeds might be able to be cranked at the moment. Let's see.
Cool.
I think so in this new Explorer for feeds, I don't think. Let me see. We might have a feed Explorer here that we can do this with. We used to have this in the no code builder. So we just recently updated our change where you can crank from here if you were non-technical, but in your program you could just prompt the simulation and you can just try it over and over. You're going to get 2 things. One's going to give you an error. The other one's going to give you the actual answer. So one's going to give you, hey, or it's just going to say, I haven't done sports in a while, but for sports, it might just tell you the live score of the game, which is not indicative of it being over. It has to say final score, whatever, and then it'll say Eagles win, Eagles lose. And that's what you will pass. So you can try, you can schedule these cranks. You can schedule cranks. So you can schedule 4, 4:30, and 5. And then when you get one, you'll use it.
Cool. It's interesting. So we're going to have people in the chats here that are like, I don't even know what a crank is. If you don't know what a crank is, go to Gemini or Claude, go to info, find some examples, go to GitHub, do some searching around for folks that use these tools. And, if I'm not mistaken, Noah's Tuk is a cron job that might have some solution there for you that might be helpful. But just, be a researcher. Everybody that's here today is doing research today by listening. Don't feel handcuffed by something you don't know. Just keep track of what you don't know and then go search around and ask people and talk about it.
I will say something too. Now that you mentioned, AI, even for these JSON parse tasks, which might get lengthy and people won't know how to like parse a traditional JSON file. You can pretty much just get so for example, if you were to get an API from ESPN, you input it here, you're going to get a big file with a bunch of letters and numbers all scrunched up together, and you don't know what to do with it. You can go to Claude or whatever AI of choice and say, I need to parse for the Eagles game data. Give me the correct JSON path to find the winner of that game. And it'll do it for you, and you just input it in this field. And you can do that. So if you guys are AI friendly or use AI a little bit more than you think you should, there's nothing wrong with AI. AI is great. You can do that to fill out some of these fields, and it'll work just fine. So again, nothing to be ashamed of. That's fantastic. Good point there. I'll check if there's any more questions.
Everybody in the room, look at the YouTube. Let's make sure that we're checking. Yeah, I see Andy is.
Switchboard, I think that pull instead of push works especially well for JIT DeFi. I remember back in the day, you guys had one of the first VRFs on Solana. We still have. I think Pith deprecated their VRF, so we're probably the only ones left. You more recently saw that in the addicted game that Solana pushed. If any of you played that, I don't know, weed game simulator. Anytime you try to open packs or whatever, the VRF was there as well too. Yeah, we've thought about deprecating it too. It's just way too much to support, but it is what it is. And as Magic Block said before, it is a challenge. I think if you could do VRF well, congrats, that's awesome.
Yeah, so like, I mean, I love that you said that and that Andy, chimed in. What a tremendous opportunity for builders to make a little bit of a name for themselves and a tremendously valuable open source contribution.
Yeah.
Build a VRF. I mean, look at how Magic Block did it. Look at how Switchboard has done it. What are the best practices? What may be new out there now in the last 6-18 months, in the general technical world that could help you make a better VRF. You will be the best friend of so many folks if you're able to tackle that and do it well.
Yeah, so, I'll also say that is one of the inquiries we get the most. And although we support, it is probably not something we love supporting. So if there is anyone that wants to dedicate themselves to having the very best VRF on chain, you have a lot of business waiting for you.
Yeah. I love hearing that because, we're always, our whole mindset is what does the ecosystem need?
Yeah.
It doesn't need another ticketing platform. It doesn't need, another pump clone. It needs a lot of other stuff. And so we want to focus on that. It looks like JK's got another question here for you.
Yeah, what are the challenges and how are you guys able to get price feeds that fast? So we don't do surge for every asset. It's only ones that we have direct first party feeds for. So when you are creating your own, say on the same screen, if you're creating your own, I don't know, Trump feed, that's not going to be on Surge, right? You're going to get it from, I don't know, Jupiter or wherever, and we can't, get that as fast as you as possible. Now, if we're getting something from, BTC USD from Binance, and we are co-located right next to Binance, yeah, we are giving you that from a first party feed. We're giving you that as fast as humanly possible. Now, do you also want to co-locate next to, if you're running, some server next to Binance right next door, then that'll be as fast as possible. But otherwise, it's the few that we've selected, and you could see them here in the price feeds page right under Surge. These are all the Surge feeds that we are personally offering. Again, the feed IDs are right here. You will get the fastest possible for these only. But yeah, it's because we are right next to where the feeds are coming from to give you the secret there.
Yeah, that is important. Other questions? If we're seeing,
I think I went all the way up, so I think I caught most of them when you were asking initial questions.
Anybody in the call that's also in the YouTube that sees any questions, I do personally have another one, but I want to give other people a chance.
Sure.
Any others?
By the way, I have a question for you, if that matters.
Do it.
And again, not to put you on the spot, like
Never.
I don't know when this cohort finishes, but hiring from this group, how would that work if an employer wants to come, poach one of your students or something?
Well, I'm already talking to your folks.
Yeah, sure.
Yeah. So, the way it'll take a few minutes here. Be careful when you ask me something.
No. I mean, this is extremely insightful.
Yeah. So we look, right now, when we started, we just had our builders program where people were building applications using Anchor and TypeScript and shipping them to DevNet in 6 weeks as an MVP or proof of concept. Since then, we now have added this cohort. We added a pre-builders program because, we're getting 900 applicants just for the builders program, and 90 of them got in this time. People that would have gotten in previous cohorts would have, didn't get in this time because the quality is just getting up so much. So we created this pre-builders program. And then after graduating the builders program, a lot of those top folks from that go into one of our advanced programs, whether it's working with Pinocchio or doing an accelerated builder with all of this tooling and Pinocchio and token extensions and so on, or even advanced SVM where we're working in the banking stage right now. The easiest way for people to connect with us about talent and even research talent is to DM me. Let me know. That's how most of it works. People just get connected to us and they DM me or they ping me on Telegram or on Twitter. Last week we turned it around in 4 days. Someone reached out on Twitter. We got on a call. They told me what they're looking for. I got a sense of their culture and their vibe and what their technical needs are, because we only, help people that we've trained get jobs. Everybody I sent them, I immediately, as I was having the conversation, had a couple people in mind because I know our people well, and sent them the CVs that day. The next day he had an interview. The next day they offered him the job, and that was a Friday. And this past Monday he started. And as of Wednesday, the CEO is telling me he's crushing it. So doesn't always happen that fast, but a lot of times it does. People reach out and say, we need talent. We ask them what they need and who they are, and we make some matches. We don't send a million CVs, and we won't send them anybody that doesn't fit. Most of the folks that hire from us come back and hire again.
And it's pure engineering, right?
Well, it's engineering and research for the most part. A lot of people get product management experience with us, especially in our more advanced programs. And a few folks have, signed on as developers and have grown into CPOs. Rit Raff is a good example. Robert, he got hired to be a part-time dev at Compute Labs, and a month later, they made him the chief product officer. Because people come to us with existing skill sets. We're much more of a professional, polished organization than we're not a boot camp. So, people come to us with, I've got a background in this, or I've got a background in that, or, I've got a background in publishing, and, suddenly they're publishing beautiful research with great graphics. Oh, those people are getting jobs too.
Sure. This is fantastic. Congratulations on what you guys have built. This is excellent.
Thank you.
Yeah, so cool. And yes, Aditya, that's right. That's correct. I hopefully we did it some justice. Hopefully I helped you guys out. Either way, we're always available. We are considering giving some grants if you're building with Switchboard as well too. So if that's the case, or if you need any help, feel free to reach out to any one of us. And I think we're pretty much all technical on the team. So
awesome. Anyone
would work.
Awesome. Manny, thank you so much. I know you kind of got thrown into this at the last minute.
It was this morning. I'm sorry.
Oh, you're totally good. Dude, you killed it. You're great. Appreciate the flexibility and, we're used to this. This is, this is how we roll. I go into Pinocchio group every Monday and say, you're not allowed to work on anything that already exists. Go. So we're used to putting ourselves in very uncomfortable spots and working together to get less uncomfortable. I don't want to ever be comfortable. It's a bad spot to be. Anyway, Manny, thank you. Appreciate it. Everyone, connect with Manny, connect with Switchboard, take a look I'm going to be going right to that examples spot right there. Brianna, what do you think?
Yeah, I think as we've talked about earlier, with projects like constantly changing and iterating based on just general developer feedback, Switchboard has done just that. I tested it out back when we were building the developer bootcamp from Solana Foundation about a year and a half ago. And just seeing the docs page shared and the example shared, like everything has changed quite a lot. So I'm excited to kind of take a step back and revisit all of the docs page and see what's changed a little bit more in depth. So it's great to see just the tooling on Solana just always evolving.
Yeah, 100%. So one of the things that I want to, you know, as we segue into the next 6 sessions is, you know, to acknowledge that, you know, the first 2 sessions here have been kind of use case specific tools. You know, you may or may not need Magic Block, but if you're building a lot of use cases, Magic Block is going to make your application way better. You may or may not need oracles, but if you do, Switchboard's going to make your application way better. These next 6 projects, starting with Yellowstone Vixen, which Kyle is, you know, joining us momentarily, probably everyone that's building an application can use these. What do you think, Bri?
Yeah, definitely. Everything listed in for the rest of the day. I'm just looking at the agenda now, but everything for the rest of the day you can use pretty much in every single project that you're building. And it's fully building out like your tooling stack. So it's excited to see all of them just in succession as workshops and how they link together.
Yeah, I agree. And this was the intention. You know, the intention was, you know, hey Kyle, the old narrative of the DevEx and the tooling on Solana, that's dead. What we're going to see in these next 6 sessions is really a developer tooling suite that exists to help everybody and to help the folks new to Solana really know how to just have the best of the best experience in delivering applications. They are all also open source software. Contribute, lend your new lens as a builder on Solana to making these tools better. So, you know, with that said, Brianna, have you ever used any of the Yellowstone stuff?
Yeah, so I actually did a couple workshops just in general on indexing on Solana, and this was before I knew anything about Yellowstone, and I was like, wow, this is really difficult, and it took quite a lot of time. And then I found out about Yellowstone, and I was like, wait, this kind of makes everything so much easier. So it's great to see that this tool is built, and Triton does a great job just maintaining everything and listening to feedback and pushing updates. So
yeah, agree. I mean, again, we're talking about another antiquated narrative about Solana, which is the, you know, the old indexing narrative. But let's get into it now. You know, we are privileged and excited to have Kyle with us. Kyle has done a lot. I'll let him introduce himself, but, you know, most recently and relevant to this is he's been the maintainer of this Yellowstone Vixen for Triton, and more recently just went to go work with Jupiter. So yeah, I remember in the middle of the night pinging you on that, and I don't think anybody knew, and I'm like, don't say nothing, Jeff. Anyway, Kyle, the show is yours. Appreciate your time being here and all your effort.
All right. Okay. Am I sounding okay? Things are good?
You sound great, sir.
Okay, awesome. All right. Thanks, Jeff. And thanks for everyone who presented thus far. I guess so my screen is all shared. Is that, or do I have to do anything special with that? I need to share my screen, right? Yeah. Okay. Let's share my screen.
If I'm able to do that from here, that's bad news. That means I can get to you.
Yeah, that is bad, huh? All right, then we'll go into slideshow mode and we'll get kicked off. Okay. All right, so I'm here to present Yellowstone Vixen, which is a program parsing toolkit for transforming, unstructured Solana account and transaction updates into programmer-aware objects that you can then react to. So that's what we're going to be looking at right now. Is Yellowstone Vixen. It is hosted at RPC pool / Yellowstone Vixen. It's completely open source under the MIT license, because what we're going to be looking at is a library here. So you're able to use this in your applications to solve your data processing conundrums with Solana. About me, the name is Kyle Espinola. And yes, as of 3 weeks ago, I joined Jupiter Exchange on their RPC team. You saw, I guess, yesterday the announcement of the Ultra V3 and the addition of a product called Shadowlane, which is our own transaction forwarding network. We're also leveraging, our mass staked validator connections to offer those using Jupiter products kind of the best access to data and ability to get their transactions landed without any funny business occurring in between. You can find me on Twitter at SBCodes. So if you want to help me out, go drop me a follow as a thank you for the prezzo. And we'll get into it. I mean, overall, I've been working on Solana since early 2021, right when Metaplex launched and NFTs became the absolute thing in Web3. And this is where my indexing story started. I built with my previous co-founder, Alex Kahaya, one of the OG Solana marketplaces called Holoplex. So, throw some emojis in the chat to date yourself if you ever experienced or worked with Holoplex. It was a one-on-one NFT marketplace where creators, usually small-scale creators, could deploy a no-code storefront for selling their NFTs using Metaplex like Studio. It was like a off-spin of the original like front end, and then all of the original protocols. And the reason I brought that up is because we had a very kind of purist mindset when developing Holoplex, and that was no databases, only the blockchain, and you could take this application, deploy it on any S3 bucket, and connect to Solana, and you were off and running. If we went down, if we went out of business, there was no database that we were keeping. You could read all of your information on chain. Well, quickly found out over even 2 or 3 months as the token metadata program in particular exploded. And if you are a frequent Git program account user, you see that the larger the program is, the worse and worse and worse your performance gets with GPA. And not to mention, there is no method of association with the Solana JSON RPC. So, PDAs, program derived addresses, are an exceptional construct when you're developing a smart contract. But when it comes to querying those and linking them, you're kind of left out to dry. There is no method. You have kind of 3 primary methods in Solana for requesting all the accounts that you write. You have the great programming accounts, which is a list version with a filter capabilities that require you to know the data layout of your accounts, meaning that you have to like pass in an offset and say that it needs to match these next 32 bits. And if it's not, then you don't get it. You have, of course, get account info, which requires you to know the program address. And then its kind of counterpart is get multiple accounts, which is nothing better. It's just a batch GET request where you can send multiple accounts in. So
Kyle, real quickly, we're still seeing about me.
Yeah, I don't have a lot of slides. I don't have a lot of slides.
I just wanted to make sure.
So this is still the about me. This is still about me. Not a lot of slides. We're gonna go from the slides into code examples, okay? And these aren't my fanciest slides ever, but I think they'll get the job done, I think, if Jeff will allow me.
I'll totally allow you.
I'm joking. I'm just kidding with you. So I bring that all up is because as we were building the site, we started to lose market share because the site continued to go slower and slower and slower because we were making all these GPA calls to the programs that were exploding. And until NFTs came on to the scene, the access that you needed to the read layer of Solana was very minimal. Tokens don't have a lot of information that they're encoding. They have the mint, they have the amount, and then they have the owner. That's the token account, right? So you don't really need very expressive querying capabilities to do your early DeFi applications on Solana. But what ended up happening is now we made an NFT project. You have to show a lot of information. NFTs are made out of 4 accounts, so there's a lot of linking. I found out that you cannot rely on Solana RPC to provide a good experience. So that's where indexing came in. And about, I don't know, 6 months into doing Holoplex, we developed Holoplex Indexer, which you can still go visit today at Holoplex/Indexer. It was the first Geyser-based, first mainstream open source Geyser indexer that indexed token program and a couple variety of them and put them into a Postgres database and then lets you read it through a very expressive GraphQL API. And really, I mention that again because like this is where my indexing story starts. This is why I am passionate about this subject, because it really kind of tanked my first product experience on Solana, not being able to provide a good user experience and made it so that we eventually lost market share. And of course, FTX happened at the same time and NFTs kind of fizzled out and we transitioned to meme coins. So yeah, I've been working on indexing for a while and I have been passionate about that still. After doing Holoplex, I started a small agency where I worked with Triton1, and that's where we developed Yellowstone Vixen. Okay. All right. So yes, the sponsors of this project, of course, Triton1 managers or like repository owners, initial funders of this work, allowing me to build it. APK Labs was the small boutique lab that I co-founded after Holoplex that I kind of kickstarted this project from. APK Labs has two other exciting ventures that you might be interested in the tooling space, both open source. The first one is SVM Kit, which is a infrastructure as code operational toolkit that will let you go like 0 to private network in 3 minutes on any hardware. I'll show the link to that once I kind of get the slideshow out. But that was, really great projects. It's been helping a lot of teams that are wanting doing permission networks to launch their permission networks. And then more recently, they have FairMeter, which is an X402 implementation that is also open source, where X402 is allows agents or bots to pay for API access with a Solana wallet in USDC or some other meme coin. And then more recently this week, Jupiter has agreed to take over sponsorship or to come on board as sponsors of Vixen. So by no means is this project going away. It's only gotten more support as the Jupiter team internally has started to explore using it. And them agreeing to sponsor means that I can, use some corporate time to make sure that maintenance and I respond to pull requests as they come. So thank you to the 3 major sponsors of Yellowstone Vixen. Without your support, this open source project would not exist. What's the problem that Vixen is handling? It goes back to what I was saying with Holoplex. And for all of us that have been working on Solana, it has a very difficult data model and an extremely unapproachable query layer. You have thousands of transactions coming through, accounts being written, and everything boils down to what Solana is processing is an array of bits. Nothing is human readable. You don't have nice JSON payloads that you're used to working with when you're kind of building SaaS products. There is no codex for your programs unless you provide them with an IDL And even then, the IDL is just the definition of what these bits align to. There's nothing that's kind of helping you take the definition to real actionable objects. We'll look at Codama here in a few lessons, in a few slots, but you also see that Vixen uses Codama. Together, we attempt to solve that problem. If you want to provide a good user experience, you need to likely introduce indexing into your stack. And this also goes for people building trading bots and such. Like you need to understand what is happening on chain to be able to react, to place your orders, to really do anything. So Vixen is really a base building block that helps you tap in to Solana, decode it, and do something with it. Okay, that's the problem we're going after. So overview, it's a framework for building program-aware, real-time Solana data pipelines. And even the real-time, we've actually, kind of skewed. It's really any Solana data that comes in, and I'll show you that we released recently a Solana snapshot source. So if you have a snapshot and you want to do some like bootstrapping or historical look or look at the current state, I don't suggest you use GPA. I suggest you start using snapshots. They're way more ergonomic means of getting access and faster means of getting access to a bunch of the Solana state. You just need a machine that's big enough to hold them. So it has three parts that we're going to look at right here. There's the source, where you're going to be getting your change events. There's the parsing aspect, where you're going to be decoding it, the raw bits, into something that is program aware. And then you're going to finally be handling it. You're going to be logging it. You're going to be writing it to a DB. You're going to be pushing it to a Kafka queue. You're going to be triggering your bots to do actions. Yes, so that piece of it is generic. And so we'll kind of get, the more you go down this pipeline, the more user-friendly it gets. With, if you take a off-the-shelf parser that we'll take a look at, and you strap in your handler, you're ready to go. And the motivation was this is to really reduce the time to start getting actionable value out of Solana data, and to not have everyone on the planet writing indexers. Next, we're going to look at some code snippets. Before I take you into the repository, we're going to boot up some examples, and we're going to talk more about what Vixen is doing. But it's comprised of a series of traits. First, we have the source trait. So you're not just bound. This was originally launched as like a gRPC connection. And Yellowstone gRPC is a Geyser plugin that will that sends over change events being processed as the validator over a gRPC stream with structured proto definitions. But those proto definitions give you a data field with an array of bits. They give you an instruction with an array of bits. There's a very big gap between gRPC giving you the information and you being able to act on it. So this source trait has allowed us to extend the streams that we support, or the sources that we support. So we have Yellowstone gRPC. For Triton 1 has just released Fumarole, which is a persistent event log. I highly suggest, if you are building an index product or have dealt with gRPC and had to deal with multiplexing it, trouble with reconnects, Fumarole is going to be your friend. It solves these problems. It basically is subscribing to multiple gRPC streams, deduping them, putting them in a very large ScyllaDB cluster, and then giving you a Kafka-like consumer experience, a pull-based experience versus a push-based with that which you have with gRPC. So what that means is like you're going to have a cursor. If you deconnect, you can reconnect, and it's keeping it should be 3 epochs worth of Solana accounts and transactions. So there's a source for Fumarole, there's a source for snapshots, and there is a very introductory one that uses Git program accounts. So the source construct is very flexible, but yet structured. One, it has a config here where you're going to be able to define a very well-typed config for your source that we'll see will play in. We'll show you how it plays into the whole Vixen pipeline. But everything is very well typed here. So you have a lot of the code development experience that you love with Rust, where you have the introspection, you have the autocomplete, and of course you have the robust arrow handling. And then the heart of your source is your connect. Oh, sorry. Let's go into new. So you're going to boot up your new filter, your source. You're going to get the config, which is likely going to have like your endpoint and some of source specific options. And then you're going to get your filters. So your filters are going to initially they boil down to like they are what is used to put together your gRPC subscription or whatever else or whatever source you are. They're going to have all the descriptive information, like what program you want to subscribe to. Do you want blocks? Do you want transactions? Do you want to filter out by accounts included on the transaction? If you're doing GPA and to extend filters, that might include mem compare clauses onto it. And these filters are attached to the parsers. So you register your parsers that we'll look at. They have pre-flight filters attached to them, and those get kind of smashed together, and you get a single filter here that you can use to build your source. And then finally, you have your connect, where you can connect to any stream, any source you want. The only thing that you're going to do is once you get your data event, you are going to convert it into a subscribe update event, which basically it categorizes like a subscribe update is an enum. It has accounts, it has transactions. You map your source into one of those objects, and Vixen will take it from there. And you can map multiple different sources into a common data transformation pipeline. All right, so that's the source. The next is the parse. Parse has three aspects of it. ID is really just a unique identifier for your parser, so that internally Vixen knows where to send things, and that there's not kind of collision on the parsers that you have registered. You have your input and the output that you're gonna take. These are both generic. Output would really be that program aware object. So Vixen is not employing any sort of strict structure on you. You get to define the struct that you want to return. You just have to set it in your type definition on your output, and the end consumer can use a variety of different parser outputs for their handlers. And then finally, you have the parse, where the value input is gonna be that subscribe update with those raw bits. You're responsible for doing your parse, which you transform it into your output, and then that is what is eventually going to be handled in this final step. And then the pre-flight is, again, we're kind of a part of Vixen is certainly a convention over configuration. So one of the conventions we have here is that you can kind of pre-register what your parser is attached to. So mainly that results into a program. So your pre-flight, you would say that you are going, this parser right here is for the token program. The pre-flight encodes that information. And then instead of you having to put together a large subscribe request, Vixen is providing you a more friendly interface for interacting with different source solutions that require kind of more robust request payload. So that's the parse. Here's just a look at that pre-flight. So just to kind of give you an understanding of the kind of what type of Solana information Vixen is set up to use right now. Accounts, transactions, block meta, blocks, slot, very much aligns to the gRPC interface, but these are very common. Any sort of source that you would want to put together is not likely. This is the set. This is what you have access to, no matter what source you're developing. We can probably make pre-flights generic if you are doing something in between, but if you're working with raw Solana events, this is your set of objects that you can react to. Parsers. So there's a lot of indexers that were released early in the game that took your IDL and just gave you a finished API. I didn't really love that approach, at least personally for this project or in general. I wanted to have some middle ground. So the parsers themselves, like you saw, are just Rust traits. They're shipped as Rust crates. and you can implement your own parsers, writing them by hand, which we've done for things like the token extensions program is a good example. I think MPL, which I'm hoping to do some parsers for the Metaplex programs here soon. MPL is another one where they're dynamic. They don't have a static IDL necessarily. The accounts are resized. What is stored in the account varies. You have to somewhat decode headers into the accounts to understand what the rest of the information that is being stored in. So they're not necessarily conducive for kind of give me an IDL and start building me an indexer. So Vixen is certainly code first, but if you happen to have a well-structured IDL, there's a solution for that, and that's where we teamed up with Codama. So you're going to hear from about Codama later. I highly suggest you stick around for it, even more so than this project. Honestly, Codama is a game changer for the Solana ecosystem. But that team, it's started by Loris. It is now sponsored or maintained by Anza themselves. I believe they can correct me later. It's in its own repository under Codama, but I do think it's a product of Anza. And what we have done is we built a renderer for Vixen parser. So Codama, just a preface, will take an IDL. It will run a renderer through it, and kind of its introductory or its flagship renders are the TypeScript renderer and the Rust renderer. But we built a Vixen renderer. So now you can have that same interface where you provide an IDL, and Codama will handle the code generation and give you a ready to run Vixen parser. So we're continuing to work on this piece of it. Actually, the whole parser aspect of Vixen is kind of going to be the main focus over the next iterations of it. I think I'm very happy with like the source layout, the API of it, the handler layout. I want to do more on the parsers because there's a lot of variance there. There's a lot of different types that people can do. There's a lot of things that change there actively. Programs change all the time. So IDLs will be the next main focus, or sorry, parsers will be the main focus of it, and more specifically, how to make the auto-generated experience more user-friendly, faster, more intuitive. Okay, but for today, you can go over to Codama. You can go to Codama's renderer Vixen. You can take this snippet right here. If you go to the Triton docs, there's an article on how to do your Codama renderer, but this is all you need, right, to get yourself a parser crate booted. All right, so there is kind of like the auto magical piece of it on the parser side, but it comes kind of built on top of the base parser traits. All right. Then the last phase, and again, this is the simplest, right? So we went from the most complex, probably parsing is the most complex, but like source is complex, parser is a little bit more complex, but your handle is not. Your handle is not. Your handle will take the value, that generic type T, over any output that your parser generated, and it will let you work with it. This is it. This is the kind of, when you're actually doing most of your programming, you're going to be writing your handler. So this is when you get your nice program-aware object that has been processed through a lightning fast Crossbeam Tokyo queue worker queue system, and you're going to be able to react to it. So we're going to show you a basic logger, but with Hyper Meme Coin, put together a data pipeline which did a sort of facet mapping of different domains in DeFi, like AMAs and lending, all built on Vixen, and all kind of done with this handler. There's also Yellowstone Shield, which is an allowed delay list that lets transaction forwarders kind of selectively, or based on user policies that are stored on chain, decide who they forward their transactions to, who you want your transactions to be forwarded to. And that uses Vixen internally right now to manage the processing and the parsing of those. So there's a lot of use cases that you can build. Again, this is meant to be a very core building block. We're looking at code because this is not batteries included in product solution, but is meant to make it things that would take you weeks, months. We can now do in weeks or days, depending on who's built parsers out for you before. All right, so that's the handle. The config is ultra basic. You have a source here, and then again, your config will vary based off the sources that you use, but Vixen will run the typing checks on your config and make sure that your config, depending on the source that you register, is correct. So this is an example source for gRPC. So you have your input, you have your X token, and you have a timeout. Bang, easy peasy. No complex configs here. All right, now let's look at a basic example that kind of puts it together, and then I'll start booting up some code examples and showing you some more features of Vixen as we look through the repository. But okay, here's the basics. So we start at the top. We have our imports. We have imported the token program parsers, the account parser, and the instruction program. This is Token Keg, largest program on Solana, and the one with the most kind of traffic. And I'm going to boot it up for you. You're going to see things are going to be flying across the page. Next, once you have your parsers, you can import a bunch of these and register all of them here. You're going to pick your source. So again, it's a separate crate. You're composing here. You're not configuring. You're not turning on flags. You're composing your parsing solution. You're composing your indexing to your index needs. So we go ahead and take the Yellowstone gRPC source. All right. So those are our building blocks. We have our parser. We have our source. We build out our handler here. This is a logger handle. It's just going to be logging the values that come out. Boom, 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 boom. But your handlers can be complex. They can register database connections. They can have their own states to them. They, they can take Kafka connections that are attached to them. They can take a Postgres connection to them. So another common one, right, is we can take in the Solana program change event. We can match on it nicely, and then we can write it to a database. So your handlers you can build out, right? There are structs. So that this struct is a unit struct. It doesn't have any fields on it, but that doesn't mean it has to be like that. You can add fields to it. You can instantiate it and then pass it down to your to Vixen. So once we have those three core components, we assemble everything. So we take our Yellowstone runtime. We set in as a generic the source that we want. This is where that magic is happening. Not magic. I mean, this is just Rust. Where it's going to be type checking everything against the source that you have registered. It understands that this Yellowstone gRPC implements the source trait, so it knows how to interact with it. It knows how to call new on it. It knows how to connect to it. And then we start our big registration process. So there's there's a couple registers. Every one of those pre-flights that we saw has its own register method. So account is for all your account parsers. Instruction is for all your instruction parsers. Block meta is for your block meta parsers. Slots for your slot parsers. So you can and you can chain these together. So you can register a bunch of accounts, a bunch of instructions, a bunch of slots, and instead of having to put together a kind of a hash map that you send over to gRPC, you now have this typed, well-defined schema that will put together that in subscription for you and make the connection to gRPC a whole lot simpler. And then finally, you build it, you pass in your config, and we run it. It has two run methods. We have the synchronous version here that doesn't require a Tokyo runtime. So you see we have no Tokyo runtime here. And that will be just kind of run until you press Control-C and exit out your program. Then you have run async, which will give you a join interface, a handle that you can await. You can boot up multiple Vixen runtimes in their own kind of threads and then join them all together and then wait for those. So the run async is probably the most flexible one. The one if you're building an application that has a bunch of other Tokyo processes running is the way to go. the run is this kind of your simple, like, this is the only thing this application is doing is running Vixen, is where you want to use run. Okay. I'm gonna switch over to okay, we're gonna switch over. We're gonna go look at the Vixen project, and I will pause right now. And while I'm doing that, go ahead and look at anything that might be happening in the YouTube chat. So I'm gonna stop sharing this. I'm gonna adjust my displays on my computer because I have the big wide monitor. Is not good for this. Displays, optimize for my MacBook. Okay, and then in chat, let's see here. Is Carbon actively maintained? Yes, Carbon is actively maintained. They're going to present on that as well. You know, they another great open source project that handles indexing for you to take a look at. You can now compare and contrast based on this and that, what aspects of it, you know, you like, what you don't. But I'm happy to see multiple indexing projects out there. So yeah, pick which one works best for you. For parsing Vixen with raw responses, yes, Nerman, that's exactly how it works. Is Vixen is modular, uses Dragon's Mouth for uses Dragon Mouth as the primary source. It uses Vixen parsers for parsing. And it exists to take the raw, unstructured Solana events and make them into structured, actionable objects that you can actually do stuff with. And having decoders as well. Oh, main difference between Carbon indexing framework and this. You know, honestly, like it's really going to be two different approaches. It's going to be two different approaches. I think what you'll see is we have some things built in, like Vixen we built for building projects at Triton, right? And we build production grade products. So I'm not saying that Carbon is not production grade. I'm sure it is. And I look at it too for reference, and I imagine they look at Vixen as well. But we have like Prometheus metrics built in. We have tracing telemetry. We have a streaming solution that you can actually register the parsers, and it will boot up a gRPC stream. And say if you're not kind of like a Rust native developer, but you still want to use Vixen, you can simply boot up the gRPC version. You don't need to build a handler, but then you can go use a programming language that you want to interact with those parsed accounts and instructions. And I'll show you the stream version later. So you know, there's the majority of it it does overlap, but you know, I hope that we can find our niches and both have very prosperous open source projects on Solana. When to use Vixen and how is it different from others? Others you'd have to specify, but I would just say look at how Vixen's structured, look at the sources that it's used. Is it an experience that works for you? Then pick it up, give it a try. Yeah, okay. So let's go into the code stuff now. And that should kind of give more light on. All right, so I'm going to share my entire screen at this point. Okay. So yeah, I mean, I got to plug right. We got Triton 1 docs here. If you want some other kind of sources, if you want like a more in-depth on doing the auto-generated parsers, this kind of gives you the full rundown of what you need to install. Would use with Codama and run it, because this is kind of this is what we get asked about the most, and this is what changes the most, is kind of people change their programs and parsers need to be updated. Okay. This is me on X. We didn't do that. Am I sharing my screen? Yeah. Go show me some love. SV codes. Thank you. We'll close that one out. This is Yellowstone Vixen. Let's send some stars over this way too. Great project. Let's give it some stars. Again, hosted at RPC Pool, Yellowstone Vixen. And let's just quickly go through the README. Now, like, let's shift. Like now, you got the main spiel, and now you're kind of like a developer. You saw Vixen on X, or like the wonderful folks at Turbine shared it with you, and now you come over and we're gonna review the README. The problem space and the overview we already talked about. We won't go into that. You know, here's kind of some of the differences. It also has a really nice testing harness when you do your parsers. Has very good metric support that we're going to dive into. And then the source layout, I think this is very ergonomic way of doing that. There's very little kind of config or runtime related code. This is very static. So your compiler is going to be doing a lot for you here to make sure that everything is in the proper place and you're using Vixen correctly. So I think you know, one part that I pride Vixen on is that I attempt to use Rust to its fullest, and we make use of generics. We make use of the well type nature of it. So I think that, you know, kind of this interface of it is kind of a spot where I think it differentiates itself from other indexing projects out there. But again, use them, figure out which one works for you the best. Supported programs. There is a variety of supported programs, and I'm going to be working to expand this as we go down this like parser improvement arc. But we have the big ones, you know, Jupyter, Camino. Now that I joined Jupyter, we certainly got to get all of the Jupyter ones in there. Pump Fun, Radium, Whirlpools. There's also, you know, in this crate here, in like the original parser crate, we have token extensions program and token program. You know, you really can't be doing anything on Solana unless you're using those. The token extension one, we can kind of understand like what's happening when it looks like a see there's like, so for token extension, the other thing that's nice about the parser not being kind of auto generated is you can use other crates out there. So the token parser, you know, makes use of SPL token 2022. It makes use of the extensions here. So like that's the other reason I did it as a Rust crate first, or we did it as a Rust crate first, is because there's already a lot of like crates out there, projects out there for transforming this data, but it's not kind of packaged together. So instead of re-implementing all of that, we instead provided an interface for you to plug this stuff into, and a way for the whole kind of system to weave together. And that's how you kind of got these kind of more advanced parsers where you get like extension types, and again, it's dynamic, so it's not really in a position to be kind of auto generated. That's why this exists. And you can here's kind of a look at the pre-flight. Let me make my screen bigger too. Here's a look at the pre-flight. This is helping you interact with the Dragon's Mouth subscription, right? It's kind of registering this account owner. It's going to take the other parsers that also take their pre-flights, and it's going to bundle them together, and it's going to build the subscription for you. When I was first working with gRPC, or if you use Yellowstone gRPC a lot, you can subscribe to a lot of things. You can do a lot with it, but putting together that subscription is kind of like challenge number one with it. Challenge number two is staying up to date. The more information you listen to, it's push-based. So if you lag behind and your window size kind of exceeds kind of that in-flight buffer, you're going to get disconnected, right? So like the other reason we built this in Rust is that we needed something that could keep up with Solana, and there's very few programming languages that can keep up like with Solana, except for the one that it's written in, and that is Rust. At least Agave, I'm sure we can do a kick-ass one in C, and I imagine Zig is another good candidate. But you really, I mean, Go would be too, but you really need something that has like concurrent constructs in it, base threading capabilities in it. Like otherwise, you're just if you're trying to do this stuff with JavaScript, please just stop, reconsider what you're doing, learn Rust, and welcome to the dark side. Okay, you're not going to be able, if you're listening to a lot of things online, or like a lot of accounts, the single threaded JavaScript runtime is not going to be able to cut it. All right. So just just don't do it. Stop asking for JavaScript kind of things, you know, just send transactions. If you're going to be building bots and stuff like that, build it in Rust. Build it in Rust. Okay. Parsers. Okay, those are the parsers. Okay, here's the sources, and then we'll get into the demos. We have the Yellowstone gRPC source. We have the Fumarole source. We have the Solana RPC source, which uses get program accounts. Let's go take a look at that one in a second. And then we have this very nice new one that I hope to continue to build on, which is Solana snapshots. Now, again, I want to see more snapshot usage. I hope that we can build more tools that give better access to snapshots. But if you are kind of like abusing get multiple program accounts and abusing get multiple accounts to get access to like the current state of the chain, start understanding how to work with snapshots. I mean, you know what? Take that back. You don't need to start like, if you want to start contributing to it, they're not well documented. They're not easy to work with. So I'm not going to tell you just to like get in there and start working with snapshots. We need that next evolution of tooling. So like Vixen is here to try to help that kind of working with the snapshots. This gives you a stream that will read the files, give you, let you set kind of like how many files you want open and just feed them through the Vixen runtime. So like all the like layouts, the deserialization is all handled by the snapshot source. And even that one is using the accounts DB crate. So I mean, that's also why, yeah, that's like, again, we want to work with other great open source projects. So, you know, most of this is actually done off of Solana accounts DB crate. It gives you this account file read, which is, I won't look too much longer. Right here. Where are we? Right here. Gives you this accounts file, new from file. So that's taking the heavy lifting, right? Like I didn't write a custom like parsing solution here, and like we use like things that Agave is already, or Onza is already building and shipping with the Agave project. So this takes does the hard lifting, and then it gives you a scan accounts, and then you get your account, and then like I said with the source bit, you are converting it into the subscribe update. So we're taking the snapshot, which is called a snapshot update, I think, and then we are converting it, we're mapping it to a subscribe account update, and that's it. Then you do the transaction send, and you can run your program parsers on it and run your handlers on it. Bam. You can even filter by the account. And honestly, this is what the validator is using when it boots up. You might want to elaborate on snapshot hash if you could. This is active. Like this is kind of a first version. I know there's more to be done with this one. We actually have a PR from Fernando, which was one of my colleagues, is now working at Triton. He had some more improvements to it. So if you are knowledgeable on snapshots, or if Turbine wants to do a cohort, you know, that would be one that I would like to be a part of, and I'd love to like build out a very good snapshot system. I know Kirill, who is the author of Yellowstone gRPC and more recently of Rechat. Also, we also have plans to kind of like give faster access to the current account state. So stay tuned. There's passionate people that want to make sure that you have everything you need to build great applications. All right, so that's the sources. And all right, let's get into the demos, and I'm almost done. Okay, so now let me stop sharing once more. No, I was sharing my whole screen, so let's go back to doing that. Share the whole entire screen. And let's go and check this out. All right. Okay, so I have, I think, 3 demos for you that are all based on our examples. So crates, you have all the crates that make up Vixen. If you're looking to contribute, like of course, like parsers, great way to get started. gateway to get in there, get your feet wet. We're happy to host parsers. We're probably going to break these out because they're just kind of starting to get a lot of them. But if it's a major kind of DeFi product, certainly if it's a Jupyter product, the PR will be welcomed. Then we have our sources like that are suffix with dash source there, parsers with dash parser. Runtime is the main bulk. That's where your handling is happening. That's like what's kind of connecting to your sources. So if you want to come contribute, the runtime is the meat of it. Yeah. Okay, now we're going to look at the examples. All right. So let's start with tracing. And this is where like, you know, I hope to get some different, like differentiate Vixen is like, it supports open telemetry tracing, which I believe is, I would say is a must if we're doing production grade products. So we're going to boot up Vixen right now. We are going to listen to the accounts token program, accounts parsers, instruction parser. And then our handler, ultra simple. It's going to take that generic and we're going to trace it with tracing. But this, like, if you go look at this example, I kind of gutted it, but it shows you how to do the full, like, what is it? OTLP? Yeah, setup where you can like push these traces over gRPC, hopefully get them in something like Tempo and start looking at them in Grafana. And actually last week, someone did a nice tracing addition there. So you can kind of start getting timings within the traces. Traces are very good for, you know, understanding a lot of information, still structuring it, but also doing timings in there. Traces are really good for that as well. So you kind of, you start a trace span, you end it, and then that gets attached to the trace and you can start understanding like how long things take you or how long things are taking. But here we get our runtime again. We set the Yellowstone gRPC source and we set our instruction and we register our handlers. Handlers is an array. If we wanted to do more handlers, we could. So they're just going to kind of take the instruction and it's going to pipe it through the different handlers here. And then we're going to build it. Again, example config here in the repository, but we're just setting our endpoint and then we're going to run it. Okay. All right. So let's go over the terminal. Let's start this one up. Okay. So I'm in the tracing directory. I have a simple config and I kind of went 2 directories out to the root to do the Vixen tone. Okay, so there we go. We are now subscribing to gRPC, running it through the token program, and watching the chain like it's the matrix. Okay, so and you see this is just zoom in. I'll show you the rate at which we're getting things here in shortly. All right, so we're going to exit out of that, right? Clean exit, very nice. Here's kind of what you get. Here's like a token account. So the parser took the very generic. We got a token account here. We have the mint. We have the account. We have the mint. We have the owner over here. We have the amount. If it's delegated, is initialized. So that's a token account. Of course, we're going to have a bunch of those. We have some close accounts coming in. We have some transfer checks. I imagine we have some mints around here somewhere. So the transfer check, right? That's the transfer instruction. So that's an example of an instruction coming in. And yeah, you got all this. So if you registered multiple there, you're going to get them here. And you can type this too. This doesn't need to be generic. You can type this, and then you can start doing whatever you need to do with those events. But Vixen, again, they take care of creating your subscription, parsing your stuff, and packaging it together into a convenient handler for you to work with. So that's kind of like the most basic. That's just kind of subscribing to the chain and logging things out. All right. So the next thing to show is Let's go look at Prometheus. Prometheus. With the feature flag of Prometheus, Vixen runtime exposes another method of metrics here that lets you, that expects a Prometheus registry. So this allows you, like if you're building an app, I hope you have some Prometheus metrics in it, but you need a registry there for all your applications metrics. You can take that same registry and you can pass it to Vixen, and it's going to add on top of and add to your metrics endpoint the Vixen specific metrics. And they are mainly kind of like success and error count metrics right now. Okay. And then in this setup, we've set up a Prometheus push gateway so that this normally this could be you know, the endpoint that you serve, where you have like your very common /metrics, but that would require booting up a web server. So we did the Prometheus push gateway in this example, but they both work. They're all working off of the registry. So let's go take a look at the metrics. All right, so let's make sure how is everything's running here. Okay, so in the project, there's a Docker container that will boot up, you know, a local Prometheus setup for you. And here we can take a look at all those token accounts coming in. So we're doing about 3,000 token accounts up to 4,000 token accounts per second. We can take this and go measure instructions. You don't like my metric? Here's a counter, my friend. I don't know. I had the Palm query right. Interesting. Okay. All right. Well, there was 5,000 of those. I mean, this is not a Prometheus example, but I do find myself spending a lot of time trying to get Prometheus queries right. I'm sure you do too. But yeah, here's the success. Again, Prometheus registry built into it. You have the Prometheus feature. You pass in your registry, and it's going to connect to the other metrics that you're kind of emitting with your application. So again, I show the production grade. Production grade, we need observability. So Prometheus is a first class feature of it. Tracing also utilized. And I think my last example for you before we just kind of look at some other stuff is the stream feature of it. So there is kind of like a pre-packaged handler, which is a gRPC stream. And it has its own runtime of sorts. It's kind of a wrapper around the runtime. Let's take a look at it. So instead of like the Vixen runtime, we take the Yellowstone Vixen stream crate, we boot up a server. You can pick whatever source you want still. And then this one's kind of registering a bunch of different programs. If you use Codama, it will generate the proto definitions for you as well. That means that this is registering kind of like the proto definition for each of those programs. All right, and then we have like instead of filter, we have proto. So this is kind of like this is already like a building block built on top of a building block, and that this is going to give us a gRPC stream. So this has been booted up over here. I'm going to use gRPC curl, and I'm going to pass in a program filter of token. And then there we are. The same kind of like a zoom of logs that we got there. Except this is token extensions, so less traffic, less things jolting across the screen. But even in this is like even the proto definition is kind of, you get this nice transfer check there. accounts, right? Extensions are all available. So yeah, like this product was made. There's a hosted version of this that you can access at Triton. If you just want to kind of get an API token and start using it. Or if you want to build out your own gRPC stream and then, you know, do some indexing or with your favorite language. I guess this is where, you know, TypeScript comes in, Python comes in, Golang comes in. This piece of it was built for people that wanted to program in a different language, but still wanted to have the parse data feed. So it doesn't require as much Rust. It's more of kind of like registering things. No handler here. The handler's kind of handled by the server. And that's that. I think if you want to do more filtering, you can compose on additional filters onto your instruction set with this filtered pipeline. It gives you an addition filter. Again, we're composing now. Now we brought in a different thing and we're composing in. So the Radium parser is just going to look for instructions associated to the Radium program, but this will now expand it and say, I only want Radium instructions where the transaction and cloud accounts includes, or the accounts on the interaction includes either one of these. Or transaction account. So if you want to subscribe to less, because one thing, you're going to get billed by bandwidth. And every provider is going to bill you by bandwidth. So I also recommend, you know, take care, filter things down. Either it's gRPC, whether it's laser streams, you're going to get charged by bandwidth. So just subscribe to the things you need, and that's what this kind of filtered parser is here for. Is allowing you to kind of even further tailor your filter to just the information that you need so that you don't get an excessive bill at the end of the month. You're welcome. Okay, that's filtered pipelines, and I'm pretty sure that covers it. Now let me just come over to conclude the repository. I want you to get involved. I want you to get involved. Come over here, check out the issues, post problems. Don't open pull requests into a fork of Vixen that you are maintaining and then close it, because I've been seeing that happen. Any open source like maintainer, that's the worst, man. I've seen that some people open up some really nice changes and they immediately close it because they're keeping a fork of the project. I get it, you fork it, but the reason it's there to fork is so you can contribute it back. All right, like, come on, let's not do that. 72 forks out there, 72 forks, not that many not as many contributions as forks. So please come check out the issues. After this, I meant to write more issues, but I'm gonna put some issues out there. One that would be great is benchmarking. Performance is very critical to this project. If this parsing engine introduced lag, then it's no good to you. For those that are obsessed with benchmarking, I would love to see CFG bench into this project, where we kind of take a fixture of 10,000, 100,000 fixture sets, run it through the runtime, do the logger, just make sure that we're maintaining good throughput. I also think some fire graph, some flame graphs is another one. Alessandro is obsessed with flame graphs. If I could walk into a meeting with him with nice flame graphs, I'm sure he would be happy, and so would I. So making sure that the CPU and memory is in a good spot. You know, these are all things that we're starting to look at. I think the API, again, I feel happy about. If you have any recommendations on the API, let me know. But I do feel happy about the benchmark. The next focus coming up here is going to be on performance and on expanding parser coverage, meaning likely to add some like macros and things, maybe take some burden off of Codama, put it into Vixen, so that if you did want to write your own parser and not use Codama, you at least had some things to help you get the parser out. That concludes my workshop. Thanks a lot for listening. Thanks a lot, Turbine, for having me here and supporting the project over the last couple of months. It means a lot to me, and you all are in good hands with Turbine. Thank you.
Thanks, man. Wow, brilliant. I mean, that was brilliant. You know, we've chatted, and you know, I've heard you talk about your work, but I've never seen you do a workshop before, and that's yeah, that's professor level stuff there. So Kyle, thank you so much. That was that's going to be a part of this video that people are going to come back to an awful lot. And you know, folks, to Kyle's point, you got to contribute. And a little bit deeper to what he said, you got to know how to contribute. You know, the people that are on the GMeet side of this call, they know that we talk about this almost every day. You know, how do you work with issues and PRs and forks and things like that. And, you know, even our pre-builders got into their first tasks and they're like, I don't know how to use GitHub. You have to. If you want to go anywhere in this industry, you got to really work with it. And the best way to work with it, you know, watch a video or read it, and then just go and do it. Okay. But Kyle, thanks, man. Appreciate it. Appreciate your time. I know you're busy, got lots going on. We'll do the best we can to respect your efforts by reciprocating with open source and continuing to support Yellowstone and Vixen and Jupiter and all that you represent. So, Brianna, thanks, Kyle. Brianna,
Yes.
what's your thoughts, kiddo? I mean,
I definitely love when workshops just jump straight into code and demos, and that was great. One thing I wanted to point out though, so not too long ago, I did a live stream with Loris on Codama on my YouTube. And one of the things that Loris mentioned was there's the ability to have custom renderers with Codama. And at the time, no one had built one yet. So Loris was saying, like, I'm really excited to see them being created. I hope someone does. So it's great to see that Vixen has a renderer, and it's kind of just tying in what we've been talking about throughout all of these workshops is everything's building so fast and like iterating on Solana. So like in the tooling stack. So seeing like this build out and it being demoed today was awesome.
yeah, I agree. And I, you know, one of the things that is part of our purpose with this day and our work together, you know, it's funny. This topic actually came up between you and I long before Toolapalooza was an idea. And that was like, you know, what did you ask me and what did we talk about? Go ahead.
We just talked about how there is a lot of tools on Solana and sometimes it gets overwhelming and things are always changing, and how can we show everyone what exists, how it works together, like what are the best use cases. A lot of times people know what the tools are, but not, hey, like when can I use this? Like what are good examples? How can I integrate this in like my day-to-day like dev building on Solana? So yeah, it's great to see everything here and how it all comes together.
Yeah, and I mean, Kyle actually did a really nice job of referencing, you know, the interconnectivity between Codama and Vixen. I love that he was mentioning the benchmark testing, the profiling, and the flame graphs at the end. I think that when Alessandro came and worked with our advanced SVMers probably about 6 months ago, I think we all were incredibly wide-eyed about the flame graph. That was super fun to watch, and fun to watch him, you know, play with his profiler. So this is all, you know, it is all connected, and it really just takes a little bit of research, a little bit of work, a little bit of getting dirty, a little bit of the mindset of, you know, it's probably not going to work perfectly right out of the box for everyone, every single time, for every use case. And that's the difference between being a developer, an engineer, and then someone who is just using AI. Okay. Venture to guess that if you go and look up Vixen Solana on Claude or Gemini or Perplexity or whatever, you might get a little info, but you ain't going to get what you just got.
Definitely.
And you won't get what you get from playing with it and getting your hands dirty either.
Exactly.
So with that said, the next of our guests, we're going to get into LiteSVM. Am I correct? LiteSVM is next.
Yep.
So, our own CTO, Andre, who works with LiteSVM probably as much as anybody every single day, and is leading the charge in our new accelerated program with everybody, and they're using that every single day. Hey, look, are we matching? No, you're not. You're wearing whatever. Strawberry Andre. All right, so Andre,
give me a minute though. We can be matching.
No.
Just keep on talking for a minute. No, it's fine. It's a challenge. I even have my Toolapalooza mood right here, as you can see.
I don't know if I'm capable of talking another minute. Do you guys think? I mean, Brianna, what's your favorite cheesesteak place in the city?
Well, I'm biased. There's one near me. It's like Joe's Steaks and Soda Shop, and it's like old school milkshakes. So big fan. It's like still the original design inside with the stools at the bar to get like your soda. So
is it like malt milkshakes?
yeah.
So everyone here knows, may or may not know, that Brianna and I are actually from the same city. Of course, I'm much younger than she is, so we didn't go to school together. But we like talking about cheesesteaks. And there is a relevant point to me bringing up cheesesteaks. Oh, Andre, very nice. Very nice. Since a lot of people are building for the hackathon, your hackathon projects are like cheesesteaks in Philly. There's 100 restaurants that make them. They're all busy. They're all good. Yet they're all just doing the same thing: meat, cheese, and bread. So even if you think you're building something that is like somebody else, add your own flavor and your own experience, and don't worry about what anybody else is building. Just always the advice that we give on that topic. But Brianna, do you know Andre? Should I make a warm intro here?
Please, of course I know Andre, but please make an intro for everyone else.
Look, Andre came to. You know what, Andre? I'll let you have it.
No. I want to hear it.
Oh my gosh!
I'll start sharing my screen while we do that. Like, I really want to hear it.
I mean, look, Andre came to us over 2 years ago as a cadet in our builders program out of Aki. And he just, within the first week, he was already in office hours helping other people in the same boat as him. So he was obviously a leader and somebody that, was very mission aligned with us. And, over time, started working with us, started teaching with us, became our CTO, and, really, I knew the first time I saw you in the office hours helping someone out. I knew. And I said to Nate, I said, this guy's going to teach with us and work with us. And now, he's our CTO, and which means a lot of leadership in the classroom and developing these programs and contributing to, the ecosystem and, leading our dev shop and really everything we do. So, and he's also a good friend of mine. And so with that said, Andre, the show is yours, sir.
I cannot live up to that intro. Like, next time, I think I'll do my own intro. People then will not put much pressure on me. Anyway.
Okay, no,
everyone.
You can skip to the next one. Who's next on the list?
Perfect. All right. Awesome, guys. If you have any questions, feel free to ping me on Discord or whatever. It was really nice seeing this presentation. All right. GM, everyone. How are you all feeling? Are you enjoying Toolapalooza? Well, I am for sure. As I said, I already have my Toolapalooza mood lights. For the ones that don't know me yet, you're not missing much. All right, so my name is Andre. I'm the CTO at Solana Turbine. So now you can ask, what does the CTO of Solana Turbine do? Well, most of the time is babysitting or being babysitted by Jeff. And that makes like 70% of my time. And the rest is basically taking care of tech on the dev shop and crafting new curriculums for new teaching programs. As most of you are aware, and because we have a lot of a lot of grads and current students here, and I'm actually pretty happy to see it. We run different programs where we try to take developers to the next level in this ecosystem. And we have been pretty successful at doing it. But one thing that we realized during our programs was that testing was somehow a dark room for a lot of developers. To tackle that, we start looking at different options and teaching them at different cohorts. There are a lot of different cool testing tools out there, and today we'll be focusing on LiteSVM. We will cover what LiteSVM is, why is it good, and when you actually use it, because it's just a tool. It doesn't mean that it's suitable for every single process of your program. We'll then look at a really simple example, and in the end, I can share the repo and throw a simple challenge for you guys to try on their own and actually to see how easy and fast it is. So let me do this. What is LiteSVM? It is a fast and lightweight library for testing Solana programs. It works by creating an in-process Solana VM optimized for program developers. In process, what does this mean? This means that the Solana virtual machine runs inside the same operating system process as your test code, rather than as a separate program. The traditional approach, where you use your Solana test validator or DevNet, is that you have your test code process and the validator process. So it's two different processes, meaning that your test, let's call it process A, will interact with the validator process, let's call it process B, through RPC calls. This means that we have two separate programs running. There is communication between process A and process B happening over RPC calls. And you need to start up a whole validator in case you're using a local test validator or being reliant on the status of DevNet. With this LiteSVM approach, it's way easier because everything runs in one program. It's a single process. There is direct function calls, so you don't have this network overhead of these RPC calls. There is no separate process to start up or stop. You don't have to start your local test validator and then send in transactions to it. And it's like basically like calling a library function. Why is it optimized for developers? This means that LiteSVM focus on what we as developers really need for testing, rather than having a full validator. What do we need while we are doing our tests is actually execute our program instructions, being able to check account states, simulate transactions, test program logic, load programs, and get transaction results and log on the transactions. That's basically what we need to test our programs while we are doing unit tests or integration testing. What we don't need for most of our tests, and that actually LiteSVM will skip, is we don't need a full consensus mechanism. We don't need a full RPC provider. We don't need block production or validation, and we don't need any extra protocol kind of irrelevant to your goals at the moment. With all this, it's much faster to run and compile, and it's available in Rust, TypeScript, JavaScript, or Python. We'll be focusing on Rust for this example. So how to use it? Simply just run cargo add LiteSVM --dev. Adding this --dev will add it as a dev dependency. What is a dev dependency? A dev dependency is a crate, library, let's call it crate since we're talking about Rust, that is only needed during development and testing, but not in the final compiled binary that the users will run. So dev dependencies are basically like a test only import, let's say it that way. It's only used when you do the cargo test or cargo bench or different examples. It's not going to be included in your cargo build or your file binary, and it's perfect for testing. Think of it as you're saying, oh, I need to develop my code, but users don't need to run this for their code. Key features and capabilities of LiteSVM, basically why to use it. Deploy programs. You can deploy and load programs from a compiled.so file. Time travel. Let's do time travel. It's really useful when you got these time-dependent programs like vesting, auctions, or something related like that. It lets you write arbitrary accounts. This is, for me, one of the best features. You can write any account state, like imagine a fake token balance, right? It's perfect for testing purposes. A lot of times you want to mimic like even using the USDC mint. So basically you can just set a variable, a pubkey variable with the USDC address, and then just create a token account with whatever amount you want for that USDC token. You can as well copy accounts from a live environment, but you actually need to do it manually, as LiteSVM doesn't have any built-in RPC fetching. Deploying programs. You can just dump a program or pull a Solana program from mainnet or devnet using the Solana program dump command from the Solana CLI, and then you can add that compiled program to your test by using the .add program from file, which will get that binary and load that into your SVM instance, as we will see in the example in a bit. Time travel. This, for me, it's one of the best things as well from LiteSVM. You can dynamically overwrite the clock sysvar. Many programs rely on the clock sysvar, and with LiteSVM, you can dynamically change this. It's awesome. So you can see right here in this example, we just get the clock sysvar from the LiteSVM instance. We change the Unix timestamp, and then we just overwrite the clock sysvar. This is really cool. If you have any kind of time-dependent logic in your program, you can now test it. It's freaking awesome. And if you're just as well, you can just jump to a specific future slot with warp to slot. If you're not looking at timestamps and you're looking at slots, you can achieve that quite easily with just warp to slot. Again, writing arbitrary accounts. As I said before, you can just create a pubkey variable with the address of, for instance, the USDC mint, and then create a token account with any amount of it. So you can just give a bunch of USDC to the US, to any account, even if you don't have the USDC mint keeper. This is really convenient for testing because it means that you don't have to work with fake USDC in the test. You just use the right mint address. So then if in your program, if you're using a constraint to the USDC mint address, you need to be thinking like a lot of times that we do like, oh, then I have the USDC mint keeper, so let me just create a different mint, and then I need to put I need to comment the constraint for the USDC address, and hopefully then this will work into production. That's fine. With LiteSVM, you can test that logic with the USDC mint itself. Again, copying accounts from a live environment, pretty damn easy. I'll show that in a bit. Now, when to use LiteSVM? It's really good for fast unit integration testing of the Solana programs, testing the program logic and the client code, to run tests frequently during development. Imagine like you don't want to have either your local test folders are always running, or just deploying your program every single time, or sending it to DevNet or whatever. You don't have to. You can use it now, LiteSVM, and have this really fast feedback loops. And you can actually see as well the performance by checking the compute units usage of your instruction. There is not a proper benchmarking, so let's put it that way, but you can create your own and take care of that. It's not ideal if you require full RPC compatibility or real validator behavior during simulation. Again, features you can have with LiteSVM compared to Web3.js. You can have a lot of the things, as you can see, that Web3.js gives you, like transaction support, state persistence. LiteSVM does have it because have AccountsDB, multi-language support, although we'll be focusing on REST for the example. And thanks, Brie, for the awesome crate. I'll mention that in the end. LiteSVM is available in TypeScript and Python. And you can have then additional things that you cannot have with Web3.js. It doesn't require a full validator. You don't have the network overhead. You have extremely fast speed since it's not network dependent and runs directly in your local machine. Also, I did found, and this is actually where it's a personal opinion, I also find that the learning curve is easy since the API for me is pretty good and doesn't have much verbose, right? There are other testing tools out there like Mollusk, which in my opinion is pretty awesome as well, but works more on instruction level and on transaction level, and it's a little bit more verbose from my perspective, right? Since I find myself needing to write more code to accomplish the same thing and more, and so and I need to add more boilerplates to my tests. But again, this is a personal opinion. Mollusk is still a pretty cool resource. So yeah, some resources. If you can screenshot this, and later on I'll just jump into YouTube and pass this link. So you have the LiteSVM docs, which are really good, getting better. Let's say, let's say it that way. Then we have this Escrow example that I'm gonna show as like the test for the make. So my suggestion will be fork it and try it yourselves to complete the tests for the rest, like the take or the refund. This is actually a cool task that we actually gave in some of our programs, so our students can actually get a grasp on understanding how LiteSVM works. Also, have a look at Codama. I know that there will be a Codama workshop later on, but let's put it on a high level. You will be able to generate Rust client code from Codama and then use that generated code in LiteSVM tests. So it will be really cool as well. And the mention to the brief freaking awesome Bazinga anchor LiteSVM Rust crate example. So basically now we have anchor LiteSVM Rust crates. That's freaking awesome, which covers no manual discriminatory handling, no manual account metadata or transaction construction, no account or account ordering does not matter anymore. That sometimes is a pain in the ass for me. So no manual instruction serialization. It's pretty cool. Props for that. And let's look at an example. Let's stop sharing this one and start sharing the different one, which should be somewhere. My screen is a mess. Here we go. Window should be okay. Yes, I'm gonna pump this up before anyone complains. This is just a normal anchor program that actually grabbed from a passel in a turbine builders cohort. So actually did try to test this in a previous escrow program. And as you can see, it's just a regular escrow with some state accounts for our escrow with the Mint A, Mint B maker. I believe you are all familiar with this by now. And the instructions with the make instruction where the user offers a token in exchange for another token. The take instruction where the taker accepts the maker proposal and then the transfers the token to the maker, and the escrow transfers the funds to the taker, and a cancel/refund operation where a maker can cancel an escrow proposal if he's no longer interested in having that proposal out there, as long as it has not been taken before. Most changes are actually the dependencies that I have in my cargo.toml. As you can see, I have the LiteSVM as a dev dependency, since I don't need that dependency in my project binary, and LiteSVM token, which is actually a crate with helpers for working with SPL tokens and LiteSVM. In my anchor.toml, I changed the test script to run cargo test with the -- no capture to allow print statements to show in the terminal. And I added in my lib.rs And okay, let's go to the test folder. So my test will be on this mod.rs test folder that I then added to my lib.rs with the mod test, just to tell the Rust compiler, hey, look, there is a file at source/test/mod.rs. Get that, include that as a module, make tests in my program. That's it. Okay, now if we look at the mod.rs, this is actually where we will start to create our test. First thing, we do our step function to initialize, create a LiteSVM instance and create a payer keeper. And we'll also load accounts from DevNet into the LiteSVM environment just as a testing purpose, just to showcase, because we're not going to be using it in the example. But it's good, it's here. So when you look at the repo, and if you need to do it, you can. Imagine that you want to clone some account from DevNet or mainnet to simulate any kind of interaction with Radium or whatever, you can achieve that. So first thing, we initialize our new LiteSVM instance with this LiteSVM new. We create a new keeper, which will be our payer, and we airdrop some sol to the payer, as easy as program.airdrop, and then just put who's receiving it and the amount of sol. That's it, done, in like that, really, really fast. Then what we do is load our program binary file into our LiteSVM instance. Again, you can load this program, load different programs. You can dump any Metaplex program from mainnet or DevNet and then load it locally into your LiteSVM instance. Here we have the example on how to load an account from DevNet. As I just mentioned before, LiteSVM does not have access to real Solana network data since it does not have this RPC fetching mechanism. So we use an RPC client to fetch account data from DevNet. Why don't we just create a new RPC connection to DevNet? We fetch an account. This was an arbitrary account that I was using while I was testing this with another Turbine genius called Johnny. And then we just fetch that account, and then you can set that account inside your LiteSVM instance with set account and just passing in all the fields that you have from your fetching account, which is awesome. And then just return our program and our payer. This is just the setup. So when you call this setup message, what's going to happen? You're going to create a new instance of the LiteSVM. You're going to create this new keeper. You're going to load an account that you're not going to use. So feel free to delete that while you're doing the take if you do that. And then you just return the instance of the LiteSVM and the keeper that you created already with some stall in it, in this case, 10 sols. And that's the first thing that we do once we want to test our make. We just call setup so we can grab our LiteSVM instance and our payer keeper. Then we just decide that our maker is our payer. So we just grab the pub key of our payer. Then we're going to create two mints, mint A and mint B, because we're going to need that to if you look here at our escrow.rs, it has a mint A and a mint B. So we're just going to initialize it. And LiteSVM token crate actually makes this really, really easy for you. So you just need to use the create mint, which creates the mint, and will load it straight away into the LiteSVM context. So awesome. We do that for mint A and mint B. You don't have to pass decimals or authority while you're doing the new on the create mint. If you don't pass decimals, it will default to 0 or 1. I'm not sure. It's it's either 0 or 1. I'm gonna bet 1. 0, I'll consider that an NFT, but okay. And if you don't pass in authority, it will default to the payer itself. So in this case, I didn't have to pass the authority since the payer is the maker, but I like to make things explicit. So I created a mint with 6 decimals where the authority is the maker, and then another mint and with 6 decimals, which the same authority, in this case, the maker. Then we create the ATA for the mint A for our payer. Again, easily done just by using create associated token account utility from LiteSVM token that again will just take care of everything and load that into your program. Again, if you don't put an owner, it will be the payer. We derive the PDA for our escrow. We derive the PDA for the vault associated with the account using the escrow PDA and the mint A. We just grab the program IDs that we need to interact with our program. We mint some tokens to our ATA. We create our make instruction, which is actually pretty easy to create. You just need to access your accounts, pass it in, and pass it to account methods. One thing that you're not gonna have to worry about later on with this, since Brie created a freaking awesome crate. We create our transaction and we send the transaction. And what's really cool is that you can do a lot of things since it has account DB. So your instance will have the state saved in there. So you'll be able to get the account from your instance and then get the data, pass it in this case to a SPL token account, and check everything in there, the amount, the owner, if it has the mint A. You can do everything and check the compute unit usage. Since I changed my anchor test to this cargo test, I can go here and do anchor test. Please live demo gods. Let's go with anchor test. Building. And how fast was this to run a test for the make instruction? You can see here, we have the address of the mint A, the address of the mint B, the ATA that we created, the compute. Oh, God damn it. Yeah, anchor, my friends, anchor. A lot of C is being consumed here. And another good thing that you can use with LiteSVM is that actually you can check the logs of your transaction, which is actually really nice for debugging as well. Let's just now run it like with the play here. There you go, compiling as, and you will see, there you go, the test is done like this. And you can see all the logs from your program. It's calling the instruction make, creating an account, then somewhere here the transfer check because it's transferring already tokens from the maker ATA to the vault. So as you can see, this is really useful to test logic of your program without having that overhead dealing with the full RPC and having this RPC calls and having this network overhead. This is really good. Of course, when you want to move to a production level, then yes, you want to have a full validator behavior in that. But while you're testing and doing these fast feedback loops, LiteSVM is the tool to go. It's awesome as you can see. Let me go back to my slides. Which is basically just saying the following. And I think it's important to say this, is that if you want to jump to the next level and be a freaking awesome Solana developer, join us. Join one of our cohorts and learn this and other technologies. Again, we are not happy with teaching the same thing. We like to be on top of all these tools that are here and actually to contribute. We run different programs, Jeff will not let me lie, that we actually encourage our students to contribute and make these tools better and make open source contributions because they're not only helping themselves. They are putting their name out there and helping the entire developer ecosystem. And the only downside of joining us is then you'll have to deal with me. But on the other side, you'll deal with Jeff, so it evens out. It will even out.
Yeah, it depends on the person. That might be flip.
That is true. All right, thanks for having me, guys. And that was it. And really hope to see you in one of our programs.
Thanks, Andre. You know, the opportunity here, being a little bit ahead of schedule, is wow, we're a lot ahead of schedule. Is we can do a couple things. Okay, number one, let's get some questions from YouTube and from here. And you know, between Brianna and Andre and the people that are on this live, Jeannie, what are the questions people have about using these?
I actually would like to challenge Bri a little bit if she's up to it, just to talk a little bit about her crate, because I think it's really awesome. Because from my perspective, and I don't know if you agree with that, Bri, is that a lot of people avoid LiteSVM or Mollusk because of all that boilerplate and trying to see, oh, what is this account meta things, and I need to take care of the serialization myself, and people avoid that because of it. So people can use LiteSVM with TypeScript because there is like already a anchor interface for it, and they're like, okay, LiteSVM is cool. But then when it goes to Rust, they'll be like, this is too scary, when it's actually not. And those crates that you created, I think it's something that it's helps a lot actually people to start using those tools. If you have something similar for Mollusk, my God, that would be awesome. That would be awesome as well. Could you just guide us a little bit, give us that alpha of that crate, please?
Yeah, for sure. I'm happy you like it. I guess like exactly what you said. One of the things that I was running into, just like working with other people using LiteSVM, was there's this learning curve where if you're only writing Inker programs, you don't need to understand deserializing and serializing accounts. You don't need to understand the order accounts that need to be passed through. There's like a lot of things that you do have to understand with LiteSVM that you don't just writing Inker programs. If you write native programs, like you will have to understand that, which is why the flow makes a lot of sense when you're not writing Inker programs. And yeah, there is the wrapper for TypeScript, but personally, I just like to write everything in Rust, and I hate like switching to TypeScript when I'm writing tests. So I just wanted to make things easier for writing Inker programs. And now like with this crate, it does all of that for you. Like if you can put accounts in any order, it's going to update it. It uses part of the Inker client that I kind of like abstracted away from Inker client, because there were a lot of people that were just importing Inker client, like that crate, to write their tests, to be able to keep it type safe and deserialize accounts for you. But now it's adding this RPC layer to your testing, which is the whole point of using LiteSVM, is to abstract away that RPC layer. So now you're like having heavy dependencies. So yeah, we pulled the part of Inker client out, and that actually does all of the type safety, and put it into the Inker LiteSVM crate. So yeah, that's a big TLDR, but if you're interested in checking it out, I have actually not in the LiteSVM docs currently, but I'll make an update to the LiteSVM docs to link out to the example repo. No, wait, actually I did update it. In the LiteSVM docs, there's an example repo to an escrow program, and that escrow program has LiteSVM regular tests, and then compared to, oh, it's linked right here that Andre has.
Let's
Cool.
be free. We have the time because we're ahead of schedule, which is probably my OCD to make sure we don't fall behind. Let's dive in. Do you mind being put on the spot a little bit?
Sure, love it.
Okay, let's dive in.
I'll be here to take bullets as well, Bri. No, so we got this.
We're talking about a bonus session here before Surfpool, where this probably fits really nicely. Look at that.
Well, and again, I would say that and whoever PRs are not PRs, but yeah, probably PRs are welcome, right, Bri, to contribute to this. You're just making, as I said, your life easier, our life easier. So Go for it.
Any issues that you run into, make an issue. Any contributions, make a PR. Currently, there is one thing that I need to update. We're not on the latest version of LiteSVM. There's a few like dependency issues I'm getting, so I need to fix that to make sure we're running on the latest version of LiteSVM. Let's see. I'm gonna pull up the example. Okay.
Nothing like a real turbine-esque. Let's roll with it and make it cool.
Cool. Okay. So we're just gonna dive straight into GitHub. This is the example that's linked in the LiteSVM docs. And part of the reason that made me want to write the crate was I was writing these tests for just a basic Anchor escrow program. And if you go into the tests directory, you can see this LiteSVM utils, regular LiteSVM test, and this has what we've already talked about within this workshop, but how to set up accounts, and then it is using the LiteSVM token crate, which I did realize there is also this discoverability issue that we're trying to fix, which hopefully the docs are helping with that. But there's a LiteSVM token crate that does help with token operations, and a lot of people can't find it. I did just, Command Shift F in GitHub, the LiteSVM token crate, and couldn't find anyone using it. And I know Coinbase just came out with an example using LiteSVM, and they were manually creating all of their token accounts. So there was a LiteSVM token crate that's used here in this example. However, it's still
that's actually pretty awesome. I found it like while creating this example for the escrow, and it saved me so much time. Like, okay, create mint. That's it. It just creates the mint, loads it directly into your LiteSVM instance. Perfect. Create associated token account. You create your ATA and load the account, everything inside your instance. So you don't need to create it manually. Creating the account, loading it. Like it's freaking awesome. Those are the things that we need people to create.
Yeah, exactly. Because there's just a lot of boilerplate code. And honestly, if you're just writing tests, like you already did the hard part writing your program, and now you just want to be straight to the point and make all of your tests and iterate on it without having to write all of the boilerplate code. And I understand the original vision was not to have API bloat within the original crate, just to help make things easier for maintainers. But we're all contributors here, so we can just add some additional APIs that people can use to make things easier. So it's great to see like other people just contributing. But yeah, you can see here is one of the main points that you're having to manually create the instruction. It's not type safe, and you have to manually pass through all of these accounts. So this is just a quick overview. Also, when you're writing assertions, those are all manual. So if I go back to the test, here's the updated one. And it kind of just does everything for you. And the syntax is the exact same as the Anchor client syntax. So the idea is when you want to update your front end, now you can just pull code from your tests and just make things easier. So here's just creating the accounts. You have the same syntax that you're already used to. You can pass through accounts. They don't have to be in a specific order. Nowhere here do you have to deserialize anything. There is also a LiteSVM utils crate, which I haven't really announced yet. I'm still kind of working on it. But just to further simplify some boilerplate code. So instead of having to find the LiteSVM token crate, now you can just create a funded account in one line of code, specify how much you want to create. The motivation behind this was bank run. Bank run's now deprecated, but I loved using bank run for testing, and there was an Anchor bank run crate, and it had a lot of utils like this, where you could just set up very easily different accounts for your test environment. So this is kind of mimicking what bank run was doing. So yeah, just trying to make tests a little bit easier and faster. You can see this reduced the code by basically 50%. I believe the other one was about 300 lines of code. I mean, this has a lot of comments in it, but yeah, just high level overview. If anyone wants to take a look, feel free. The actual crate is on my GitHub. We'll go to repos. It's this Anchor LiteSVM. This includes both Anchor LiteSVM and the LiteSVM utils that I was talking about. I'll probably abstract that later. But there's a README explaining how to use everything. And yeah, that's a quick overview.
I'm gonna throw a challenge at people that are listening. That grab the repo of the escrow that we just been through, and this is actually a mandatory challenge for the accelerated people that are here, and rework everything using this Anchor LiteSVM crate.
And
It should be easy.
My inspiration over there going, no, no.
And yeah, if you run into any issues at all or want additional things added, please let me know. You can message me on Twitter. My DMs are open, or just make an issue directly here on this repo. Oh, and one other thing I forgot to mention. I'll go back to the example. One of the things with Mollusk is the checks that people love that doesn't really exist in LiteSVM. We now have assertions, which are kind of the same, but if you go here to tests, this one is using the Anchor crate. If I go down here, I'll zoom in a bit. You can see there's now assertions that exist within the crate. So I can assert that an account is closed. I can assert a specific token balance. There's a few other ones. So you can just look through like the APIs that exist here, but just simplifies things a lot when you're wanting to load in account state and then verify it. So yeah.
Nice. You know, it's funny, we're talking about Mollusk. Joe was going to join us, but he's actually traveling right now. So Joe, Buffalo Joe Caulfield at ANZA, who wrote Mollusk, wanted to be here, but he has already agreed to participate in the next one because yes, folks, we will do this again. Little different theme, couple different participants, but we will. Let me ask you all the question. First of all, you know, any dev out there that's watching or listening that doesn't understand the importance of testing, you know, there's a reason we're talking about all the different ways to test. So Brianna and Andre, and really anybody on the call here, on the live GMeet call, you know, what are your best recommendations for use case to test tool for people that are building? I mean, you know, what is the best use case for this Anchor SVM crate?
I would say, and then I will let Brianna punish me for my answer. But I would say that if I'm the part of unit testing my code, and again, if I need those fast feedback loops, I just want to test the logic of my program. I don't need any full validator behavior. I will go with LiteSVM all the time, or Mollusk. But if I'm lazy, I'll go with LiteSVM. And that will give me really fast feedback loops. I'll be able to test the logic of my program. I'll be able to mock any kind of mint that I want in the VC, USDC, or whatever I want, because I can just write this arbitrary data in the account. And I'll be able to unit test my program really, really fast. And then later on, if I need to move into production and test it for production, then I will need this full validator behavior, and then I'll need to move away from LiteSVM. But definitely, if I'm just testing the logic of my program, even for integration with different programs, since you can load different programs into your LiteSVM instance, I'll go LiteSVM, LiteSVM, LiteSVM until you need a full validator behavior on your tests. Brie, prove me wrong.
I agree. You took the words right out of my mouth. So I would do the same, especially when you're just focusing like on the program side of things. Mainly you're wanting to write unit tests to just kind of iterate against like all the edge cases that you can think of. LiteSVM is the perfect use case. And then once you're doing like full application testing, I would then move on to just Surfpool, because you can now add in that RPC layer and connect to your front ends. And really that covers most of what you need. There's very few use cases where you're going to really need to be running the full validator or creating like specific developer environments. Like they're more complex. I don't think it's going to be a very common thing. So LiteSVM and Surfpool should cover most of what you need, especially when you're first starting out.
Yeah, I mean, you all know what serendipity is, right? It's pretty cool that the next thing that we're going to hear about is Surfpool. So I do love that this is naturally coming together. I'd love to say that all of this was intentional. If not, but it is intentional to get people in the room that know how to make these connections and create a good learning and developer experience for those participating. Mikhail, you ready? I mean, we can't set you up any better than that.
Yeah, I'm ready.
All right, man. So next up, folks, we got Mikhail, we got Surfpool. We just had them in the other day for a closed call, and it was the best one that they've ever done with us. And they work really hard to create tools and experiences that are easy and robust and intuitive for the developers. We know these guys well. They are, the best of the best people outside of what they do with the tech, and they genuinely want to, build things for you that make you better professionals. So that's all I've got to introduce you, Mikhail. The floor is yours.
Awesome. Thanks, Jeff. Yeah, I'm really, really glad to be here. Like Jeff said, our goal, so I'm co-founder of TXTX. My name is Mikhail. My co-founder is Ludo. I came from Ethereum world. He came from the Stacks blockchain. We've both worked on developer tools for a long time now. And we started building on Solana about a year ago, and we love just everything about the culture and the chain. And we want to build, we want Solana to have the best tooling of any chain. And that's kind of our goal. And so, yeah, we want to make the best initial touch point for developers building on Solana. We want devs to build faster and safer. And those are our goals. Yeah, I'll talk about the tool. There's kind of two sides to it. And so I'll start with the simple one. It's a local validator built off of LiteSVM. So under the hood, we're using LiteSVM. And it lets you deploy and test your programs locally before you go to mainnet, but it acts exactly like mainnet. It has all of the same mainnet data. It pulls all that data on the fly. So it's got these supercharged features, like pulling data from mainnet. It's got these cheat codes that gives you the ability to give yourself any amount of any token or soul, and lets you do time travel, all the stuff that LiteSVM has that we've just put a wrapper around it to make it happen automatically, make it really easy to use. And so like in the development lifecycle, as soon as you're writing tests, you're going to need a validator to deploy it on. Particularly like it's helpful for unit tests, will be built into Anchor eventually. When you run Anchor tests, it's just going to spin up a Surfpool instance. But like Bree was just saying, like when you get into integration tests, you want more than just the VM to talk to. You want to have to go through the RPC layer. There are some extra things that can happen that can go wrong that you want your tests to be handling and your program to be prepared for. And so Surfpool really shines with those integration tests. If your program relies on another program and you have a CPI, which just pulls those accounts for you, and it just makes it so much easier. So that's one side of Surfpool. The other side is what's called infrastructure as code. Infrastructure as code is a Web2 best practice. It gives you like a documented, repeatable way that's committed to your repo that says, how do I get my local work to production? And for Web2, production means AWS or someone else's computer, right? But for Web3, production means mainnet. And it's really valuable for Web2 to have like these repeatable ways. Okay, I've deployed my thing to production. I need to do it again. I don't want to have to remember all of the CLI commands. I just need a file that goes through all the steps, that's executable, that documents everything that happens. And that's what we're building for Solana. So we've created this infrastructure as code for Solana, which allows you to define workflows of your on-chain operations. So you can define what's happening on chain, so like a program deployment. And usually if you're deploying a program, you have to initialize the program, so you have to call it afterwards. And maybe you need to do some fund transfers or something like that. So there's this on-chain stuff. And then you've got, well, what's the wallet that's actually signing each of those things, right? And locally, you want your wallets to be as low friction as possible, right? I want to deploy, I want to send transactions super easily, super quickly. But that's not really the priority on mainnet. When you're going to mainnet, the priority is security, because if you're deploying a protocol that's going to handle people's money, or that's on chain, that's going to have funds associated with it, you need it to be very secure, right? And so we want users to be able to easily have the same workflow and just swap in a different signing structure. You've got a local key pair, you've got a web wallet, you've got a squad signer, same transactions that are happening, same workflow, just different signers. And that's managed with the infrastructure as code, as well as the off-chain stuff. So I've deployed. Now what is kind of the question? And there's other things that you need. You need indexes, you need watchdogs, and we also want all of that to be part of the infrastructure as code. And so in terms of like when in the workflow do you need this? Right when you're deploying to Surfpool, we are creating the infrastructure as code for you. So you're using it every time you deploy to Surfpool. But then when you go to mainnet, it becomes particularly valuable because you can reuse all of the same things you've already made locally. Jeff, you know how I present. I don't do slides. I do live coding. Is that cool? Am I allowed to do that here?
Dude, man, and you know how we go. What do we say? Just do you and have fun.
Yeah. Okay. So yeah, especially this infrastructure as code stuff, if you're not familiar with it, it can be kind of confusing. And so we're gonna do some live coding. I want to share my entire screen. That's the one. Okay. Can you see my screen?
Yes, sir.
Okay. All right. Let me get my notes as well. Almost ready. Okay. So this is going to be, we did this in the this demo and the kind of closed turbine call. It was a lot of fun. It's going to be moving fast. So we're calling this 0 to mainnet in 45 minutes. We're going to build a program. We're going to deploy it to mainnet. We're going to use infrastructure code as code along the way. We're going to vibe code some stuff. It's really fun. So I'm starting in a terminal. Someone please chime in if this is too small at any point, any of my workspaces. Oh, one question, Jeff. Is there a place where I can see any questions that come in from the live stream?
Yeah, so what we're doing here is that the folks in the call here are a bunch of our advanced accelerated folks that are keeping an eye on that, and they're dropping the good ones into the chat.
Perfect. Love it. Okay. All right. Okay. So I'm going to start with make directory Toolapalooza. That's a hard one to type. And cool. And so we're going to do anchor init price feed. So we are going to make a anchor program that is going to interact with the PIF price feeds. It's going to fetch the current price of Solana to US dollars, and it's going to store it in an account. So it's pretty simple, but you'll get to kind of see what it's like to interact with PIF on chain. Okay. We've got a new project. I am going to, for the sake of time, so we don't have to download dependencies later, I'm going to start an anchor build, and I'm just going to hide it away. And I'm going to do an initial commit. Cool. All right. So whenever I'm building an anchor program, everyone knows the first step is to allow unexpected config so you don't have extra warnings that you don't need. And we're going to call the instruction here fetch price. And the accounts, we're going to define the accounts that we need for this, and we'll also just call this fetch price. And so for the accounts here, we are going to need, we'll need the info lifetime here. So yeah, we're going to need a signer. We're going to see how GitHub Copilot does for all of this, but I'm going to call the signer sender. And we are going to have a PDA. So, oh, it just had system program for me. We will need that, so I'll put that in there. Okay, and then we're going to have a PDA, so account, and we're going to do init if needed. So whenever this is called, if the account doesn't exist, Anchor's automatically going to put the code in to create it for us. The sender will pay for it. The space will be 8, so that's our Anchor discriminator plus price init space. So that's going to be the account we're going to create, and it's going to derive the space needed for it. It's going to have seeds, price feed, and then we'll also have the sender key. So this PDA that's derived is going to be a combination of the bytes of this constant plus the whoever's calling it. So every caller will have their own unique account, and we've got our bump. So that's everything we need there, and then we'll name this pub price account. Yep, and I'm gonna spell account correctly. Thank you, GitHub Copilot. And price, good. And then we're going to have the pith price feed. So pub pith price feed. And this is going to be, the type is price update v2, and we will update our dependencies here. So we are using, first of all, you'll see this error here. This init if needed is a feature we have to enable with Anchor, and then this does not yet exist. So we need to pull in that dependency. So I've never done this on 0.32.1, so we might have, I don't know, we'll see if we have issues. Features equals init if needed, good. And then we're going to need the dependency pith, Solana, receiver, SDK. Beauty. Cool. All right. So now this account can exist, and we need to create this custom PDA account, right? So we need to define what this is going to look like. So we can say this is an account, and we're going to derive a init space. So this here is going to calculate the space needed of the account. And that's what lets us do this guy here. And then, we're going to have the value, we're going to call this price, and then we'll say time checked. So we will store the price alongside the time that we are checking the price. I've got a hand raised. The question?
There's actually the font on your ID. It's it's too small to follow through.
Oh, I need to zoom in?
Yeah.
Thank you so much for the heads up. I put in capital letters on the top of my notes, all caps, zoom in, and I forget every time. Thank you. Cool. All right. So we've defined our account. Now this one we need to import. We've added the dependency, so we can do the import here. And now we can get to the actual logic. So we are going to have a mutable reference to our price feed, and we're going to get the current price. So this is how you interact with pith. So you can, the price update account, and we're going to call, it's called get price no older than. And for this, we can pass in, so we have to pass in the clock. So how it knows what the current time is. And then we have a maximum age. So we'll create a constant. And we'll say, this is a U64, and it'll be 60 seconds. And then you have to tell pith what price feed it is that you care about. So essentially, these are these accounts that pith maintains where they are pushing the current price, and they've got an ID associated with them and an account associated with them. So this is the specific ID for Sol USDC, right? And so we're going to call get price feed ID from hex, and I'll need to add that dependency here. Cool. Yeah, and we'll pass in our feed ID. And good. I think that's everything we need. Oh, it doesn't know about this guy. I may have missed something on my import. Fifth price feed. Let me see. Price update v2. Okay. I may have just misspelled the name of the account. No, I didn't. It should be. So this is the add a macro on the accounts. Oh, yeah. Did I miss something here? Let's take a look. No, I don't think I need this. Let me consult some notes. Yeah, I think you're right. I think I missed let me make sure I got all my imports correct here. Okay, get feed. And this also could be an anchor 32 thing. We can't leave that out. So I might need to downgrade, but it should be price update dot. Yeah, it's not pulling this account data. Yeah, so the function exists on this account. Okay, let's try. This has been tested on 31.1. I think for this I need to add. I don't remember what this is. It's just anchored. Let's see how that does. And let's check all of these accounts. We've got our system program. We've got our pith price feed, which is an account of this type, which we are importing from the receiver SDK. Maybe need to delete cargo lock. That's a good point. We've got our price account where we are initializing. We've got the pair, we've got the space, we've got the seeds, we've got the bump. We've got our, oh, F, silly. This does not need to be mutable. Which I don't know if that looks like that did it. There we go. It did not need to be mutable. Okay, we're back. So we've got our price in this price object. We've got the current price equals price dot price. It's a little redundant. And then we've got the exponent equals price dot exponent. And then we've got our price account that we do need this one to be mutable because we need to update our local price account, our PDA price account. And so we'll say price dot price equals, and it'll be current price as F64. And we're going to multiply it by, no negative needed here, and this isn't needed. Cool. And we did a U64 here. We're gonna have the decimals because that makes things easier for users reading it. And we can update the time checked is right now Boom. Okay, there's our program. We had a little hiccup there, but not too bad. So now if we anchor build, I'm going to change it back to 032 anchor.toml. Oh my word. Okay. Start with deleting cargo lock. Edition 2024 is needed. All right, I'm going to need someone to help me out here. Anchor champs.
Chime in on the call if you're here and you know the answer. Tell them the answer.
Heck yeah. Okay. It looks like Anchor 31 was helping us here. So I will add that back. And don't match. Okay, I need to change this to be version. Cool. All right, I've got another idea. Try again. We'll copy and paste code so it won't take too long. No, CD try again, and we will make sure we're using cool. Oh. All right, so pasting in my code. Pasting in my, it did 32 again, so EVM's not doing what I expect, but now let's try and anchor build. What the heck? One of the packages needs to be programs, cargo.toml, edition equals 2021. Yeah, I have 2021. I have, it's my only cargo.toml. It needs to be 2021, right?
What do you think, Andre?
It says 2024. Where do you see that? M is saying I see 2021. The error says 2024. This is in let's do anchor dash. See, EVM use.
Glacier, you on the call? Yeah, I know.
AVM use 0310. Yeah, let's install it. Downgrade base. Okay, so that'll be base C for CT. And I think I do at 1.6. let's look at. Changing edition to 2024 might work. We'll see. Nope. Okay. No. Okay. I'm downgrading to 0.3010. We'll see how that works. And if not, I've done this project before and we can use one of those ones that are building. That was before, I don't know, Anchor broke things, I guess. All right. See it. AVM does not seem to be doing its thing and changing my version of Anchor. Okay, so let's try something. I've done this project before, so this is all the same code that we just wrote, just in a building state, and we'll work with this. So we've got all the same code here. We have a program that is fetching a price feed from Pith and storing it in a PDA. And we're building. Cool. All right. So you've got a building at long last. You've got your program building, and you are ready to start testing it. You can run Surfpool start. And so what we do when you first run it, we're spinning up a network for the first time in an Anchor project. We can detect that you're in an Anchor project, or if you're using Pinocchio, we can detect that. And so it's going to prompt, do you want us to build your infrastructure as code for you? And if we do that, it's going to generate these runbooks. Ooh, I'm going to actually, since I've deployed this to mainnet before, the keys are bad. They've been used, so we want to be fresh here. So we'll do anchor keys. I've deleted the key pair file, anchor keys sync, anchor build. Beauty. Okay, so when we ran Surfpool start, it generated this infrastructure as code, and then it is executing it for us automatically, sending all the transactions we need to deploy. So we've just processed 230 transactions, sent all 230 of those to deploy our program. And that is happening because we have this infrastructure as code here. So we'll take a look. It generates this txtx.yaml. So this is, it's called the manifest, and it's going to define your runbooks. And your runbooks are the sequence of on-chain operations that are going to be happening. And so we're saying there's a runbook called deployment. We have a description for it, and we can say this is the location of the runbook. So all of the TX files in this runbooks deployment folder is our deployment runbook. And then we can define these environments. So we can set up like, okay, when we're on localnet, the RPC URL is this, and when we're on devnet, the URL is this, and you can set it up for all of these. And then we can look at the actual contents of each runbook. So the main.tx file is defining what's happening. So we're doing in this action, and the type of action is deploy a program. And so whenever this executes, it's going to deploy your program. You can kind of just look at this and see what it's going to do. It's going to deploy a program. It's got a description, and it's saying, what's the program we're deploying, this price feed program we just created. But then there's this question whenever you're deploying a program, who's paying for it? What's the wallet that's paying for it? And who's going to own it at the end of this, right? And so we're defining the payer is this thing called signer.payer, and the authority is this thing called signer.authority. And like we talked about, when you're local, I didn't have to think about the signer. It just signed all these transactions, right? It's really low friction, really fast. And so we have a signers.localnet file here. Let me zoom in again on this. And so in signers.localnet, we're defining a signer, and we're naming it payer, and the type is just this secret key signer. And then on for the authority, same thing. It's an authority, it's a secret key signer, and we're just pointing to the secret key that we have on disk that's going to be the payer and authority for this program. And so whenever this is executed on localnet, it's going to pull these signers. But then whenever we do the same thing on mainnet, it's going to pull the signers from this signers.mainnet file, which we have is this SVM web wallet. It's a different type of wallet that's signing it. And so if I go into another terminal here and I say Surfpool run deployment, that's the name of our runbook, and then env localnet, and then -u, this is called unsupervised mode. I execute this, it is going to execute the runbook. It's sending all those transactions, all 230 transactions required to deploy this program, and it's done, right? But also, if when we go later on, we're going to do the web wallet to deploy to mainnet. We're going to do it in supervised mode. So we leave off that -u, and you'll see there's this starting a web console, and it's going to take you through. Oops. Copy that. It's going to take you through step by step. These are the wallets that are deploying. Start the runbook. This is the transaction we're sending. And it's going to walk you through each of the steps for the deployment. And that's the supervised mode. Cool. So we've built a program, and automatically Surfpool has created this infrastructure as code to get your program on chain. We're going to take a quick pause and go to ChatGPT. I'm going to ask ChatGPT. I'm going to copy our program, and I'm going to say, can you make me a very simple single file HTML front end with embedded script tags to allow inputting a sender and fetching the price PDA and decoding the price time checked. Always be polite to your LLMs, people. Okay, gave it my code, gave it a prompt, and we will see what it comes up with. So we are going to, it's going to build a front end for us. We'll see how it does. We probably are going to have to debug it some and figure out what's wrong with it as we go. We'll do that live together. But in the meantime, we need a way to actually call this this program as well that we've created. So we are going to create a new runbook. So I'm going to do a new file. I'm going to call it fetch price, and I'll make a main.tx here. And I'm going to copy, we're not even doing devnet, so I'll just copy these two signers files, and we're only going to have one signer. We'll call it caller. And I'll do that on mainnet as well. We'll rename this payer to caller. I'll delete the other one. So now we've got our mainnet and our local net signer. And I'll copy some stuff here as well. So this add-on block is just saying that we're targeting Solana, and that the RPC URL is coming from our rtx6.yaml file. And then now we can define a variable. So we're going to say our program that we're going to be calling is get program from Anchor project, price feed, beautiful. And then we're going to call our program. So we have SVM process instructions, where you can provide the details of any number of instructions you want and create these transactions. And we're going to say who's going to sign them. We can provide an array of signers because there's, if you could have some multiple instructions that need multiple signers, and we'll define our instructions. So we'll say program IDL for TXT or for Surfpool to be able to assemble a proper transaction. It needs the IDL, and then it's going to be instruction name equals fetch price, and then we need to say what accounts there are, right? So we look at our program, we've got an account called sender. So we'll say sender public key equals signer.caller.public key. So whoever's signing this transaction is the sender that we pass in when we're creating this transaction. This is derived, so we don't even need to provide it. Surfpool will figure it out for you, as well as the system programs hard-coded. So we just need this guy. Pith price feed, public key equals, and then the price feed account is just this. So cool. We are good to. I didn't approve the last transaction to finish our deployment there. That's okay. We are good to call this. We just need to add our runbook here. So name fetch price. Good. So that's where our runbook is. We've got a new runbook. Now we can do Surfpool run fetch price -u -env localnet. And we've sent our transaction. Cool. And now I'm going to demonstrate something. If I send this again over the course of a minute, it's actually going to fail. I'll wait a minute and I'll send it again. I'll show you why it's going to fail. So we have said the price is only valid if it's no older than 60 seconds, right? 1 minute. And Surfpool, we have called, maybe it's easy to forget about this. We've deployed a program, but our program relies on this price feed account that, we don't know about locally. It comes from mainnet. So Surfpool is automatically parsing those transactions and saying, oh, the user needs this account from mainnet, and it fetches it, right? But it fetches it once, and now it's this static account that lives here, and it's not being updated from mainnet. And so now this data has gone stale. And so whenever we call this again, we see the price is too old. And so that's kind of a struggle about being on localnet. Even if we're pulling mainnet data, it's this static data. So what we can do is, I just killed Surfpool, and I'm going to add to my deployment. And this is only on localnet because you don't need this on mainnet, and it won't work on mainnet because you don't have cheat codes on mainnet. But I can say action setup, and we have the setup surfnet action where you can, in infrastructure as code, access these cheat codes. I'll quickly go to our docs.surfpool.run. We have all these actions defined, and there's the setup surfnet one. And one of them is, I forgot to merge the PR to update our docs. Tempted to do it now. Okay, so we have this one that is stream account. So what that's going to do is, instead, it's going to pull from mainnet, but it's not going to pull from mainnet just once. Every time we reference this account, it's going to pull the value fresh from mainnet. So it's always local. So right when we deploy, we're also sending this cheat code that's telling Surfpool, always keep this data coming from mainnet and never store it locally. And so that's going to be our same account here. Cool. So now let's give this a go. Surfpool start. Deploying our program. And if we look at the logs, we can see streaming account process, Surfpool account streaming. So now, whenever we send this, the data will never go stale. Even if we wait a minute and we send it again, we're not going to get an error because it's pulling that. Oh, actually, that's not true. If on mainnet the account hasn't been updated, which that's okay. So yeah, one passed, one failed, then another one passed because we had to wait for that data on mainnet to actually get updated. So we're pulling live mainnet data here. Every time we reference this account, it's pulling the state from mainnet again, which is pretty sweet. Okay, let us see how ChatGPT did. I've done this a few times, and every time it gives me something different. There's usually some sort of bug, and the UI looks different. Okay, so we've got a front end. It's going to ask me for the sender public key. So let's do Solana address. Okay. Yeah, and then this is a common error. It doesn't always have this error, but it's common. So first of all, we're pulling from DevNet here. Let's change this RPC URL to be localnet. I don't need confirmed there. And then we had that error, buffer is not defined. So where are we using buffer? Okay, yeah, buffer does not exist in the browser. And so we need to use text encoder instead. Cool. All right, let's try it again. Refresh. Aha. So we have fetched this. We've derived the PDA that is, a result of our sender, those static bytes, and our program ID. So this is the unique account where our data is stored. And then we've fetched that data and we've decoded it and we've displayed it here. So we've got the price of SOL to US dollars at this time was this. And so I want to point out something. If I call this again, and then I run this again, our data has changed. The price has changed, which, price has changed. But the question for as you're going to mainnet with your deployments is, what happened to that last price? Before the price was 185, now it's 185.285. And what happened to that previous number? It's gone. We have overwritten the state of our account, right? And so this account model is really cool with Solana, but if you have an account that stores important information and then you update it, you don't have this history. And for a lot of use cases, like you have users who are using your protocol, they're going to want to see the full state of things that have happened. Like if you've got a DeFi protocol, I've deposited some funds and I've gotten some tokens and the value of these has changed over time. I want to be able to see that value over time, not just right now, right? And so we need this data of we need this past data from Solana that we're not getting here. To access that data, you need an index. So you need something that is listening to every transaction and storing this data that you care about. And Surfpool can do that for you pretty easily, very easily, I'd say. Where any program, any of the data you care about, we can create an index to get live updates on the data. So we're gonna add to, we have this deployment runbook. Whenever we're deploying, we're gonna do another thing. We're going to it's called SVM deploy subgraph. So we're going to deploy what's called a subgraph, which is just an index of the chain where we're going to define the stuff we care about. And sure, we'll give a description. And we're giving this name price PDA. So we need to tell it what's the program ID we're indexing. And so this will tell Surfpool any transactions targeting this program ID, start looking at them to parse out this account data that could exist. And then how do we parse the account data? We need to know those anchor types to be able to parse the data. And so we provide it this IDL. And then we need to know what slot do we start indexing at. because you don't want to have to index starting at slot 0. You want to just what's relevant is when the program's deployed. So we can say we can reference this past deployment and the slot it was deployed at, and that's when it's going to start indexing. And then the type of data we are indexing is a PDA, and the type of that PDA. So this is the anchor type. So if we look at our program here, our type was price, and then we can tell it what instructions are using this price type. So the instruction name is fetch price, right? So instruction name equals fetch price, and then the name of account, the account in this instruction that is that type. So this instruction fetch price has these accounts, and the account that is using this price type is called price. So we can say account name equals price. So if we had 5 different instructions that were all referencing this type with a different name, we can have 5 instruction things here, and list them also, and all the account names that use that type. But this is all we need for this one. So now if we kill Surfpool, start again, we are deploying the program deployed, but then we also have your subgraph has been deployed. We can go to, I'm going to copy this URL. We'll go to, this is Surfpool Studio, where you can pause and start block production. You can change the time. You can inspect your transactions. You have a faucet that can get you SOL or any token. There's also this data indexing tab. And here we have documented like all of the, the last checked and price field, like all of the data that you have provided here. We have it on this GraphQL interface. And we can go to the query builder and we can just click to build this GraphQL query. And it's empty right now because we haven't sent any transactions. So let's do Surfpool run fetch price again. And now we've got data here. And if I run this again, I have overridden my account state, but I have 2 entries in my database, right? I have all of the historic data. And so if we want to now, we're going to update our front end file to show all of the data instead of just this one moment in time and losing all of the past data. We're going to update it to use a GraphQL query. So here we go. Let's look at how this is working. It derives the PDA, says fetching account. It's fetching the account, which we don't need to do. We don't need to fetch it from the RPC anymore. We don't need to check if the data is valid or not. Surfpool's already done that for you. We don't need to do any of this decoding. Okay, output content plus equals decoded data. So what we'll do here is we're going to paste in a fetch. Okay, so we are just fetching from that URL we were just looking at. We're doing a GraphQL query. I've already got the query made here, and then we can console.log the response here, and then we're going to filter this. So this database is going to have all of the entries, right? Even if multiple people call this, and we're going to filter by the PDA that we care about in this. So data.price.filter. I'll say our entry, where the entry.pub key equals our price PDA. So now we're just looking at those entries, and we can say for const Rust doesn't need these dang all parentheses, but JavaScript does. Okay, let's see how AI did. On-chain entry, price, last checked. We don't need all this data. That's good enough. Get rid of this. Okay, so let's reload our front end. Let's do Solana address again. Grab the sender account. Last check, not good. I think I put in the wrong. What was the name of this field? Last checked. Let's look how it is here. Last checked. I think I probably spelled it wrong in my HTML file. Where am I? All right, this is the live debugging we've got to do. Fetch price. Not even seeing a network press request here. All right, I'm going to remove this just to see what happens. Let's look at our query. Price, lamp ports. My query. This all looks good. Okay, yeah, that doesn't exist. We haven't even gotten to our request. Cool. Sweet. Okay, so now our front end is showing, oh, last checked, undefined. I can add that back to my query. Last checked. Boom. Okay, so now we are not losing any data. We're not just showing the account state right now, but we're showing the full history. So if I run this again to get a new price, we've got another entry in our database. And so just like that, in like 3 minutes, we've created an index of our program that's automatically done locally. You can build out your front end and have a GraphQL database. So this is actually, it's IDL to SQL, right? We are parsing your IDL, parsing all the transaction data that comes in, creating an SQL database where this is all stored, and then we put a GraphQL wrapper around it so it's really easy to access the data. And super cool, but it doesn't just work locally. We can also do this on mainnet. So we've done our deployment runbook a few times. When we are ready to go to mainnet, we've already executed this deployment runbook multiple times locally. So all we have to do, let's add to our manifest the RPC URL and everything. I'm actually going to be using a Helios address just because, you know, we're going to get more stability that way. So I will put that in. Cool. And so now when we're ready to deploy to mainnet, we can do surfpool run deployment --env mainnet. And if we recall, this main.tx is defining what's going to happen. So we're going to deploy our program, and then we're going to deploy our subgraph. And on mainnet, we're going to have a web wallet signing, and we can demonstrate that. So it's hosting this. If I go to browser and I load that URL, we've got this interface where, okay, this is the wallet that's connected. You can make sure you're going to be paying with the right wallet and that the authority is the right wallet and that you have enough funds for all of this. And we'll start the runbook. And okay, we see a transaction with one instruction will be signed by the payer signer. The transaction creates an ephemeral account that will write to the program buffer. It's telling you what's going to happen because deploying to mainnet can be quite scary, but we're trying to make this feel as safe as possible. You know, if things go wrong, there are steps to recovering any funds that are in rent, and nothing's going to be like locked away and trapped. And there's logs for every step of the way. So we've clicked sign transaction because we've said a web wallet is signing for this. It's going to open up our web wallet, and we can see how much it's going to cost, confirm, validate. And as that's deploying, oh yeah, we can see the history of transactions that are sent here. We've got some waiting to do. Are there any questions in the chat while this is deploying to mainnet?
Yeah, let me look in the looks like Luda's in the chat too on YouTube. So he's helping out there.
Nice.
Anybody on the live part? I know a lot of the people on the live side saw this a couple days ago.
Yes. I don't think Bree has seen all of these features of Surfpool. She's just seen the validator side.
Yeah, I haven't. This is really cool to watch.
Anybody have any questions on how to use this and where in the process and how to maybe use this in tandem with some of the other things? Kind of the theme of the day. You know, I mean, just to ask on that, Mikhail, what would you say is the best tandem tool of all the ones we're showcasing today to use with Surfpool? It's a hard
Well,
one.
you know, we want to be integrated with all of them, you know, like where when you run Anchor Test, we want it to be spinning up Surfpool. So like they're going hand in hand for sure. Whenever you run Surfpool, you're running LiteSVM, you know, that's what's happening under the hood. And so they're all just like, they're kind of going like this, you know, becoming one thing. The switchboard demo made me curious about how we can continue to make it easier to like integrate with oracles.
Nice.
Yeah, my brain has been spinning ever since I saw that one.
Yeah, I mean, the other thing, like you said, is, you know, everybody should be looking at ways to do what you just said. How can we make it all smoother and more integrated and more intuitive, and, you know, have some kind of common lexicon of what we call things. You know, I know that when we did the GILL working group, that was a big emphasis. You know, let's grab all the vocabulary that people have been using with this stuff for the last couple of years and different tools and come up with a common, you know, lexicology about it.
Yeah.
So a lot of times that's a really hard thing, you know.
Yeah.
I come from EVM, I call it a smart contract, but here it's a program, and here it's and here it's this, and here it's that. It's like, you know,
not calling it a smart contract was a hard habit to break since I came from Ethereum.
Yes. And I still think that I say program smart contract like back to back all the time. Because I mean, you know, mostly being from Cosmos before coming here, and even Polygon before that. So
I see confetti. So we have just deployed our program. We have a HTTPS URL to reach our subgraph. So okay, first let's just go to Explorer. Let's look for our program. Make sure it's there. Boom, there's our program. There's the authority. But then I can also go to so cloud.txtx.run. And so we've got, I think I deployed it to this Surfpool. We've got this subgraph that's been deployed, and we can see what our URL is. We can have that same, oh wait, I'm on the networks. There we go. There, yeah, it's called price. I was like, how is it named demo? All right, so yeah, we've got the URL to do our GraphQL query. We've got the same query editor. We can let's do Surfpool run fetch price. So this time we'll do mainnet. Right, so we're going to do the same thing, but this time instead of deploying a contract, we're calling the contract we just deployed on mainnet. And just I'll give it some time so the price can change, and I'm going to do our front end here. We can grab this URL. And so now instead of pointing to localnet and fetching local data, we will point to our mainnet index. And we can we'll call our contract again, so we have, you know, multiple pieces of data being indexed. Confetti, love to see it. Okay, let's see. We're going to refresh our front end. So we have deployed everything locally on Surfpool. We've tested calling the contract. We've built our front end. Instead of just like pulling data from on-chain, we've just got an easy to query GraphQL database. Now we've deployed it to mainnet, and we have the same database schema. We have, we can go to this query editor. We can fetch. We've got entries in our database here. We can. Oh wait, this isn't who called it this time. Let's look at who this was. This was our sender, and we've got the on-chain data. I think one of them's still being indexed, but like just like that, we've got live mainnet data being indexed in a GraphQL database, the same schema that we were using locally. Super powerful for like, when you're ready to go to mainnet, you do the same thing you've already done, and I just changed out one URL from a local net to a mainnet one. And so yeah, going to production has like never been easier with this tech, which we're really excited about.
Nice. I see Onana asking how soon are we to integrating Surfpool with Anchorcast?
I soon TM. The PR will be open, I thought, last week. The things have come up that have just prevented us from opening the PR, but we'll be opening the PR soon, and it'll be up to the Anchor team to decide from there. But yeah, should be soon.
Nice.
Yeah.
Any other questions, folks? This is brilliant, as always. And I do kind of secretly love that there was a little bit of a hiccup that needed to be addressed, because that's life.
Yep. It's a demo has yet to go perfectly, and the hard part is keeping your cool while you figure out a workarounds to keep the show going.
Well, but look, I mean, most of us know that is a very normal part of development experience, especially.
Yeah.
Things are changing fast, daily, and it's something that's probably never going to go away, which is fine, because watching you go through your strategies and the people in the chat offering up their strategies is giving the newer people the toolbox of, when it doesn't go exactly how you expect, here's your first 3 steps.
Yeah.
Next 3 steps. People need to know how to do that. People need to see people doing that and not go, up, doesn't work, I'm bad, I'm going to quit. I mean, that's the wrong thing to do. And that's not just on Solana, that's everywhere. But, maybe a little bit more often on Solana, because we move so fast. We're moving and getting and doing things so quickly. Any other questions? Anything in the YouTube channel or anything here local? All right. Explain Surfpool in 1 line. But how would you define Surfpool in 1 sentence there, Gaia?
Okay.
For Richard.
Supercharged local validator and Web3 infrastructure as code.
Nice.
Semicolon. No, I'll stop it there. I won't keep it going.
You're good. I mean, it's funny. I was waiting for a run-on sentence, but you know how to use your punctuation to connect and create complex sentences. But careful with the old English teacher here. I'm watching. But no, this was great. This is brilliant. Anybody on the call here have any questions? How do we get in touch with you? Oh, 1 second.
Yeah. I am Micaiah, good luck spelling my name, _TXTX on Twitter. My co-founder is TXTX_Soul, much easier to spell. GitHub, star the repo, use it and break it. It's I can share my screen again. Oh, I'm still sharing. Yeah, surfpool.run is our website. github.com/txtx/surfpool. Yeah, download it, break it, open issues. We've had a lot of contributions, and especially recently, so it's been awesome to see.
Yep, I agree. Always a good session, Kaya. So, we do have a little time now between, the end of Surfpool and the beginning of our next presenter, which is going to be the 7 Labs guys with Carbon. And I am aware that I'm echoing. I'm not sure why, but I am aware, so I do apologize. What I'd love to do is, here on the live G-Meet call, we have a bunch of accelerated advanced research turbine folks. So I'm curious, what that's why. Okay. I'm curious, someone want to kind of unmute and talk about your experience with any of these tools, looking for a brave soul to be like, yeah, these are what I'm using now. This is how I use them, just to kind of get a little bit of a more real user experience and not necessarily someone who's the master of this stack. What have you done with any of the tools that we've talked about so far? Anybody on here want to be a brave soul and brownie points with Jeff? Yeah, inspiration, you the man. Go ahead, talk to us.
So Jim, thanks for the presentation, Micaiah. So my own the new thing that I started working with was LiteSVM, and it just feels natural to have the same program that you write still relatable in your tests, right? You can have reusable crates. You can import your crate accounts, you create instructions, and still use them in the test. If you are doing Web3.js, it would be you have to just have the account, then you pass the account, PDA derivation. All of that just feels natural. You have this buffer string from Rust and still use it inside your test instead of writing buffer.from in TypeScript. It just feels, I like that VM feels natural to write your Solana programs, your Anchor programs there.
Okay, I'm talking and I'm muted as always. Cool. Who else? I mean, who else on here? What's your lowest hanging fruit, your go-to tool from what we've heard about so far with what you're building? Anybody? Go ahead and grab YouTube time. Go ahead, Alex.
Yeah, as I've asked the questions before, I'm playing around with Magic Block and Switchboard. I think Solana is becoming more and more real time speed, like super fast, and that's an exciting tech as well. Every time I'm seeing Micaiah's sessions, I'm like, okay, I need to set up my integration tests using Surfpool. So looking forward for that as well. And I'm most probably going to bother Micaiah constantly.
That's okay. I know he likes to be bothered and doesn't consider it being bothered. If Micaiah, if you haven't met Alex yet, you guys are going to enjoy each other a lot. You guys have a lot of the same energy.
Nice. Yeah, I look forward to hearing from you.
Micaiah, what's the lowest hanging fruit that you guys need for contribution from the open source contributor world?
Honestly, since my last Turbine call, a lot of the low-hanging fruit has been claimed because so many people have jumped in saying, I want to contribute, which has been awesome. I still would love to see more examples in the Surfpool examples repo. So, people writing programs that need indexing, you can throw in an open source example there. Or like if you're using Surfpool to maybe simulate some trades or something like that, it's great for that. You can pull mainnet data so you could like simulate a series of trades ahead of time without spending any funds. And it would be really cool to see some examples like that in the examples repo. So yeah, that would be low-hanging fruit.
Nice. And everybody can do this. The one recommendation I would make, and this kind of goes back to what Kyle was talking about before, just be responsible stewards of this content. If you're going to create some examples as Micaiah recommends and requests, let a couple people look at it, let a couple people play with it before you go ahead and submit it. There is no race, quality over quantity, process over product. make sure that you're really exploring and making something useful before you submit it, and make sure that somebody else validates the utility of your work before doing that, or multiple people. And of course, you could throw that into the Discord, either TXTX Discord or the Turbine Discord, and get some validation. But that's just good best practice. Anybody else in the room here have any? This is how about, let's shift gears. Is there a new tool that you're like, I didn't know enough about it, but now that I do, it's going to be the first thing I start to play with? What got you most excited today so far, people in the Genie? Inspiration says, unfortunately, Yellowstone, but it's not unfortunate. Yellowstone is brilliant. The documentation is excellent. And the variety of people that are working on it and maintaining on it, as Kyle mentioned earlier, is varied, which gives you a greater probability of getting the help you need. Again, if you have that toolbox of people, you got Jupiter, you got Triton, you got Kyle and his group, you got a lot of people with their hands on the Yellowstone stuff. All you got to do is ask for the help. And if you exhaust your prior references, the ones I just mentioned or the ones just ask one of us, because we're pretty tied in with a lot of those teams, and we can certainly help make the connections that are necessary for you to get the support you need. Again, with you then being responsible for turning around and providing that reciprocity. Here, I'm going to make a contribution because I got help, and I want to make sure that I pay it forward to the next new user to help them get over the hump as well. So cool. All right, so we do have a short break here. Vixen was mind food. How so, Alex?
I mean, for me personally, it was quite an intense, more technical presentation, and I didn't know about it, so I literally absorbed everything from that, and made a lot of bookmarks, and I need to follow and took some notes, but it was a really good session as well.
So I would venture to guess that even though his camera is off, that Alex has a notebook and a pen in his hand, and he's actually handwriting notes.
6 pages for this call.
Only 6? I mean, that's unless you're using like a giant notepad today.
It's more on Vixen, but the other ones I have already a lot of notes on that. So
awesome. So let's do this. Let's take an intentional 5-minute break. Let people kind of get up, get a quick snack, go to the bathroom, do whatever you got to do. I'll put on a little theme music in the background so that it's not completely boring. We'll come back here in about 5 minutes and and pick this up. So everyone take a little bit of a break, and we'll see you back in 5. All righty. Let's continue. Let's see here. All right. So, Varm, you want to pull the break slide off, and then we will continue. We'll do a couple short items with some of our cohort members here on the call, just to talk about a little bit about some of the stuff they're doing, some of the tools they're using, some of the concepts they're excited about. And then we'll pick it up. We should have our friends from Carbon coming in shortly. And once they get in here, we'll segue into what Southern Labs is doing with Carbon. So let's start out with a little bit about QuickNode. Talk about QuickNode for us and pull up your screen. Let's see what we got.
Hello, am I audible?
Yes, you are.
All right, let me share my screen.
Yeah, and I mean, we know QuickNode well. I would say if you're looking for, you know, a DevNet free tier to test stuff out that's pretty robust and has a pretty good limit, you know, we always recommend newer developers, you know, take a look at QuickNode. I do think that for DevNet, you know, high limit free tier, it is, you know, it's your best option. They've been around a long time. Actually, a handful of our grads work there, Mike and Aaron and Javier, and they're a real good group of guys and do some really great work. So yeah, talk about what you're doing with QuickNode.
All right, so basically I was using QuickNode streams in particular for a product I'm building for the Cypherpunk hackathon. And basically what's required over there is I'm working with real-time blockchain data. So what QuickNode Streams provides is it monitors the chain in real time, and it redirects all your required data to an endpoint that you specify. So let's go into settings. Yeah. So basically what QuickNode Streams allows, there are two options. You can either stream the entire raw payload of everything that's going on chain, or you can filter it before streaming, which as in the Yellowstone Vixen demo, they were talking about that your build based on the bandwidth used. So if you filter the payload before it's received by your endpoint, you can basically reduce your cost that you're incurring. So I have a simple filter over here. It monitors everything that's going on with this particular program over here. And it basically streams it to an endpoint, which I have defined over here. So let me just do a quick demo of how this works. Basically, this is the distributed, the DApp I was working on. Is the DApp visible? I don't think it is. Let me share.
I see the QuickNode page.
Yeah, I'm switching over.
Okay, cool. Time lock?
So basically, I will start the QuickNode stream. And this is just the basic DApp that I will be tracking. And one other thing, let me share my terminal. Yeah, so this is the endpoint I will be using. I will start the server. And there's this tool that can expose this server to the internet, which is, again, on another tab. So let me share the other tab. You know what? Let me just share my screen and start. Yeah, so what I'll do is I'll expose this local port that I'm using. And the server's up, the same endpoint that I've defined in the stream over here. So now if I interact with my DApp, let's say we just make a transaction in the DApp. That's something I do not want to share. So was the Phantom extension visible? Yeah, it is. Let's confirm this. And basically, once the transaction is confirmed, yeah, it got confirmed. So yeah, we should have a post on our webhook through the QuickNode stream. And if I go to the server, which I was running here, yeah, there we go. I received all the data that I wanted, filtered from the raw stream on QuickNode. So now I can look into this data, parse it, and just read whatever I want from this. And this is all real time on chain. As long as the QuickNote stream is running, I can always access all the transactions that that this program is doing on chain. So that's basically just a quick demo of the stream aspect.
Nice. Yeah, it's I remember probably a couple months ago when Apollo was trying to get some work done for range early on, and he was using one of the free tiers available, and he's like, I keep getting rate limited, I can't do all the stuff I need to do. I said, give QuickNote a try, and he was able to rip it no problem, not be limited. So it is a good tool, and again, their documentation is excellent. Mills, who's been there a while, Aaron Milano, was actually in our very first Solana cohort 3 years ago. And so, really good work by those guys over there. Who did we say was going to go next? Let's see, Alex, you want to talk a little bit about what you're dealing with some of your 00 research?
Yeah, I've been researching a bit about the whole project, but right now I'm actually I wanted to finish the whole architectural diagram of communal lending markets for Monday. So hopefully Andre will like it. But been working on a lot of research parts on deep machine learning, on stable coins using the P token. So there's a lot of work that I'm stuck there every single day. But 00 will be quite interesting to discuss on one of the calls, maybe. Was
Cool.
Just a suggestion.
Yeah, I mean, look, 00 is doing something super ambitious, and it doesn't surprise me. And we've had some calls with them, and there isn't a team on the planet that is more suited to achieve what they're pursuing than them. And that is, ultimately, that is the first most important thing you need to nail. And Austin and company have definitely done that. Inspiration, you had some MPL stuff that you thought would be interesting. You want to share?
Yeah, it's just, let me pull up my screen. Just the transition from the metadata program to core, and everybody's not crazy about it yet. Okay. A minute. So I think for my previous capstone, I was doing some things about the marketplaces, right? And we had to just get the whole idea of different kind of tokens that are on Solana. What defines a token, the non-fungible, fungible addition, fungible assets, fungible, programmable, non-fungible. But with core, especially for NFTs, with core, they just makes everything streamlined and simple to use, right? If I come over to core now, the only thing you need to be worried about is just your account and assets. So they made it so that instead of having these different metadata accounts, which one has the master edition, which one has the master account, I just have one single asset. And the assets can also be assigned. That's something else in the future when they did NFTs as accounts. Like NFTs can sign transactions and all that, but I don't think that gains much adoption. What I was trying to point out there is it just feels more natural to use assets, and I think more people should use core NFTs for the NFTs instead of using the old metadata accounts. So it feels natural and just feels like, okay, this is how it should have been. But there's one downside. I think using core, it gives you a what is known as the normal NFT, right? You can't have multiple supply of it. It's just like one supply. So that's like the standard NFT, one asset, one supply, right? But it changes the way you think about having to manage what metadata is in one account. But the docs still has maybe some more work to be done, because most of the examples there, especially for CPIs, they are not exhaustive on how to add plugins, because there are different kind of plugins on top of core. So core is like you have an asset that you put plugins on top of it. So there are Rust examples and there are JavaScript examples for all those things, but the CPI anchor ones, they are not very exhaustive to give you. But I was going to make a contribution, but I'll just get back to that. Make a contribution to the docs and see how to pull that in there. But just MPL core is an amazing thing for your project if you want to go into NFTs. That's what I was going to try.
Cool. Yeah, and I mean, you know, I remember when Core really first dropped, and Andre was still working in tandem over at Metaplex and with us at the same time. And he, I remember the workshops he did. Andre, you want to chime in a little on MPL Core?
Yeah, I just wanna add that MPL core is definitely the way to go. At the moment, you can already see that it's having more traction than the old token metadata program. Just the cost of deploy, it's way cheaper. You don't have to create these token metadata accounts, then these master edition accounts. Basically, you don't have to interact with the token program whatsoever, right? So you just create this asset in the core program, and even if you want to transfer it, the ownership, you just change the owner of that asset. So it's not saying that I think it's the future of NFTs. It's already the present, and everyone that it's looking at NFTs, of course, I always say that everyone should learn the way that it was the legacy way, let's call it that way, with the token program. But after that, switch to core because it's way cheaper. It consuming compute units, it's way lower. I remember then just creating the mint and the master edition account and the NFT itself, it was costing already almost 200K compute units, which was insane. And those numbers got lower like quite dramatically with MPL core, and that's definitely the starting to go from ages ago already. So yeah.
Thanks, Andre. And thanks for chiming in, and everybody for chiming in. Anybody else on the call want to share a little bit about what they're working on, or you know, I've got something to kind of jump into just for a couple minutes while our friends from Seven Labs are joining. They should be here any minute. Let me look at the YouTube chat. Yeah. Okay. So, you know, one of the things I kind of wanted to just ask, you know, almost the 500-pound gorilla in the room, which is, you know, getting ready for the hackathon. I know that a lot of people are building and shipping, and I know today is targeted towards a focus on tooling that should help people build their applications and ship them. But one of the things that, you know, I want to make sure y'all are thinking about at this point in time is your actual pitch, your deck, your video, and all of that. Keep in mind that the people evaluating these projects are going to have thousands of projects to evaluate. So you really only have, I don't know, 7 to 10 seconds to get their attention and have them continue reviewing your project. And even though we're focused on the tech side here, I would say that the tech would be the last thing they look at in evaluating your work. And what they're going to look at first is this a good idea? Is it interesting to me? Do I think it will be interesting to others? Do I think people will use this? Do I think a lot of people will use this? Do I think it will be easy for a lot of people to use this? Do I believe in this team? Maybe even before what I just said about users, do I believe this team can execute? So these are things you want to think about when doing your pitch and your video. Most people are building from tech up towards user. You got to make sure you're thinking about your user, because the people evaluating your project and potential investors down the line are only concerned with users, because users return on investment, not great tech. You need great tech under it, but you could also have very simple one function technology that gets a lot of users, keeps those users, makes it simple for them to onboard, entices them to continue using. So I want to encourage everybody to just think along those lines that, you know, what is my user? What's the user experience? How do I keep them using it? And how does that use generate a flywheel that returns investment to those folks that are believing in me as a founder that they trust, that can execute to get this to that mainnet stage where people are using it. And I am not a judge, so I can't claim to say, you know, I've done this. I've judged competitions before, but I haven't judged Coliseum. I'm probably not as objective a evaluator as maybe others, because from Turbine and Turbine grads, we'll probably, you know, we get over 100 products shipped to these things every quarter, and that's only growing with the more graduates that we have. And we've had a lot of people win and so on. So, you know, I just want to encourage you, as you start thinking about your pitch, focus on users, focus on go-to-market, focus on total addressable market. Andre?
Yeah, I couldn't agree more. And I think that you touched the exact point, Jeff. It's that it's not about the tech, right? You can have the best tech out there. If you're not solving a real issue, or if there is no progress, or there is no use case for it, it doesn't matter for you having the tech. And your pitch deck should not focus on the tech. You need to be able to grab the judge's attention by first the one-liner of the project, right? And then what's the problem and how you're solving it. And that's what basically will be able to catch their attention. And then what's your business plan? What's your go-to-market plan? It's not about the tech itself. Of course, in a later stage, it's going to be about the tech. But as Jeff said, first, look at a problem, find a solution for it, see how you can actually achieve your users, how you can actually improve what's out there, or create something new that will actually solve a problem. And that's what's gonna get the judges' attention. The tech comes after that. And again, just another note coming back to MetaPlatform. I just looked again at the numbers so you can have an idea. An NFT with token metadata, the deployment cost will be 0.022 Sol, with core 0.0029 Sol. So the difference is quite amazing, right? And the compute unit usage, it was before we took another 205K around that compute units. I was a lot of times going into the issue that if I didn't request for additional compute units, it was using the 200K default. A lot of times I will run out of compute, and it with core it's 17K. So you can see the difference. But again, going back to whoever is going to the hackathon now, look at it from that point of view. It's basically you're trying to build a product to solve a problem. The tech or your pitch deck is not the first thing that people will look at.
Yeah, and I mean, look, in our industry, there's more great tech than there are great PMF ideas. Okay, so, you know, there's the belief, right, wrong, or indifferent, and I don't know which one that is, that, you know, anybody can build the tech part of a lot of these projects. What people want to see is, and the other thing is this, not what's trendy and hot now as a product. Because most of these projects, you're a year away from mainnet. Most of them. You know, Dark Lake guys, they built that as a MVP in our cohort over a year ago, and they're just now going mainnet. So latching on to something that is hot meta now that could be fleeting and short term isn't always the best idea. You think long term. What long term do you believe people are going to, you know, want to use in this industry? Or take what your idea already is and say, this is how my idea is going to be a long-term, you know, stalwart in this industry. Here's how I'm going to get users. Here's how I'm going to keep them. Here's how I'm going to make them love their user experience. And here's how all of the above is going to create an ROI flywheel for those who believe in us early. It's kind of a little bit of a different mindset than when a lot of, you know, a lot of tech first builders have. But it is something that at least for the next couple of weeks while you're putting together your package, you want to consider. So with that said, hang on one second. Oh, excuse me. We got about 8 minutes until the next one. I also wanted to take a minute and talk about, you know, as much as we want to make this about the whole ecosystem, I wanted to talk a little bit about what we're going to be doing in 2026. Excuse me, at Turbine. So right now we have a variety of programs. And if you wanted to think about the programs that we offer as being like uni programs, I would say our new pre-builders program is like the summer course before freshman or first year of college, first year of uni. Gets you ready, gets you caught up maybe in areas, get you exposure to areas that you may not have had a lot of exposure, even if you have the talent and the skill to do some of that first year uni work. Our builders program is definitely first year university. That is the bachelor's degree. After that, there are at least 3 programs available. One is accelerated builders. One is advanced SVM. Right now we're focusing on bank, which if you don't know, that's where all those MEV products focus most of their energy, you know, BAM and Paladin and Recruit and so on. And then also a research program that Prince and Alex run. So that's kind of your master's. And if you think about a bachelor's program, it's like get your foundation, do some professional like stuff, ship something, learn how to do a project, and learn how to actually do school, learn how to work in this adult environment that's not like your secondary school environment. Your master's is a little bit more experimental. It's more complex. It's more targeted and specific in a content area. And you have to create something that is a little bit more of a novel project. You're looking to solve something that nobody else has solved or that needs open source contribution. And then finally, you have your PhD style programs, which at Turbine is what we call our working groups. We've now done multiple working groups. We had a working group style program for Magic Block. And the idea there is you are creating with what exists something that does not yet exist anywhere. It is fully new creation. And it requires people that are not afraid to build something new that doesn't exist and not know if it's going to work or not. So that's the working group model. PhDs have to go and research and study and connect historical dots and iterate and try and test new solutions, knowing that failing in doing so is actually often much more useful than succeeding on the first try. But from a personality standpoint, there's a lot of people that will not succeed on the first try and be frustrated. That's not, if that's you, the working groups are not for you yet. We also did a GILL working group, and you'll hear from Logan shortly on the output of that. But the whole idea there was we're going to build something out of these pieces that doesn't yet exist. And then probably our most successful working group is our Pinocchio group, Pinocchians, where everything we've done there did not exist prior to us building it. And most of the time we've been building with Pinocchio, it was not yet audited or considered, you know, useful yet. So in 2026, we're actually going to more formally structure Turbine to follow this path. So people will have an opportunity to select a major of study, in which case we'll give the schedule of courses to do back to back. And there'll also be some elective courses, short 1 week, 2 week programs where you could follow a deeper dive into some interest areas. So that's what's coming in 2026. But what's coming right now is the guys from 7 Labs, who are the builders and maintainers of Carbon, are going to walk you through a workshop session for the next hour or so on their tooling. So I'd like to welcome Kellyanne and Nicola. Thank you guys for being here, and the show is yours.
Hey guys, thank you so much, Jeff. Thank you, Turbine in general, for all of the education you've been putting out there. Like, it's been crazy to me to see like this last year in the ecosystem, like how much people have gotten more and more interested in developer tooling. Like we've really seen crazy things when it comes to tooling, and on Solana now, there's like too much to keep up with. Like, so it's been crazy, and thank you for inviting. We're going to be presenting. We also have new features that we want to showcase on Carbon that we've just released today. So Nicola will be screen sharing the presentation.
Can you see it? I think it's being shared right now.
Yes, sir. We got it.
All right, go ahead.
Great. So we're going to present Carbon. So for those who don't know, Carbon is an open source framework for indexing data on Solana. So we've been building it and maintaining it for about a year right now. So we have new features to share today that we'll do towards the end of the presentation as we go through the demo. And like for some background, we're a dev shop on Solana called 7 Labs. And so we've been helping projects for like 2 years. We only work on Solana. And so when we did that, we did notice that there was like quite a gap in tooling for building indexers. And so that's why we went that route. We found that there was a lot of pieces of code that we kept like rewriting for clients. So we built Carbon, and let's get into it. So for those that are like on the newer side to like blockchain in general, you might be asking yourself, like, why do you even need an indexer? And so the reason is you cannot build like a production ready application just off of the Solana read layer, because if you only use an RPC, you're not going to be able to query enough of your accounts. If you have a bunch of accounts, you're not going to be able to have proper like activity feeds. It's going to be too expensive, too slow. And so that's why you actually need to index. And like most application developers, what they really want is to just have all of their data be in a database. So I want to like plug in my RPC, plug in my IDL, and then by whatever magic, I just want my accounts in Postgres. And so that's what we really try to focus on achieving. So Nicola will get into the technical like overview of like the framework, and after that we'll get into a demo. We'll showcase the new features, and then we'll get into the code a bit and like how each of the parts of Carbon work.
Okay, guys, so let's look at what Carbon is. So you can look at Carbon like a pipeline, and it consists of 3 things. And basically, it's a data source, a decoder, and a processor. So what a data source is, it listens to the blockchain and feeds you data, right? What a decoder does, it takes the raw data from the data source, parses it, and then makes it readable and understandable. And lastly, a processor, well, that's basically anything you want. And most of the time is going to be writing to a database, right? Triggering something, sending notifications, alerts, analytics, or yeah, basically any custom logic that you might need. And so once you put everything together, you have the pipeline, you have Carbon, and you have an indexer that's complete to and ready to use. So for data sources, what are they? As I said, they feed the Carbon pipeline with account and instruction updates from the blockchain. We currently have 9 data sources published, and you can basically split them into 2 parts, real-time and historical data, I guess data sources. And so for real-time data, the data source that's most often used is the Yellowstone gRPC, right? And it's used for real-time account and instructions processing. And similarly, there's Helios laser stream, and actually that's the one that Kellyanne is going to be using later in the demo, so later in the call. And if you're needing to grab some historical data from the blockchain, you can get some Solana RPC methods, which basically use get program accounts. We have a data source for that, which is going to be fetching all the accounts that exist for the program on the blockchain right now. Or maybe you need some old transactions, you can use the transaction crawler. So it's going to be fetching transaction signatures from the past and feeding it to you in the pipeline, right? And so what a data source is just a Rust trait. And basically anybody can make a data source, anybody can contribute a data source, or anybody can make their own custom data source because it's just a Rust trait. The next part of the pipeline is decoders. And so they do the magic of deserialization. They take in the raw data and return parsed accounts, instructions, which you can operate on as you wish. And then later we'll see how we can make them easily for any program, basically, even your own. As you can see, they're also just Rust traits, so they're easy to implement if needed. But yeah, as I said, more on that later. Because we've been maintaining Carbon for a year now, we've encountered with many of the big Solana ecosystem programs, and we've been generating and maintaining them, for a year. And they're all published as cargo packages, which means you can just import them easily in your cargo project, Rust project, and start using them right away. And you can see, I guess, some examples of what we are maintaining right now. However, there's another thing which you might do, and that's wanting to build an elixir for your own program. And that's where the Carbon CLI comes in. And it's you can generate your own decoder for your own program using the Anchor or Codama IDL of the program, right? Using the Carbon CLI. And it's basically an interactive and easy to use CLI that takes in an IDL and just builds the decoder. And as I said, again, more on decoders later when Kellyanne does the demo. The last part of the pipeline is processors. And basically, this is where the logic of your app should be. So here you have all of the account and instruction data ready. And basically, you're free to do whatever you wish with it. Whether it's simply to just store it in the database, or do complex path calculations, stream data somewhere else, basically whatever you need. And we can see a simple example of a processor being implemented here. And it's going to be a pump fund processor. And you can see here you can match against what instruction type is coming to the pipeline from the data source and the decoder. And using the decoded types, you can just do custom logic for each of the instruction types. Like for this example right now, it's only logging, right? So because it needs to be concise, but anything you wish can be written here. And then scaffolding, I think Kellyanne will handle it from now on.
Yeah, so that is actually the new feature that we're releasing today. You're now able to use the Carbon CLI with any Anchor or Codama IDL to generate a full indexer for you. So you'll of course have to choose data source, an IDL, and whether or not you want to persist to Postgres or to enable a GraphQL API. But in basically less than a minute, you just need the credentials to your RPC or gRPC endpoint and your IDL, and you'll be able to have your indexer. So that's what I'm going to be demoing to you guys today. And after that, I'll go deeper into each of the traits in the Carbon framework. So let me start my screen share.
Turn it off first, yeah.
Yeah.
Okay, I think this is good.
This should be good.
Yep, we see it.
Okay. Yeah, so we've just released 0.11, and we've released our CLI. So this version is basically what enables you to do the scaffolding. So feel free to give us feedback. It was 7 hours ago, so still very early. We are happy to change the API and to overall collect feedback on everything. For this example, we're actually going to be indexing the Pump Fund program directly because it's well known, and I think it makes sense for a lot of people. So here we have an IDL in this directory, and I'm going to be able to use the Carbon CLI directly to scaffold the project. So the project I will call demo. My IDL is in idl.json. It is an Anchor IDL, but note that it works the same way because we're actually converting our Anchor IDL to Codama, and then we have a Codama renderer that does all of the rendering to our decoder implementations and Postgres implementations, even GraphQL implementations. So Codama here is it's to prove that Codama is actually a very good piece of dev tooling because you can generate a bunch of stuff from it, and it's actually like a universal way to describe your program's interface. I will auto-detect it, and now we will choose Helios laser stream for this example. We will actually dump all of our data to Postgres, and for this example, we won't enable the GraphQL API. Otherwise, it will take a bit too long to detail this part. But as you can see, the indexer has been created, so I'll be jumping into the right directory in VS Code. Here we go. And so here we have everything. So let me wait for Rust Analyzer to pick this up, zoom in a bit. So this is what our workspace looks like. So we actually have an indexer crate and a decoder crate. So these two will work together, with the first one handling parsing your row, account, and instruction data into program-aware entities, and with the second one just being the host of your Carbon pipeline. And this is where the indexing will actually happen, and this is the binary that will be run. So here I need to fill my env. So I should have it in there and be able to copy it. Okay, I don't. Okay, give me 1 minute. I need to fix to put my credentials. I don't want to share them and leak the API keys.
I'm glad you're doing that candidly. It's just good professional practice for people to actually see that.
It is.
Yeah, actually, I thought I had the env and I was going to be able to copy it, but I have probably deleted the file before. But yeah, don't share your keys.
Yeah, the number of people that have in early Turbine cohorts that didn't know the concept of git and ignore and shipping their projects to GitHub. Yeah, had some outcomes that were not fun.
Definitely. Okay, I'm close. Verifying that it's all good. Cargo check is taking a bit of time. Okay, I'll screen share again. Apologies for this. Okay, so I now have my ENV, which I won't share. And so here our ENV has our database URL and also our credentials for Helios LaserStream. By the way, Helios LaserStream is actually an overridden version of Yellowstone gRPC. So most people are familiar with Yellowstone gRPC. Here we're just using them as our provider. So first thing we'll do is we'll run our indexer to see the behavior, and then we'll go through the code and actually like how it works. So I'll set some logs and we'll run it now. So it's going to build for a bit of time because there's a lot of stuff. But essentially what should happen here is that we'll have a table created for each of our account type, a table created for each of our instruction type, and then we'll just start being stream all the account and instruction updates that are pending for the pump fund program on chain. And off of that, like everything will be basically dumped into our DB. So you see this example is like 120 lines of code, and it's all just been generated from the IDL, from the decoder implementations that you can see here. Let's run, we should run a format just after, so it's easier to go through. But basically for each of your accounts, you have some types that will help decode them. And then you also have Postgres and GraphQL implementations for all of them. So this is all generated thanks to Codama. So we should see it run soon now. Since this is a new project, it doesn't have anything in its target. It's downloading everything. I'm also in a hotel room, so the internet could be better. But here it's actually just compiling everything. Okay. Okay.
Okay. I was worried.
It's starting to, it's happening. It's happening. And now it's running. So as you can see, when your Carbon pipeline is running, you'll get metrics. So here, a lot of these metrics are custom to a project, and we'll get into metrics like later on. But here we've chosen an interval of 5 seconds in our pipeline here to be basically flushing our metrics. And here we're just using log metrics. That means whenever the 5 second period ends, all of the metrics are just dumped into the logs. But you also have like Prometheus metrics, and it's a trait also that can be implemented. So here we can see that we already have had more than 1.5K updates that have been processed throughout like accounts and instructions combined. So we can now go to our DB and we should have everything. So let's refresh. You can see we have had a table generated for each of our instruction type, as well as each of our account type. So now if I simply go into my cell instructions, for example, well, I'd be able to, on the right, I have some metadata on when, like metadata on the instruction. So what is the transaction that it happened in? What was the stack height and the instruction index? What slot it happened in? And then on the left, I have whatever field is actually available on my IDL. So you don't have to like set all of the table fields yourself. It will basically all work from your IDL. So that is for cell instruction. But if we look for an initialization, there hasn't been. Let's check buys. We have more there. We could check curves. You see, so this has the token reserves, the SOL reserves of the bonding curve on pump fund, everything that you need that is available on the IDL pretty much. And so this is all being dumped in real time to our database. and we haven't had to write like a single line of code. We just gave it an idea. So if you had a Codama ideal, it works. If you have an Anchor ideal, it works. So that is what it does. Now let's get into how it works. So let's remind ourselves of the three main components of like a Carbon pipeline that Nicola talks about. So you have the data source that is going to be getting the data from the blockchain and giving us the account or instruction updates. Then you have the decoders that are going to go from the raw data to the parse data, and then the processors, which in our case are going to simply be dumping into Postgres, but that could do a lot of other things. So let's just start with the beginning and start with the data source. So here you can see that we're using a Helios laser stream data source. So this is just a crate actually. If we go on the Carbon repository, we can see that we have this data sources folder that has all of the crates. These are all published on Cargo, and you can just import them. And so you can see here specifically we're using this one. And so this whole implementation is essentially subscribing to Yellowstone gRPC, and the result of the consumption is being streamed to our pipeline in real time. So as you can see here, we're specifically choosing to subscribe to the pump program ID. So that means for accounts, we want the owner of the account to be the pump program ID. And for instructions, we want any of the accounts included in the transaction to be the pump program ID. So that's the two filters that we're applying here. And in a result, we're getting all of our accounts and instructions from PumpFun streamed real time. So there are other types of data sources, for example, historical data. A good example that's in our repo, I think that you could check out to start understanding how to build data sources, is the block crawler data source. The options of a block crawler data source is like the start slot and the end slot, and it's basically going to be fetching in batches all of the blocks that have happened in between, and then it's going to be replaying the transactions that happened to your Carbon pipeline. So of course you can filter over it, because you might not care about all transactions that have ever happened during that slot range. But you can see in this implementation that we fetch through all blocks and we just send them to Carbon. So that means you can use Carbon for first getting your historical state indexed, and then you can switch to real time so that you can have like full state integrity and like a full index of your program on chain basically. So if we want to get into actually how you can implement a data source, we basically have this simple trait. So we have two functions on it. We have the update types, which is what is this data source going to be giving our pipeline. So is it account? Is it transactions? As simple as that. If we look at if we look at the block crawler, for example, it's not going to be giving us any account updates. It's only going to be giving us instruction updates. And so that means you could not get your historical account state from a block crawler, of course. You would need to use something different, like a data source that uses get program accounts, so that you can get the current snapshot of your accounts and then feed it to your pipeline so that it indexes it, and then you'd switch to something like gRPC to maintain the state. So that's the first function that you need to implement, that basically tells Carbon what am I going to receive from this data source. And second thing is the consume function, and the consume function is actually the most important. It essentially starts running your data source. So we give you a sender, so that's a Rust sender. So we give you a sender and you can use it to feed the pipeline with updates. So probably a good example for this would be let's use. We're going to use block subscribe, which is an RPC WebSocket data source. And so you can see here we have our constant function. Whenever it gets called, we start by calling an RPC function called block subscribe. So it's actually on the WebSocket RPC. And then whenever we get an update from it, we will basically call our sender so that our pipeline can be fed with the transactions that we're getting. So building a data source is not something that most people building an indexer need to do, because of course, like these 9 data sources can already cover a lot of needs, but we're like always open to contribution on them. So if you have any interest in helping us contribute new data sources, especially on the historical side, we're open to it. And so now after data sources, let's get into what's next. So now we have a good understanding of how we're even getting our stream of data from the blockchain. We're using here our laser stream data source. But now how do we go from this data to actually having everything in Postgres? Well, first we go through the decoder. And this is the part that here we don't even have to implement, simply because we just have to provide it an IDL and our CLI will be handling it. But just because it is probably interesting to understand how things work under the hood, you basically also have a trait which is available in our core crate. And so this trait is for accounts, and you have the same trait for instructions. And so we're simply passing the raw Solana account, Solana SDK account type. And the goal of this trait implementation is to give back a type that is generic. So that means if you're implementing a decoder, your result type would be this type. So that is what you would set as this type, your result type. And then you would just have to get the bytes in here, deserialize them yourself, and you'd be able to return whatever parsed data you want to return. So if we take an easy example here, I think that would be the bonding curve, because it's easy to understand. Let me run cargo format. Yes, it would be easier to read through it. So here we have our bonding curve account. And so we're just using both serialize and deserialize to deserialize this struct. And then we have basically a discriminator that helps us know that this is the right type of account, and that helps us decode this type of account. And so account decoders are always going to be at the program level. That means here we don't implement the trait for this specific type. We need to implement it for a whole program, because then it gives us a very compelling enum of all the types of accounts. And whenever we get an account that is from this decoder, we know we can just match on it and do whatever logic we want to do. So as you can see here, what we're doing when we implement our trait is we simply try to decode with each of the different implementations that we have for each type of account. And so here it's actually Codama that helps us generate this, as I mentioned, because the interface just has everything needed to define discriminators. And so previously we only had support for Anchor. At least we only had a stable support for Anchor. And now we basically can support any type of IDL, which is very compelling because there's been more and more programs being written without Anchor lately. And so writing a Codama IDL for your non-Anchor program is probably something that you should do as a dev, so that then you can use all of the tooling that's going to be built around Codama. So yeah, that is how you build a decoder. But what I would recommend for 99% of people is just use Carbon CLI parse. and then you can pass your IDL, and that's how you get a decoder generated. Or you can just scaffold the whole indexer that we just did, but you shouldn't have to worry most times about actually decoding your accounts and instructions. And so then once it's decoded, we now have access to our data in a way that is easy for us to read. And that is actually the biggest part of the work that we do, because then the logic that you actually want to implement, it varies, right? In our case, we're just putting it inside Postgres, but you might want to send a transaction when something happens on chain. And of course here, it's going to be fully custom logic. So the processor is actually the part that you are going to be implementing most times when you use Carbon. You typically won't spend a lot of time thinking about your data source. You typically won't spend that much time thinking about your decoder, because that's actually what we handle most for you. You will typically spend most of your time writing processors. And so before today, if you wanted to store something in Postgres, and it was such a simple use case as storing database, you had to write it. But we've introduced a new processor that actually is published, and that means you can just pass it. Your decoder generated types, and it will handle dumping all your data in Postgres for you. So I think it's interesting that we dive into this implementation, because it will also help you understand how you can later on build your own processor for your own use cases. So here is our custom processor for Postgres. So this is actually quite a tricky one, because it takes in generics. But what this essentially says is, for all types that implement the Postgres traits that are defined in Carbon, I am able to use this processor to upsert data from accounts or instructions, whatever the type. So you see what you're being provided with is your input, which is the output from your decoder, and then metrics. So metrics I will dive into later on. It's actually really important, but it's a way for you to track whatever has been going through your pipeline, and also to track successes and failures. And overall, it enables Carbon to actually be production ready, and not just a library that you can use to do some testing. Like if you don't have metrics, you cannot use this properly. So here, as you can see, we're just being given our decoded account and some metadata about our account. So like the pub key of the account, the owner of the account, the typical Solana account type that you know is going to be residing in metadata. And then off of your decoded account, you're able to do whatever you want. And here what you see is that we are upserting to Postgres. So that is one example of how you would implement a processor, but there are tons really. There is probably as many processor implementation as there are indexers, unless all you want to do is to literally dump into Postgres. Another good example here that is also a PubFund example would be actually having alerts on things happening on chain. So here, for example, whenever a trade happens that is more than 10 SOL, well, we will log something, but this could be whatever you want. This could go into an event queue. This could trigger a transaction that you send yourself. So as you can see, you just get this data. It's easy to use because it is human readable, and you can do whatever you want with it by implementing this trait pretty simply. So let me still show you the row trait. So it's literally just a process function. There's close to nothing more to it. But metrics. So if we get into metrics, what's good with metrics in Carbon is that they're available all throughout your application. So here is the metric that we're using. So here we're just using a log metric. So that means every time our flush interval for our metrics happens, we will be logging to the console what has happened in the metrics. So these are all of the metrics that are by default inside Carbon. You can see we have the amount of updates we've received, processed, how many were successfully processed, how many failed to be processed, how many are in the queue. Because what if your processor is taking too long? Well, you want to know that your queue has been building up and that you haven't been able to keep up with how fast the chain is sending you updates. And then you have some stats about how long it's been taking you to process in average your updates and a bunch more metrics. So that's for logs. But to be clear, it's the typical way you handle metrics. So you're able to increment a counter, not necessarily those counters, but any counter. You're able to update a gauge, record a histogram. So that is all the trait also. So that means here, what we're doing when we flush is that we log. But if we take the Prometheus one, which is in our repo here, it will just flush it and you won't get any logs. That means you can say it to whatever metric system you have. So this one also has the same implementations. And you can have multiple of them. So you could enable logs and also have Prometheus metrics on your pipeline. So again, very important that you're tracking what's happening inside your pipeline so you're not blind. That means if there are bugs happening or if you're falling behind, you'll be aware because it will be clearly visible. You can tie it to a dashboard, so it's of course even easier to debug. And the way you use it inside your processor is that you actually just call your metrics. So here, for example, I could simply use my metrics object and call increment a counter. And here I could be like, there is a new token that was created. So token created 1. And so what happens is, does this have to be awaited? Yes. So what happens here is my counter will be incremented every time a new token is created. And same thing would happen here for a big trade. So you can just use it as you want. And it's not only like the internals of Carbon, but you can also use the metrics for your own logic. So this is pretty compelling. I think I went over most of how you would use Carbon. So maybe if we have any like questions, I can go through them, and then I can maybe start. Maybe if there are tangents to start on some topics, I can go for it.
I mean, are there any questions at this point in time, either in the YouTube or here in the Gmeet? Go ahead and drop them, and if not, we'll green light to the next. Any? And this is amazing. I mean, I have not seen you guys demo this work and explain.
This is super new. Yeah.
Yeah, but this is brilliant. I mean, super useful, very clean, very intuitive, and easy to follow. And heck, if I think it's easy to follow, that means that anybody with half a brain is definitely going to find it easy to follow. Any thoughts here in the call? Let me check the YouTube real fast.
Jalen was thorough enough.
Yeah, it says what's ClickHouse? ClickHouse would be a very cool feature, especially with how much throughput indexers usually handle. Is that
Yeah, so we actually don't yet have as much data sources as we'd like. So if you're interested in suggesting more data sources for historical data, I think this is definitely something that we're going to be putting a lot of effort in the next few months. Now that we have achieved like the main feature that we wanted, which is you have your Postgres accounts in your database. Now it's more like I have thousands of accounts and I want to get them right off the bat, or I want to go through the transactions that have happened a long time ago. All of these things we haven't built all of the tooling yet. So this will basically be about implementing more data sources.
Yeah, this is really, really impressive. Hold on, let's see what devs get. Okay, yeah, totally. And you actually kind of already addressed my next question, and that's always, you know, what can the open source contributor-minded person do to support your work? And, you know, what's some low-hanging fruit we could send people right off to do right now to try to, you know, support your project?
Okay.
Serve.
So let me screen share for this.
Sure,
again.
of course.
Yeah, so this is our repo. I don't think I have shown, but the most like the low-hanging fruit is helping us add and maintain new decoders. So as you can see, we have all of those ecosystem programs like handled, and so sometimes updates will happen. So we of course have to update them. So that's some maintenance that we're doing, and that other ecosystem like contributors have been helping us do. And if you have a program that you think is relevant enough that it should make it into the Carbon Decoder Crates like repository, then feel free to just open a PR. We have accepted most of them, just because it's actually quite simple to create a new decoder, and it's always helpful for someone to just be able to import a decoder instead of having to go through the hassle of generating it himself and then finding the ADL for it and then having to maintain it. So that's like the easiest thing to do to contribute. And then in general, I think feedback is probably the second best thing to do, especially around like the new feature that we've just like started putting out today, about the API of it. We could probably make it better. Frankly, like, I'm quite satisfied with what it is right now, but we're waiting to get some initial feedback on it. So feel free to try scaffolding an indexer yourself, run it for your program, and let us know if you think it could be better in any way.
Nice. Very nice. Yeah, we'll definitely make sure we get some folks heading over that way to support you guys in what you're doing.
Perfect.
Cool. We good? Any other questions? All right. Oh, looks like okay, we already saw that one. Let me check YouTube, and there you go. Yeah, Tim's already contributing to decoders. There's always updates. Sweet. Awesome, awesome, awesome. All right. Any other alpha for us today?
Thanks.
I don't think so. Like this was the big thing, like being able to get your idea to Postgres. Like I think this has been the pain point for devs for a long time. So just run a command and you're good. Like especially if I think if you're still, if you don't have PMF yet, you want to iterate quickly. Like spending a lot of time building an indexer is probably not the highest ROI activity that you can do, right? So just being able to do it way faster with a command, and then if you need any custom indexing logic for a reason or another for performance later on, you can just go back to it. But right now, like most of your time can be spent on writing your program and your actual application logic, rather than just rewriting the same indexing stuff over and over again. Which actually is, I mean, yeah, it's usually the same thing for most projects, but there hasn't been that much tooling.
Yeah. Well, guys, thank you so much. Really appreciate it. I know you have very busy schedules. It's funny, almost every one of our visitors here today has been in a hotel room. And you know, on the topic of hackathon, folks, if you're gonna be a founder and you know you're serious about this, get ready to be in some hotel rooms. It is a reality. So thank you guys, really appreciate it. Appreciate jamming with you guys. Appreciate the other stuff we're working on. And we will shift gears to our next session, which is Codama. You know, the nice thing about this whole day is that we've been hearing about Codama, and today we've got, you know, FX is here to, you know, run us through Codama. And we're seeing your Discord there, bud. I don't know if you want to see. We see your Discord. There you go. So everybody, you know, I've known FX for a while. Programs. He's massive contributor and, you know, brilliant deep diver. He's not scared of anything. And so when, you know, when getting Lurs in here on short notice wasn't going to happen, FX said, I could do the Codama. And I don't need much more from him than him saying I can do it to have full confidence that he's going to rip this thing. So, sir, the show is yours. Tell us about Codama.
Okay. Check in. Can you guys hear me?
Yeah, we hear you.
Can you guys hear me?
Yeah, we hear you just fine.
Okay.
Cool,
Yeah.
sir.
Okay. I'm trying to share my screen. Okay, so like yeah, like Jeff said, I'm an FX. I'm a systems engineer. I like tinkering with low-level technologies, and like unlike almost everybody that's gone before me, like they are the maintainers or users, like the owners of the projects they talked about. So, but like one of the reasons why I hopped on this was because like a lot of the times with a lot of like these geniuses that make these libraries and repos that we tend to use in the ecosystem. If you're like me, sometimes a lot of things fly over your head, you know, like there's a lot of discourse in how Kit is difficult to use, how Umi is difficult to use, how e.g. Kodama is difficult to use. So like I just spent like I think a few hours this week just like going through Kodama code base, and like I'm just here to tell you like what it is, what it does, how you can use it, and like what else can you build from this? Like how can you build on top of it? Yeah. So what is Kodama? Kodama is like it's like a language agnostic representation of Solana programs. And what does that mean? That's like a mouthful, right? But like it's just basically a way for you to kind of like represent your program, which is written in Rust or C, but mostly Rust, in a way that we can kind of like interact with your programs with multiple languages. So that's what language agnostic means. It means that like it's not really like a language centric representation. You know, like when you have structs, those are Rust centric representation of like an account, you know, stuff like that. But like Kodama is just basically like a representation, something like Anchor IDL. We'll get to that, but like just like a representation of how your program is, like the instructions, the accounts, the functions, like basically almost everything that you would need for a program, just like a representation of that. And like while I was preparing this slide, somebody was like, "Oh, but like Anchor IDLs," like, and I was like, "Yeah." And I originally had the thought when I was like going deep dive into like Kodama, and I realized that Kodama is just more than what just meets the eye. And then like, yeah, I'm happy to share most of my thoughts and most of my knowledge over the past week with you guys. So yeah, why Kodama? Why can't we use IDLs? You know, like, or if I have like an Anchor program and then my Anchor program spits out an IDL, why can't I just take that IDL and just like create a client for it or a wrapper around it that basically I could just like replicate across different languages? Like that's easy, right? Yeah, it turns out it's not that easy. You know, like whenever you're trying to take a lot of the things that a lot of the reasons why we don't typically see how difficult it is to do this stuff It's because like we're always writing languages. We're always writing our clients in either TypeScript or Rust. You know, so like with Rust, fairly easy. The program is actually written in Rust, so the program is even the client. But in TypeScript, there's a lot of tooling in the Solana ecosystem that just basically allows you to interact with like an Anchor IDL. So a lot of that friction is abstracted away. You know, so like the problem with IDLs as like a point of representation really starts off when you start having to write like clients in Python, in Golang, all these other languages that are mainstream, but not really like officially supported by like for Solana Foundation or like even like the devs in the ecosystem. You know, so like what exactly was wrong with the IDL and why did they build out like Codama? And I'm just gonna, so I had like a code like first of all, IDLs are really bad at like safety. So like whenever you're writing like clients with IDLs, like because like you basically see like an IDL JSON being passed to like a TypeScript type, like a TypeScript. So you have your program and it's basically like synthesized into like a type, you know. So basically you have that kind of safety from TypeScript. But that's just for people writing TypeScript. To the large population of people who are writing Python, there's actually no safety. You basically just write code and you just hope, you know, cross your fingers and hope that at the end of like a method call, there's actually the method and it actually takes the arguments that you want it to take. You know, so like you're just really YOLOing your way through whenever you write like programs, whenever you write clients in other languages. And Codama, like an Anchor's IDL is basically just that. Like it doesn't really prepare you for it's not really like the best interface when you want to write in other clients. And we really don't see a lot of it because, or acquired, like we really don't see a lot of it because like typically we write in TypeScript, you know. So like, yeah. So this is just like Anchor IDLs is just basically data. There's no structure enforcement. Everything is optimal. Exactly. That was kind of like this is kind of like a segue from what I was talking about before. It's kind of like almost everything is optional. So what's it breaking? So it's not strongly typed, which is something that we inherit from TypeScript. It's not and Rust. Anything goes. I can add any field, and it's just basically like break the entire class or method. You know that. And like operations are ad hoc, and you just have to hope. Like I said, like you have to hope that somehow the structure you're seeing is like what you're going to expect. So you're kind of like YOLOing. And you know, when you're writing production ready code, you are not supposed, this is not supposed to be like that's not how you're supposed to interact with it. Everything has to be like kind of like deterministic. You need to, the computer always has to respond to one if you expect one all the time, you know, that kind of stuff. So like Anchor IDLs are typically bad when it comes to like representing them or like a point of truth for like multiple languages. So what did Codama do? So Codama kind of like, and I was trying to create like a tree-like structure to kind of like explain this to you guys, but I'm really, really bad at Figma. So like, I'm just gonna try and share my screen to the Codama repo. Jeff, is that okay? Is this something I can do?
Yeah, I know, absolutely. I love that. I think this is the way folks have done it this way today, and I think it's definitely the most developer appropriate way.
Okay, cool. So yeah, Anchor, I said Anchor. Codama basically has a, let me get it for you. Yeah, so a Codama IDL is basically, instead of just like a flat data structure, the same way, like the way we have Anchor IDL, it's just flat data structure, instruction, accounts, errors, you know, stuff like that, the regular stuff we're used to. Codama's IDL is a bit different, and like they represent every data type, instruction, account with like a node, like, and that node is basically like it's supposed to take all the possible states of that particular aspect of the IDL. Now, what do I mean? So the root node basically is kind of like the experience, and it points to the program, and the program basically points to instructions, and instructions points to the account, and accounts points to like the data type, you know, like they call it like the struct type, and the data types that can be like used for public key, you know, the regular types are used in like Solana ecosystem, and then they have the instructions account node. And why did Codama basically build this kind of stuff? So turns out Codama was built on like pure types. What are pure types? Pure types are just like the pure representation of a data set or a data structure in computation. Like, and it's not like just Solana centric, like everywhere. So like Codama is basically like, okay, this is like an an unopinionated structure or representation of your program. Go build the methods. And when you have like, why you have like in let's say let me try and pull up and why you have like say you have like a, what's the word, like an anchor, like an anchor idea, or basically like when you're interacting with it on TypeScript, you have all the methods, like your instructions are being set like method calls, and you can just program.method.initialize. Anchor Kodama's idea is basically say, oh no, we're not doing that for you, go do that by yourself. But we're going to make sure that we give you everything that you need to make those your clients safe, safe to write. So like a typical Kodama ideal is kind of like how am I going to put it? It's kind of like a tree-based structure, So like that stuff basically flew over my head like multiple times. So I'm gonna like take my time to go into just that, like what is like a tree-based structure, and then we're now going to go into like why that is better than like the flat structure that Anchor ideas basically like went with. So yeah, a tree-based structure is like a tree basically is a data structure that consists of a parent and child, like that both interaction themselves like in a hierarchical manner. And what does that mean? It just basically means somebody has a parent, and that parent has a parent up onto the node, or up onto the root node. So like the traditional approach with Anchor clients is basically, oh, you have an instruction and instruction, like you have a program and program has methods and it has an account, and then you can do some stuff with the account, maybe like read an account with clever methods to read from the account. It's tightly coupled. You can't really like extend it without modifying the core. And every language, if you try to like push that into languages, you have like every language needs core changes. And at the end of the day, you just realize that it's kind of like writing on Salesforce. It's kind of like no one is there to help you out. No one is like you. It's basically you, and you have all the response. You have to take on all the responsibility for like basically every modification you make. And then Codama has an approach where they have like pure data types, and those pure data types, like an instruction node, that is basically like, oh, okay, it's like I have a struct because I have a struct, and they like this struct is an instruction. Okay, what does an instruction take? What kind of node is this? This is an instruction node. What is the name? Is an instruction, like what's the name of the instruction? Say like initialize. Does this initialize take any counts? And typically you see it with like, when you're writing Anchor, you see CTX. And CTX is basically like the context for all your accounts that are going to be passed in through that particular instruction. So Codama takes this inside, like it takes this into account. It's like going to be like accounts, and like how many accounts are there, and it basically has to list it, and it does that up until when you get like the final children or the final accounts at the bottom of the instructions. And then what you realize is that like with these pure data types, anybody can write generators, and there's like no need, there's no permissions. Yeah, like there are no permissions needed to like extend. You basically take these data types, and like every language has its own representation of like an object, maybe like struct, whatever. Like you can basically take these unopinionated data types and just like put it in like say like a language like Python, or Golang. I'm thinking about languages that are not really popular in Solana ecosystem. So like you typically like you just take it like languages like Python and Golang, and then since you have all the safety in the tree structure, you just basically write your client with all. So think of it like a compiler, exactly. Like you think of it like a compiler, and like that compiler, these tree structure is like a compiler that is guiding you, making sure that you do not make any kind of like, you don't make any logical errors, in a sense, like you're being within like safe zone, you know. And then you just realize that it's kind of like how am I gonna put it? It's kind of like the Rust compiler when many people can write on C++, many people actually do write on C++, many people write C, you know, and like, but then it's like kind of like a responsibility to keep up like with the safety and everything. And like this tree-based structure is kind of like what you need for like devs like you and I. They are not really geniuses to basically take any program and then port it to like a random language, like a random language as a client, and then be able to like basically call, write, or read Solana state based on your contracts, the constraints of your contract. So yeah, I'm gonna go back to the slide. So yeah, I'm gonna go back. Oh, I already spoke about why nodes. So yeah, what's the real cost of duplication? Like, yeah, and this is like the major question, like, oh, okay, but like if I have a team of engineers, like I can always just like write like I write in all the languages like my community needs, with just like an IDL or an interface, you know. I mean, if we wrote the code, we can basically port it. But then you have to ask yourself, what's the real cost of duplication? What do I mean by duplication? Yeah, duplication is like duplicated efforts. Like it's kind of like the amount of effort it takes to like maintain or replicate a client across different languages and support it. And you just kind of realize that is very, very difficult to do, especially for teams. Where like if you make a change here, you have to make a change across all other clients that you support. And it just felt like, it's just waste of work. It's waste of developer hours. Like my devs should basically spend their time doing some other stuff that doesn't involve this redundant replication of like clients across languages. So yeah, Codama really was built for just that, because you have to realize that the guys that built Codama came from like Metaplex, and Metaplex is like this huge protocol on Solana that like has like multiple code bases and repositories. They have like communities basically interacting with these repositories. You just realize that it's kind of like it can be kind of like tedious for the developers to like keep on replicating all these changes, version 1, version 1.0, version 1.0.1, you know, like across all the multiple clients. What did they do? They just created like this should I say, very, very complex parser that basically takes one state and then replicates that one state into multiple different languages. And basically that's what like Codama is. So how does Codama do it? So Codama takes a Codama IDL structure, which is basically like the Codama tree, and it transforms it with something called visitors. I'm gonna go to visitors like in a moment here, but like just take it at face value now. Visitors like modify the tree and they prepare it for generation. And then the generation stage, renderers just like output the code, like create clients documentation based on the original source of truth, which is the Codama idea. So yeah, how does the Codama do it? Visitors. So what are visitors? So because Codama allows you to write like methods and basically logic that transverses your IDL tree, the Codama IDL tree, visitors are kind of like Kodama's way of making it easy for you to basically write this transversing logic. So you have when you see Codama renderers. So Codama renderers, e.g. Rust, is basically like a visitor, and that visitor is basically taking a Codama IDL and spitting out Rust on the other end, kind of like how you just see how the Rust compiler does it with taking Rust syntax and then spitting out machine code like x86, you know, like basically on ARM on the other end. So visitors are just basically like this, should I say this, I don't want to say tooling because it fits the point, but think of it as like this helper functions, like a bunch of functions that basically take in an IDL and trying to spit out like either a new tree. I don't want to put that because it's going to be confusing. Either spit out like logs, events, or basically like what's the stuff skips my mind. And basically like spits out okay, yeah, writes to Dix, like spits out code like languages like Rust on the other end. Yeah. So while I was like reading through the code base, I realized that there were multiple types of renderers, and I'm going to go into that. Multiple types of visitors, rather, and I'm going to go into that in like in a while. But like, okay, just think of it this way: like, we have to establish a single truth. Visitors take the idea, which is the Codama idea, and they spit out some other stuff on the other end, which can be a Rust client, a TypeScript client, a Go client, or just basically like logs. Basically, visitors visit they visit the idea and they do something with the idea, and basically they change, or they either change the state of the idea or utilize the state of the idea. You get what I'm saying? So there are three types of visitors. There are transformational visitors, and what these visitors do, this type of visitors do, is that they basically output like a new tree. And where does one typically utilize this? So say the ideal is originally written in like snake case, and you want to make all the accounts like, or you want to make all the accounts all the names of accounts camel case. Like, transformational ideal basically takes in the Codama idea and spits out a new Codama idea with camel cases as the account name instead of snake cases. So exactly that's what it does. Like, it's implicit, like it's explicit in the name. It's like transformation. It transforms. You know, you can take accounts. You can say, oh, I want to delete all. What's the, okay, no, that's like side effect. Like, I want to basically take like all the snake cases, all the names that are snake cases, and I want to split out camel cases, because I have in my own backend or in my own docs, I have like, I've already started using camel cases. I don't want to like change everything. Codama allows you to just do that just fine. You know, without any change to the major ideal itself. Just basically use a transformational visitor, and you get like a camel case ideal at the other end, or a camel casing client at the other end. There are also renderers. Like, you have renderers, which is the one that a lot of people are quite comfortable and like we're familiar with. It's kind of like the ones that take a Codama idea and then they spit out like a Rust client or a JavaScript client on the other end. You know, basically by taking all the account node fields, instruction node fields, and then basically doing like should I say concatenation or something like that, the same way you would with a macro. Yeah, Codama is basically doing concatenation and filling it, or like writing, basically like generating code using like logic, you know, and you can see it in when you go into the code base of like these renderers. Then you have accumulators. Accumulators basically collect data from the ideal. So it's kind of like, oh, I want a method to extract all the account names and nothing more. I don't want the account balances. I just want like account names. Accumulator visitors are kind of like the type of visitors that enable you like do that. You see a lot of like visitor pattern in action in like the Codama code base. You basically load your account IDL, and then you can render with a render to JavaScript with a JavaScript. You have like for all the languages that are supported on Codama, they all have visitors. So I think now there's the Rust visitor, there's a Rust renderer, which is a visitor, and you have the JavaScript renderer, which is also a visitor. And you can basically, if you want to score points, you can just basically go there and write your own visitor for like Golang or Haskell, you know, whatever language you feel confident in. Just basically write your own visitors, and you'll help the ecosystem by allowing developers that build programs basically spit out clients in languages that you can use or you can interact with, which is like C or your Haskell or whatever language you want to basically write it. But like the beauty of Codama is that each renderer gets the same clean transform tree. You know, so like so we're going to like how do renderers work? Like renderers basically it transverse a tree, visiting each node. Remember I told you that it's a parent-child like data structure. They generate code strings, they map types, like let's say you U64 in U64 in Rust cannot really be mapped directly to like JavaScript. So you have stuff like big integers, So like if a JavaScript renderer was like mapping all the types, you basically just have like a big int. The same way you have big int when you're using like Coral Anchor, for your JavaScript clients. The renderer basically builds functions and the structs. It accumulates everything in memory and then basically just writes to disk. And when it writes to disk, it's basically the part that you see is like client.rust, client/rust/ you see your Codama generated files. Then at the beginning of the file, you say, oh, this file was generated by Codama, do not touch, that kind of stuff. But like if you know what you're doing, you can touch it, I touch it oftentimes. So yeah, you basically take an example would be taking a number type node with a format U64, and then a JS renderer will format it to will pass it to a big int. The Rust renderer will pass it to like a U64 because Rust supports U64 types. A Python renderer will just like pass it to an int type because Python by then doesn't have like those U64 like those very very memory data primitives exactly. So yeah, I think that is basically all going like a speed on how Codama how Codama does what it does with visitors. I guess I wanted this to be like a very interactive session. So like I tried to like speed through what Codama is, and I'll just like take you guys' questions. I'll try the best of my ability to like answer all the questions that you guys have. So yeah. Before I do the demo, I want to hear like all your questions, and then I'll just like answer them, and then we can just move on to like a demo using like Codama. Yeah. So anybody have any questions?
Yeah. Any questions from YouTube or in the Gmeet call? Anybody?
I can't see YouTube.
I got the YouTube right here. I'm watching it for you, and I'll relay the question.
Okay.
Any questions or anybody in the chat? W for FX. Yeah, I agree. That was great. Anybody in the chat? I mean, I think we might be ready to just demo. You want a demo? Let it rip, man.
Sure. Okay. Yeah. So let me try and get like a contract. Do I have any contracts? It's kind of messy because I tried to not plan before I do this kind of stuff. So you guys kind of would know that, like the full end-to-end process of like what it takes to do this. So you might see a very messy demo. It wasn't planned, but then any bugs you see along the way kind of like can just basically take that, and then whenever you're doing your version, which is going to be realistic, the realistic version is that you're going to see bugs, you're going to see errors, you're going to not have some CLIs installed, so like my process is going to like take as many errors as possible so that you can just like replicate it on your side. So let me try and see if I can share my screen.
Yeah, I think I mean, look, you've heard me say this before. I think it's great to do the raw rip. I think there's a lot for people to be able to see the actual process by even the best of them.
Yeah.
Because it is a process, and it is inherently messy, and it's less messy when you've done it enough to have strategies to go.
Yeah.
Yeah, exactly.
Okay. Try and share a window. Let me just do my entire screen because I can't find the window. So yeah, after we have Codama installed, typically when you want to install Codama, you do pnpm.
Okay, so
install.
okay, there we go. I was just waiting to
Yeah,
see it.
can you see? Can you guys see my screen?
I could see it here. Hold on, let me make sure it's up. There we go. Yeah, it was just time delayed on YouTube. You're all good to go, sir.
Oh, okay. Okay. So yeah, when you want to install Codama, it's just basically like a pnpm install command for literally Codama, you know. And I have Codama installed. Well, already up to the. Okay, no, that was just a running. Like I already have Codama installed. So if I write Codama, yeah, you see it's already installed. And typically what you want to do first for a typical, this works perfect for like an Anchor program. It's almost like it was built for it. But this is like an Anchor workspace that I'm currently working on. I don't want to show you guys the keys because it's actually like going to go to production. You know, but this is like an Anchor program that I'm currently working on. And then like if I wanted to generate like client for this program, I'll just type in Codama in it. And then it basically, oh, where exactly is your ideal? And then my ideal is it's at targets, the target folder / ideals / stakeholder. So yeah, so it asks me, do you want to generate a JavaScript or a Rust client? So let's go with JavaScript. Let's see JavaScript. Where do you want this code to be generated? The 5 parts, client / JS / source, then generated. And where should the Rust client be located? There actually Rust client. You know, where should the Rust code be generated? Cannot read package.json. Path package. Oh, okay, yeah, that's exactly. I'm not in the directory. Okay. What? Oh no, CD program. Yeah. So let's try it again. Because I'm not gonna write. Yeah, so the same 5 parts. Same stuff, yes. Yeah, and just like that, basically gives you like you say like a config file, and then this config file is basically like a script of how the pipeline process. Remember I told you guys that it was basically a tree, then there's a process, there's a pipeline, and then you have like your final Rust client, Vixen parser, whatever it is. You know, so like this is basically like a script, and this is like my JavaScript script, and you can see it's utilizing the Codama renderer. I think we should go into that just a little bit. And then the argument is that, okay, this is where to spit out to. This is the create folder, and then should the code be formatted? So what you need to do is just, once you've seen all this stuff and you confirm that, oh, okay, yeah, this works for me, then you go do Codama run. There are no scripts before visitors to run. There are no scripts for visitors to run. I have this program. Let's go check. Let's go check the oh, okay, yeah, I'm missing. I have to indicate the script to run with like the / command. So Codama run. Let's do all. So the all will be my both the JS and the Rust. So let's do all. And yeah, exactly. And just like that, I didn't touch any line of code, and I have my entire program auto-generated. And basically, I can plug this into any backend and basically interact with my program. You can see Solana Kit here. The reason why it's crying is because I don't have Solana Kit installed in this particular directory. But if I just do npm install Solana Kit, it should work automatically. You basically see all your types, even with the anchor discriminators, everything like pre-generated like you wrote it, you know, like it's just generated like you wrote it, you know, and you can just like plug it into anything that you or just basically do with this like how like an SDK. You can basically work with it the same way you would work with like a Rust client or like TS client written from scratch. But like what I want to see is like I want to see probably somebody, one of you guys, who do this for like Golang or C, you know, like fun. You know, it's really like one of the best ways that, in my opinion, to learn is by actually doing. So you get messy, you do it again, until you really understand what is going on there. You know, so but like, yeah, just that one command, like just spits out a JS and a Rust client for me to like interact, like for me to interact with. And that's basically the beauty of Codama. Like if you try doing this with like Anchor, it's going to be very, very difficult because like there are a lot of things that you can do with that code, with the scripts that you can't really do with Anchor because Anchor type is very really built for that level of transversal. And then like I guess there are multiple places that you can contribute to when it comes to Codama. I want to see like guys write Codama visitors for like MCP servers or GraphQL servers. You know, like take an Anchor, like basically taking an Anchor program or Solana program that you just spit out on the other end, like an MCP server or like a GraphQL server. You know, like multiple different ways that you can use Codama than what probably even the guys were thinking about. You know, someone can, oh, you asked me for the font size. Sorry, I didn't see that on time. Yeah. So like, yeah. So basically, just like I want to see like guys write their own renderers from like Turbin class. You know, like if you guys need any help, you know, I know Golang and I know C. So like yeah, that I want to like basically build their own renderers, trying to understand like the visitor model. My DM is always open, kind of like your classmates. So like, you know, like if just drop a tag for like in the advanced SVM chat or general chat. If I see it, I will respond. But like if I don't see it, don't hit me for it. You know, so like yeah.
Awesome.
So yeah, I guess that's all I have to give. I hope you guys really enjoyed the session. It was a bit of a, you know, it's scruffy, but you know, like then again, I'm going to be going head against guys that built their repos from the ground up, and like Loris is a genius and I'm not. So yeah.
Yeah, I mean, look, seriously, my friend, do not sell yourself short. You know, you did an excellent job, and you are always doing great stuff. Really proud of you and appreciate you stepping up and doing this session with us. And we are, you know, if you believe it, we are up to the final session of the marathon. Not gonna lie, took me 2 large Diet Cokes to get through it. And but you know, we got something special for you again right here, because we got Logan coming up with the GILL SDK sharing of what we've been working on and what really he's been like cranking on with some teammates. We started this GILL working group probably about 6 weeks ago, and the mandate was, can you get a bunch of JavaScript people together to help? And that's kind of what we started with, and we really spent probably the first 2 weeks really figuring out what does that actually mean. And you know, but once we gained a little bit of momentum, we made a lot happen, and Logan really took on the developer experience part of it, and he killed it. So if you don't know who Logan is, you should. I hope he shares a slide with his Twitter handle on it for everybody, and if not, lets everybody know. But this guy and the people they work with did an excellent job, and so here's Logan with GILL.
Okay, thank you very much, and yeah, thanks everybody for sticking around. I think this is a good thing to end on. So you have your Solana program, you've tested it with LiteSVM or Surfpool, and now kind of last step is to create an app that uses the program. And GILL is designed to make it easy. All right, so just a quick background. I'm a full stack backend software engineer before joining Turbine. Earlier this year, I was in the builders cohort, and I'm currently in the accelerators. And like Jeff said, as part of the GILL working group. And a lot of what we did was creating GILL documentation and developing additional features on top of the GILL SDK. And actually, when I was a full stack developer, I used the old predecessor to GILL. So I've been able to see like how we're solving all the pain points that GILL is making a lot easier, and definitely helping a lot of developers. All right, so I'm gonna do a kind of a quick intro. Like people in Turbine might have had the presentation from Nick Frostbiter, who's on GILL, one of the founders. But I'll give a quick introduction and then go into a lot of the stuff we've done in the GILL working group. So to start off, what is GILL? It's a JavaScript TypeScript framework for building Solana applications. So you've got your program, and think of anything you're going to build on a JavaScript stack, you can use GILL. So React, Node, React Native, it should all work with GILL. And it was super interesting to learn about Codama, because so you have your Codama now, you need to use it in a client. GILL is made to integrate with Codama, and some of the work we've done was trying to create new ways to use Codama. So I'll get into that in a little bit. Okay, so some quick background. So before GILL, there was Web3.js, then there was a Web3.js version 2 layer named Kit. And so it's important to know why we're using GILL now. So when I started building front end, I used the original version, and the Kit, it seemed like it's an updated version, but really it's not. It's a complete rebuild of the original Web3.js. So the original one was made, I think, over 5 years ago. And as time went on, developers surfaced a lot of issues. So this is some of them here, like heavy bundle size. You'd have to kind of import everything into your bundle if you're only using a few functions. There's no tree shaking. And it didn't use any modern JavaScript. So there's lots of security issues, like just not using modern encryption. Key pairs were extractable by default. So if something on your browser found your key pair, then you compromised. So GILL was made to fix all these issues. And I linked a YouTube video of a breakpoint presentation of when Kit was introduced. So if you have 20 minutes, it's really cool to go into a lot more details about like all the improvements they fixed and like what went into it. Yeah, this is just a screenshot from that presentation. That was cool. Just visualize what tree shaking is. Like basically, like there's all these methods that you have to import, but with Kit, you can only import what you need. So there's tons of stuff here that I don't know what they do, but yeah, highly recommend it. And also go into the security a lot. Improvements in the presentation. Cool. So enter GILL. So we just had Kit. So what is GILL then? Well, GILL is built on top of Kit, and it was made to be like the developer experience layer to make things a lot easier. And it's lightly opinionated and uses, and you can still use Kit's low APIs. So there's utility functions, simplified transactions and creating clients. and something called flexible abstraction, which I mentioned to go to these low-level primitives. So again, the reason to do this is to reduce boilerplate, decision fatigue, and slower development if you were using all low-level programming. So Kit improves on all of this. All right, now just going through some examples. So this is, actually quick note, this is from the cookbook. It's newly on the Solana.com cookbook page. So if you go there, you can also see these examples if you just Google Solana and its cookbook. So thanks to a bunch of other people on the GILL working group to help get all these examples added. So anything that uses TypeScript will have a GILL example next to the Kit one. And so this is just the basic connecting using an RPC. So basic things you need to do when you're creating your application of your program, connecting blockchain, building and signing transactions. GILL exposes this create Solana client function, which when you're developing use a lot, which gives you these three objects, the RPC, subscriptions, and send and confirm transactions. So very, very easy to get all three. And if you just toggle over to Kit, you can see that you can still do the same thing, but for each one you have a factory to create it. There's a lot more boilerplate. So this is what I was talking about when kind of like more overhead. So GILL kind of fixes this to make it so you can do these in a lot less lines of code. And quick note, there's also a reference on the lower right. This is from the GILL SDK site. So it also has comparisons. We moved a lot in the GILL working group into the cookbook, but there's still some that were not represented. And I think as a future work, we could potentially introduce a lot of these new examples to compare. And one more thing, like, so even though this is done with Kit is basically imported into GILL. So everything, if you change this import to GILL, it will still work. Everything you can do in Kit, you can do in GILL. So that's what I meant by you can always have this escape hatch. Like if you need to do something in Kit, you can still do it in GILL. And this is another example of loading a signer, is an example of one of the helper functions to make things easier. With Kit, this loads a keep your signer from file from your default file path, which is Solana config ID. And you notice the import is to GILL node, which is kind of like node content means anything that's server side. So again, this separates the packages, so everything's more tree shakeable. And another benefit is if you try to use something GILL node on the client side, you deliver it with an error, and you know right away that that you'd have to fix something before trying to actually run the code. And Kit, you see, like there's no helper method here, so you could resolve the path manually and drop the keep here. So GILL is just one of the things that just reduces that overhead. To go back, you just have to do a lot more simpler with GILL. And okay, here's another example. I'm gonna link the resources below on the bottom left of where we add this to the cookbook. This is for creating a transaction. And GILL, you can see here what I mean by like a lightly opinionated. So there's a create transaction method that you get from that create Solana client. You see what you need to pass in, and array of instructions and compute limits. So easy to see, easy to read. And if you're developing on, toggle over to the Kit example. Here you see like a much more detailed way of creating a transaction with the pipe method. You can see it's doing the same thing, but in much more verbose and much more lines of code. So this is kind of what I meant by decision fatigue. Like if you look at Kit, basically just by glancing over, you're trying to find an issue. You can see exactly what this function does, but with Kit, it's a lot more verbose. And again, like if maybe you're doing something more complex and you needed to use pipe, you can just change all these imports instead of Solana Kit, just GILL/Solana programs, get the program methods, and you can still do the same thing. So in my opinion, right, no reason to just not use GILL where it has all those abstractions you could potentially use. All right, and yeah, so I've been kind of mentioning all these examples. So again, there's the official GILL docs. It has these high-level comparisons, and the GILL repo has some detailed ones and kind of more, I guess, still fresh in development, things that can be done, which maybe eventually we'll, at the working group, can try to move to front page of Solana to kind of surface and make it easier. Things like builders for minting tokens, token transfers, are in the Solana cookbook. And also want to mention that the create Solana adapt. So if you're creating a fresh project, you can get a template, and it'll include options for GILL and Codama, I believe, the new versions at least. But I'll go into those in a bit. Cool. So yeah, I just want to show you like this is from Solana.com. There's all the cookbook examples. So if you're developing something for the hackathon or something, want to know how to do something, I guess for me, I think it's a good place to start. Like all these basic things how to do that. All of them that have Kit should now also have GILL as an example. So this is fresh. So if there's anything you see, any issues, let me know, or anything you think that needs adding. Since we're rolling, we can add things quickly. And shout out to people at Solana Foundation for reviewing those PRs quickly. Okay, this is going back to the more advanced examples within the repo. Like these are kind of buried in the readmes of the GitHub for GILL. Minting a token with Kit. Again, this is how it's done. And GILL, they have a comparison example, which again, it's just light level extraction, makes it easy to read, just top level. One thing is this doesn't have the ATA here, like in the Kit one. I think I took out some lines of code to derive the ATA, which you have to do boilerplate anyway. But I believe like this helper function is built to just make it easy. Like, you know exactly what you need. It does. I believe that getting the ATA does within the method. And there's a bunch of examples like that if you're looking for more advanced stuff in the time being. But yeah, I think as part of working group, that's something we're working on, like surfacing and making known. And okay, so those are the examples. Now, there's also other packages within the GILL repository. A lot of stuff we did in the working group was working on the React package for GILL. There's some other ones like Svelte, but Vue, but React is the one we're actively working on. It's built on top of the Tanstack query. And there's some hooks, and yeah, a lot of hooks is what we were working on developing there. It's just a list of some of the already existing ones. So kind of lots of useful stuff if you have a React app and you want to create a more interactive experience and handle all the asynchronous data. Use count, use balance, and here's just one of them, use token account. And so if you're not familiar with Tanstack query, it's a very heavily used library, but you can see it exposes these variables for you, like is loading, is there any error message? So this makes, when you're developing a Solana dApp, just getting this information after like you signing transactions, getting data, makes it very easy to handle all this asynchronous data. And oh yeah, I also want to touch on the create Solana dApp. You see, yeah, so if you want to start from scratch and you're creating a program, you want to dive in, there's a bunch of examples. And yeah, I think I checked this maybe a couple weeks ago. I think GILL was kind of like, it said beta or something next to it, but now it looks like things are moving fast. It's just like on top now on the default. So yeah, it comes with GILL and I believe Codama as well. And this is a snippet from a template. So if you're really diving in, want to just see how you can use GILL, and especially with Codama, this is getting from the Codama client, just pulling in some of the information. But yeah, this is just like a top level to start diving, like to see how it works. You can see it within the code. But we are actively working on it in the GILL working groups, just adding more React hooks to easily use Codama. So maybe in a couple weeks we'll see some of that. All right, so yeah, thanks y'all for sticking around and listening. So this is the resources here that I use. Basically, like the cookbook is what we just developed. Be adding to the SDK in comparison. So as we're doing like the more newer stuff with React and deploying it, it'll probably be there first before we push it to the main page. Yep, any questions? There's my Twitter handle.
Great job, man. Any questions here in the actual call or in the YouTube? Let's take a look over here. There's some funny ones in YouTube.
Oh, let me check it.
Or tongue in cheek. Yeah, great work. I mean, look, you know, Logan's really been a leader in that GILL working group, but there's been a number of folks in there that have really contributed a lot. Inspiration and Nariman and Williams and Raul and you know, I'm gonna miss people, but the groups worked really well together. Really thankful for Toby and Kat and Guy. You know, Toby and Kat really led the way in helping guide and craft there. So tremendously grateful to them. But Logan, you know, you really stepped up and did a really, you know, you took on the hard work of leading when there really wasn't a lot of direction in the early stages of it and stuck to it. So really appreciate your work. And, you know, to your point, we're just getting started with this stuff and GILL is getting to a place where it's going to be very useful, even for the people that don't like JavaScript. And more so to the people that do. So, you know, it's hard to believe that we've been on for close to 8 hours. So I just want to, you know, thank everybody. Thanks all the facilitators. Thanks to Brianna for, you know, hanging around and jamming with me a little bit. And, you know, to all the people on the G Meet and all the people in the YouTube, appreciate everybody. With that said, we will end Toolapalooza 25. Stay tuned for what's next, because there's always something next. But for me, what's next is a little bit of food and a little bit of a nap. But I hope everybody has a great rest of your Saturday, wherever you are in the world, and great rest of the weekend. And, you know, we'll see you back in the grind on Monday. Have a good one, folks.
Bye, everyone.
Good night, Jeff. Might be a good idea to actually have a dream. See y'all.